Welcome to Sharp Economy, the social fi platform empowering creators, communities, brands, and businesses. With tools like Contribute to Earn and Spend to Grow, we reward participation and put your skills on chain. A decentralized ecosystem built on Web3 principles, where transparency and ownership truly matter. Sharp Economy stands on four powerful pillars: the Sharp platform, bringing Web 2 to Web 3; the Sharp token, fueling growth and rewards; the Sharp Rewards app, where you learn, earn, and grow; and the Sharp Innovation Foundation, shaping the future. Step into Sharp Economy. Own your growth. Own your future.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp Reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep. Every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp Reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Hi everyone, and welcome to day 4 of Software Architecture Conference. Finally, we have made it to day 4. It's been 3 long days, but we have covered more than 30 plus sessions. Coming up today is a lot of sessions around DevOps, Gen AI, and QA and everything else. For those who are tuning in for the very first time, this is the very 4th edition of the Software Architecture Conference. We have done it we have done 3 times in past 4 years. It is a conference that is always well accepted by our community members. We have a power pack session today. It's gonna a little longer than the other days. So if you're watching from India, it's gonna go till maybe like 1:30, maybe 1:30 past midnight. And if you're joining us from the East Coast, it's going to run till 3:35 p.m. So almost like till 4 p.m. East Coast, and that is 1 p.m. West Coast. We'll be soon joined by our very first speaker. I saw he was there in the background, but he dropped. So if he's watching, please join us back. We need you. Shuvodeep, who's actually the very first speaker. Yay, he's there back again once. Okay, so the very first speaker of the day, he is Shuvodeep. He is a DevOps architect at TCS. I love DevOps, but I have never really had an opportunity to talk a DevOps architect, I have friends who are DevOps engineer. I used to work on Azure DevOps and everything else. But I think it's an honor for me to host a DevOps architect, and he works at TCS. And today he's gonna talk about redefining developer experience with Backstage IDP powered by Harness, and it's a case study. So Shuvodeep, welcome to the Software Architecture Conference. Oh, you are muted.
Hello.
Hi, Shuvodeep. How are you doing today?
Doing good. How are you?
I'm doing absolutely great. Thank you so much. Are you wearing a harness t-shirt?
Yeah, right.
Wow, yeah. I'm very
Okay.
excited, Shivadeep. Yeah,
Yeah,
when we were internally talking about it and we were talking to the audiences, everybody is really looking forward to this session. I think this is the best session. We can start with day one. So please feel free to go ahead and share your screen. At the bottom of your
sure.
screen, you will find a plus icon. Click on it, share screen, and then we can get started.
Yeah, just a second. Let me upload the file.
You can either upload or do a screen share, whatever works for you. So do you use harness in your day-to-day, project development and management? Oh, you're muted once again.
Yeah,
I can,
so uh, is my screen shared? I think, right.
yeah, I can see your screen share. Once you move to the PowerPoint, I'll then add it. I see you're
Yeah,
inside the StreamYard now. I see that screen.
sure,
Um,
sure. Let me go ahead and quickly pull that up.
Perfect. I see your slides. I have added it to the stream. Yeah, you are going to the slideshow. And Shubhadeep, yeah, you can click on that hide link, right? There's a hide link. If you
Right.
click on it, perfect. That will go. Oh, okay. Ideally, that
Okay.
should have not happened. Yeah, it's working. It's working absolutely fine.
No, it's
Perfect.
fine. Yeah.
Yeah, next
Okay.
30
So
minutes is all
correct, correct.
yours.
So yeah. So today we'll be mostly talking about, although I'm been kind of introduced as a DevOps architect. So switching from DevOps to platform, it's kind of a good experience for me. And right now I'm working as a platform engineer and as well as an architect on with few of my clients in TCS. So I'll share one of the case study which we have been recently completed, and along with a few core ideas. So I'll start with the core ideas of the developer experience, the platform engineering, then move slowly towards Backstage, and then towards harness, and then roll out the case study. And nevertheless, we will also kind of planning to have a kind of quick walkthrough on the harness IDP portal, a kind of a mock scenario that I will quickly demo and showcase you how things will work on the harness portal itself. So let's get started. So while talking about platform engineering, so it's basically when you talk about DevOps were mostly talks about the entire dev and IT who are earlier work on the silos in traditional IT environment, bring them together, having a right collaboration, along with breaking different I would say gaps in terms of starting from, if I talk about the overall life cycle of a software engineering, starting from the requirement till you release a product. So what DevOps ideally did is basically reducing those cognitive load between each and every individual, and with respect to, I would say, the components as well as the roles that they have, and stitch them together and collaborate to make sure that a product, which in the traditional IT environment took a larger period of time, it actually go for a faster release or a faster time to market. Now, when DevOps slowly matures, one potential gaps that we have identified, that although we have a lot of DevOps engineer in place, still developers are not happy. The core idea was, I mean, when we kind of dig down this area, we noticed that it's mostly that the developers don't get ideal platforms to roll, or I would say the boilerplates that needs to get reduced, and how things can be simplified in terms of a developer's perspective, because when you think about DevOps, it's not about the developer perspective, it's about how fast we can roll out a product. Now, in terms of platform engineering, or I would say, when I say platform engineering in terms of the developer, it's how we can satisfy a developer, or rather in my core team, how we can leverage more, I would say, components or paths that can be easily achievable for developers to roll out a product. Because until they bring, or I would say build the software, it's tough for them to get, I'd say, collaborate with the DevOps engineer. And then this terminology comes into the picture when the platform team has been set up slowly. And what it does actually, it's create a golden path for the developers. Now, when I say golden path, it consists of several things. First would be kind of, there would be a certain set of standard tools and platforms that they could actually, hop into instead of going forward to multiple tools and platforms. So ideally in DevOps, there are a lot of tools and platforms which stitch together. But in when I'm working as a developer, I don't want to get a context switch. Okay, that actually hampers my productivity, the developer productivity. So I would say I would love to have a complete, I would say, isolation from switching back to back and forth things, and love to get a complete end-to-end picture in a single pane of glass. And that's what the motto of the platform engineering is. So stitching the entire developer platform together, be it a CI/CD, be it your entire infrastructure through Terraform or any form of code, like maybe OpenTofu or Pulumi or Harness ISEM, kind of a granular policy control management where the entire governance should be there, and there is a single strategy that can be implemented for a single or a set of developers through kind of centralized policy management, governance at code, along with kind of whenever developers want to get on board and going for a faster onboarding, there should be some golden paths through which they can actually roll into a certain set of activities. It could be some sort of ready APIs, ready-made portals, some catalogs which they can readily use, or maybe I would say an entire scaffolding environment which they can readily onboard into and start implementing their journey. So when we mostly talks about the platform engineering, the most important thing, as I told, it's a developer experience. Now, in order to measure developer experience, there are few key aspects. The first thing is lead time for changes. The next is deployment frequency, the time to first commit, time spent for waiting, and context switching. Few of them I already discussed, but right now I'll be kind of elaborating few of them. So lead time of changes is basically means how long it takes from a software engineer or a developer while starting their code until it get delivered. Frequency, it ideally means how fast they are delivering this product. This also kind of an amalgamation of DevOps engineer and the developer. So it becomes a DevOps engineer. Then the time to first commit is basically how fast their entire product suite is set up and how fast they are committing to GitHub, GitLab, or any other source code management system. Time spent waiting ideally means how long they have to wait for a certain product to get rolled out for them to enable those services. And context switching is basically hovering back and forth to multiple tools. For example, a developer who is working on for example, an IDE just like VS Code or PyCharm, they want to switch it to. They don't want to switch it to. I would say any kind of code quality environment that to check a code, it should be what they expect is everything should be there in front of them, in front of them to get a visualization at the right point of time, as well as when it comes to the product to be kind of rolled out, there are multiple testing suits, how we can integrate those testing suits together or stitch them together in one single pane so that they can actually readily collaborate to different team and eventually get the ideas, or I would say they can see what is happening instead of basically raising a ticket and wait for them. The next part would be, and obviously should be a feedback loop where the entire from the different stages of the DevOps, it can readily fed to the developer experience portal on real time, which eventually goes for a kind of, I'd say, overall, it actually improves the overall reliability and the performance in terms of they can readily understand the change failure whenever there is a ServiceNow integration with their entire ID itself. So, I mean, whenever the integration of ServiceNow with the ID along with Jira, they can easily see that what are the features they are working, what are the blockers they have, and how they have to mitigate that. And the next part would be kind of, I would say, sentiment metrics. It could be kind of overall developer satisfaction surveys, I would say, which talks about how much the developer is happy. So many of the product tools or teams, they are currently doing this kind of service to make sure that the developers are happy in terms of building new product. There are no, I would say, hiccups in terms of onboarding them and get the first product to get delivered. Along with the overall developer effort score, and there was also kind of ready quizzes which actually talks about how much the developer is actually happy while using a certain product suite. And some of the product teams, usually what they do, they send some sort of service to them so that they are well adopted and how the developers are actually behaving in terms of using different tool sets within the product. Okay, moving to the next one, it typically talks about a very high level architecture where we have our application developer who actually uses different set of products which are being a part of an internal developer portal. It could be a certain set of golden path that they use to create a certain suite of products. Certain set of platform services consist of APIs, infrastructure. It could be the platform itself, scorecards, which ideally talks about different set of metrics in one single page, which ideally create a certain set of catalog repository. And it eventually talks with the CI/CD, the infrastructure platform itself, the monitoring tool, or the overall observability platform, where they eventually get talks with the SRE engineers itself. Now, since we are mostly talking about the harness itself and the harness IDP, so let's deep dive into the harness architecture. So the overall harness platform being managed, ideally in our scenario, it's a platform team who overall manages all the typical needs of a developer. It could be the entire harness product suite. There are certain set of catalogs that needs to be maintained, which built by the platform team itself. There could be a certain set of let's say scaffolding templates which uses those catalogs in terms of building the infrastructure, building an API, building a certain set of product or improvise that product, how we can implement a certain set of release note into tech docs. So this entire thing, platform team takes care, but the development team is ideally collaborate with the harness IDP and communicate with a different set of products within the harness suite. And eventually, while using these software catalogs, they talks about, or along not only the software catalog, but also the harness product suite, like the connectors and the APIs. They usually talks with the infrastructure as code to build the infrastructure from a certain set of catalogs. So they already have a few set of predefined requisites ready with respect to the infra as code, with respect to the CI/CD tool, the security tool, the SCM, the observability of the policy. So all are baked into one single environment, into one single IDP workflow, where once the product being pushed onto GitHub, there are certain policies that to be implemented, but how to cater them, that entire suite being, I would say, governed through this entire IDP platform. And whenever a development team onboard into it, all they need to do, they need to use the correct UI platform so that they can use certain set of product. For example, they are currently using product version 1.0. So they will select the product, and then what are the prerequisites that will automatically come into the scaffolding page from that UI itself. So they can easily aggregate on try building their own products from the leveraged interface of the harness IDP. And it might happen that there are multiple different product suite that being used, but what harness ideally provides, they have an entire product suite with respect to CI/CD, their software testing, along with their functional and non-functional requirement handling. Then if I talk about the overall observability tool, they have harness SRE. So all entire thing along with the IDP, they provide it in a single pane where a developer need not to switch back to multiple repositories itself or product suite itself. When it comes to product suite, I would say the GitHub, GitLab itself, they readily log into the harness UI through their SSO or any ID, and then they explore this thing. So there is a very less intervention of the context with respect to switching different different tools and platforms. So it also talks about the rationalization of multiple toolings, which a kind of generic problem nowadays in DevOps, where we have an entire product suite, and we are seeing that multiple customers across certain geographies, they are adopting. Why? Because they want a single tool that can handle everything, and developer need not to worry about integration and all those stuff. They can readily move on to this entire product suite in all at once and deliver the product. Now coming from since we are talking about mostly on the IDP, so let's have a quick walkthrough on the differences, and I'll give a quick glimpse on the differences as well in the next slides. The first thing is, whenever we are using a Backstage IDP, the main challenge is how you can leverage, or I would say administer a certain platform, because Backstage does not have a composite platform which gives out of the box. You have to build the platform, you have to maintain the platform, and for a certain product company, they don't want to invest much on the infrastructure cost in terms of maintaining those operational productivity, efficiencies. Mostly what they want, someone who can handle this thing, and then what the developer can do, they just need to write the code and push it and see the products get rolling. So when it comes to the Backstage, the basic feature is I would say the components that they provide with respect to ready plugins. While the Backstage does not provide an out of the box plugin in most of the cases, but yeah, in some vendors they do provide. But when it comes to integrating those plugins with the front end and the back end, there comes the most challenge. And what we have seen, that since Backstage is a pretty legacy products and they didn't have rolled out, or I would say much after since last couple of years. So most of the third-party plugins that we use that are non-compatible, and then here comes the harness. Harness actually brings those things. They're actually using the Backstage core underneath, but integrating all the relevant plugins together with the UI itself. So the developer may or may not want to go through the entire set of products through integrating them through the code. They can use the UI, so it's a low code, no code interface through which they can use, and obviously they have a choice to use the codified version itself. So let's jump into the detailed comparison. So here comes the catalog. So the main differences are, if you see that in catalogs, both the same, both Harness and Backstage are providing similar entities or similar components. But when it comes to the automated discovery with respect to the catalog discovery, here comes Harness, where they actually provide a certain set of discovery mechanism with their auto discovery and Harness IDP intelligence, to which what kind of dependencies they have, that resolution automatically comes into the picture in a single graph. Along with, in Backstage, you are not supposed to, since there is no UI in the backend itself through which they can connect, it's only about how the UI interacts with the backend. So you are not allowed to use the UI to update any entities. It can be done through the YAML only. But in Harness, as you said, it's a low-code, no-code platform. Through the Git experience, you can readily back and forth the code push or changes with the Git itself. It can be the Harness Git itself, or it can be any third-party vendor that we can integrate. When it comes to workflows, there are a few similarities, and I would say in terms of the custom workflow action with respect to the pipeline integration, Harness provides an out-of-the-box orchestrator with respect to pipeline. When it comes to, I would say, workflow group, that Harness provide using a certain set of golden paths through their IDP hub. When it comes to defining the failure strategy on certain set of execution, or I would say defining those failure strategies, Harness uses a conditional execution through Jexel, that is using a JSON template through which you can easily build some conditional execution, along with failure strategies based on certain parameters. When it comes to scorecard, now scorecard is an important thing, as I said, like whenever there is a certain set of policies and all, how we are mapping them together, that's where the scorecard comes into the picture. And in most of the cases, Harness IDP wins here, because scorecard does not come into Backstage out of the box. It mostly you have to use certain set of third-party plugins. But here we have seen that scorecards being implemented out of the box through the service discovery, and all the different set of metrics are being populated in the scorecard itself. When it comes to platform, again, the main differentiator here is the platform, and Harness IDP wins in this stage, where it basically talks about how, I mean, you don't need to maintain your own platform. Let it handled by us or the Harness itself. So you need to use different set of platform readiness, or maintain those platforms through a certain set of applications, or integrating some applications while the setting up the platform. It can be done out of the box through Harness itself. When it comes to governance as well, there is no out of the box policy governance mechanism in Backstage. Yes, we can use third-party plugins again in that catalog info, but that's what Harness kicks in. They have their integration with open policy agents and Keyvarno in terms of open policy, mostly use with the overall practices in terms of your certain set of DevOps workflow, whereas the Keyvarno mostly works on integrating your infrastructure policies and workflows, along with the audit trail and certain set of granularized RBAC. So you have your org, your projects, your accounts all in a single pane. You can manage what you have to do at what time in a single click. You don't need to write a set of code or something. It's there for you. Only you have to define certain set of policies and it will be readily rolled out. Okay, now here is a quick overview that how we can manage this entire thing. So let me go ahead and quickly I'd say switch back and go to the Harness one and showcase you how it works, since we have only 5 minutes. So this is the Harness developer portal. So I go to IDP. So here comes the catalog. So if I select all, so we have all the catalog. So it differentiates to the components, API, resources, and workflows. So let me talk to the components. I'll check this one, boutique at service. Okay. So when you say this is the overall IDP page, and you see there is a scorecard. So your infrastructure standard, your security standard, your coding standard that is used by Java, that is being maintained here. So once you click on scorecard, you get a detailed overview. Let it be bring out. Yeah. So you can see that there is a overall standard check based on the scoring pattern. You can say 0 to 49 is a red, 50 to 74 is amber, and 75 to 100 is green. Whereas if you go deep, you see that there are some weightages that is being maintained through code, and these checks are being done on a periodic manner. Okay. See, last updates 7 hours ago. So if I go rerun checks, it will again check. So this actually tells you that how your overall product is behaving in terms of security. You don't need to go to or look for any security dashboard or something. It's all integrated together. When it comes to dependency, well, there is no dependency component for this, but you will see that mapping is there with respect to dependency. Since it's not an API, so definitely there is no API component are there. Also, in terms of IACM, if it is loaded, so let's see whether it loads. I don't think there are any IACM components are there. So I'll quickly switch on to the YAML part, how it looks like in terms of YAML. So you can either codify through YAML or you can use the Harness IDP portal to bring. So this is the raw YAML which you see. If you can see here, the Backstage, overall Backstage API is being leveraged here. So Backstage.io v1 alpha 1, this is for the core API that is for your component, your APIs, your infrastructure, everything that is being used. So it uses a flow of API version, kind, metadata, and spec. Okay. So in API version, we have this Backstage, kind is component because it's a component category that is selected. There are a lot of metadata that I would not to go here, but what important thing is the annotation. So here we are integrating all the different Git paths or locations, or I would say your project slugs, your Kubernetes namespace, everything together. So in annotations, we are mapping them together. If I go into this path and let's see. Let me see. Oh, okay. So it has been deleted, I believe. Go to this thing. Okay. Let me switch back to something else on the. Okay, yeah. So I have something here. So with respect to workflow example, this is the YAML template that I was talking about. So this is where the scaffolding is being taken place, where I have all the components which are being maintained here with respect to the services, with respect to the repositories, with respect to the overall templates, how they can define, along with publishing a tech doc to a certain set of resources, registering the components and output with respect to sending the information to the repository back and forth. So let's quickly choose a another example here. Let me go to catalog. Let me see if I have the currency service. Okay, let's go to a different component. Let's go to an API. So for example, GraphQL. So let's see. Yeah, so it shows about overall mapping on how the API being provided by which source and who is the consumer of this API through this graph. We have a provider which is basically kind of actually facilitating the entire product suite. We have a link to the GitHub repository. And if I go to the definition, this is the raw GraphQL definitions itself, which are being maintained here. And if I go to the YAML, so again, it's a similar thing, but only the differentiator is this is the kind of API kind and spec type is GraphQL. And if I go to the annotations, these are the integrations. It will give you an overall brief overview. And if I talk about the templates, so this is the raw JSON and YAML templates which you can leverage. Again, it's basically on the API side, so it uses the same Backstage API where it talks about the annotations, how it's been integrated, right? And the different relation with respect to different account specifications and all. So let's go to one of the workflow quickly. Yeah, so in case of workflow, it's similar. We are using the harness IO here in terms of while defining the workflow or creating a workflow. So this is for a certain sandbox project that we are talking about, where you mostly talks about the workflow with respect to who is the owner and the metadata and the spec along with different pipeline details. So here the pipeline trigger URL gets triggered along with the properties of the project itself, with the authentication mechanism, along with the steps so that it can trigger the harness pipeline. So when it says steps and the ID is trigger, we are basically triggering a harness pipeline here through the harness pipeline studio and invoking them in this IDP workflow itself. So in the backend, there is a harness IDP which is getting triggered. So yeah, that is the overall concept of the harness IDP that we are talking about. I think we are running out of time. So any questions so far?
Yes, Shiv, we do have the question. You want to take now towards the end of your session, or you're done with your session?
Yeah, I'm done.
Okay, perfect. That's good. It's I think you went on to share a lot of stuff. So let's take a few questions from the audience. There's one question coming right from Khan Singh, and he's asking. You can come back to StreamYard and actually see on the screen. It is, you mentioned in reduction cycle times. How did you measure this, and what was the magnitude of the improvement?
Okay, so when you say reduction of cycle times, it's basically when it comes to harness IDP, I would say measuring it, we can integrate it with a certain set of observability platforms through which we measure with respect to when we are defining an SLO from that observability platform, we can get the data directly mapped once it is mapped to the harness IDP platform. So that's as much as simple.
Perfect. Thanks for answering that. Let's take another one from Rohit, and is asking, "Hey Shuvodeep, what was the most effective tactic you used for internal evangelism to drive adoption of the new platform across thousands of engineers?"
Okay, so what ideally has been taken care of that. See, the main idea is to understand the core problem of the developers, or I'd say the product engineers who actually writing the code. Okay, so when you have seen that, we identified a set of parameters, and that I explained. So how the developer behaves in terms of when it comes to their productivity, how quickly they are adopting new stuffs or onboarding onto new pipelines, how the pipelines are get ready, how they are getting different set of access of tools, which ideally should be available, but kind of restraints due to some operational imperatives. Maybe it goes to certain back and forth processes in a large organization. So a centralized platform team has been set up to identify those core pain points, and eventually we bring our own service catalogs, step-by-step method, and integrate it with the harness or workflow itself. And that is how the developers get happy whenever the new team gets onboarded. Earlier it eventually took around 10 to 15 working days to get it rolled out, but now it eventually takes around 1 to 2 days max with respect to the entire automation suite. So we have reduced this entire time almost 75 to 80% with respect to the developer productivity, and eventually it helps the faster time to market for a product, because once the developer is ready to roll out, the product suite will be eventually built early, right? And once the developer is happy, then it actually takes the satisfaction.
Oh, that's
Yeah.
lovely. That's very lovely. There's another question coming from Scott, which is very similar. So I wanted to take this up. Scott says, "Great session, by the way," and he's asking, "How did you end up choosing hardness?" I mean,
Okay.
and I'm really interested to know, right, for an organization like TCS or something, right? We all have, we all come from engineering background. We have Azure DevOps, we have GCP team, right, who has their own suite, right? There are
Hmm.
folks who love Terraform and everything. So first, how did you end up choosing hardness? Yeah, so that's a very good question, I think so.
Yeah. So let me answer that. So the basic idea was, see, whenever we are integrating, so the first point we have identified while talking to multiple customers, what they want, they don't want multiple tools hovering into their environment. They want a certain set of product suite which takes care of everything. So when it comes to harness, so they have their entire product suite with respect to the CI/CD. Harness has their own CI platform itself. They have their own product code repository itself. So eventually, when a developer gets onboarded, they don't need to integrate with GitHub or GitLab. I'm not saying that it's not required or it's completely bad, but what I'm trying to say is instead of having multiple different products and integration, there are a lot of maintenance with respect to GitHub, GitLab, or any other product suite, maybe Microsoft product suite, I would say ADO or something.
Yeah.
When you have a certain set of single pane, it's easier for the developer to think out of the box with respect to their product, mostly not thinking most about how I can tackle my infrastructure if it's certainly having an issue. So what the beauty of harness is actually take care of everything into their kind of, it can be hosted into the vendor cloud or it can be hosted into the private cloud of the customer, which mostly we do. And the entire manageability is do it with the customer itself or us. Now, whenever we are doing it, we have the entire visibility on what is going on around with respect to the CI/CD, IACM. If you talk about the software testing orchestration, where a lot of fragmented tools are there, you have one single tool which can take care of that. Along with the SRE, like the service reliability management, the incident operation product suite, like incident response playbook, along with integration with multiple observability tools, is so much seamless. What I've seen that it can help you leverage the overall, I'd say, product portfolio team to handle this thing efficiently rather than hovering towards multiple tools.
Okay.
Right?
Okay. That's very good to know you that you can go to one place and you find everything else. I'm with you, right? Otherwise, you have to hop from one tool to the other.
Correct.
Although, right, as you said, they have their own code repository, so
Mm.
it may make things easy. So yeah, kind of, it's true, right? Whenever you use any other kind of CI/CD, other stuff, right, there are too many moving variables involved,
Right.
right?
Right.
So that's very right. So we'll take one more question before we move to the next one. Thanks for
Mm.
answering that so beautifully. There's a question from Hemant. He's asking, what advice would you give to a platform engineering team with limited resources that wants to start building similar to IDP?
Sorry, can you please come again with the question?
It is, you can actually see it on the screen if you also come by,
Okay.
if you want to reread. It says,
Mm.
what advice would you give to a platform engineering team with limited resources that wants to start building a similar IDP?
Okay, so I would say this is a kind of a POC platform that they are talking about with respect to limited resources. So the ideal is to, since harness is not an open source, definitely, so Backstage it's a ready to go platform here. So you can leverage Backstage, although it has some limitations, but the core features with respect to the catalog management, with respect to scaffolding the templates, although you have to integrate a lot of plugins from the backend and the front end. But yeah, that would be a good experience for you to start with. And once you have an experience on the Backstage part, you can readily roll onto the harness, where it has a more advanced platform where you can have everything in a single pane and you can manage it with maybe few clicks, and that's it. Yeah.
Yeah, perfect, perfect. I have many friends actually who work at Harness, so I was very excited to see you winning a t-shirt. Right, they also have a conference coming up, and they're not doing in person in India, but they often do a lot of meetups and everything else. And
Yeah.
in yeah, so I think perhaps that's where you got the t-shirt, right? So Shuvodeep, it was absolutely lovely to host you. There's so much you
Thank
share
you.
in just about 30, 35 minutes. very core engineering. I really loved it, and I'm pretty sure everybody watching, they have loved it. Any final thing you want to plug or you want to add before we move to the next session?
Yeah, I would love to hear the feedback and the open questionnaires. I would love to respond to them. Since it's a pure tech sessions, I understand there are a lot of jargons I have mentioned. So yeah, please excuse me. But when there is a technical, or I would say a similar sort of session with respect to the architecture, so these kind of things do come by, right? So yeah, I would love to attend.
We all really enjoyed it, right? Thank you so much. It's all developers audience. So thank you so much, Shuvodeep. Have a nice evening, and hope to see you in some other events and conferences.
Sure.
So yeah, bye-bye.
Bye.
All right, ladies and gentlemen, what a absolutely stunning session by Shuvodeep. And we now move to another session that is by none other than Prakash, right? We all know Prakash. He is no new to the developers community. And today he's going to talk about CQRS Pattern, backbone of microservices. Hi, Prakash. I cannot add you to the stream because your device is not connected. You can maybe switch on your camera or something, and then I will be able to add you to the stream. Until then, I'll play. Yeah, he dropped. Never mind, ladies and gentlemen. Enjoy this quick 1-minute commercial, and we'll be back. So Prakash, what you need to do is you need to click on this at the bottom of your screen. There you go. I can now add you. If you switch on your camera, your device went back. Okay, perfect. I can add you now. If you would like to switch on your camera, only then we can see you. Otherwise, we won't be able to see you. Oops, your device not connected again. Or would you like to just present like this? Can you hear us? So Prakash, what you can do is at the bottom of your screen, you will find the gear icon, right? Click on it and go to audio and camera on the left hand side, and then you can pick the right audio and camera. That's how you can quickly fix it. But I think we can hear some noise from your end. So perhaps, but you need to fix your mic maybe, right? Click on that gear icon, go to audio, select the right mic. You're muted now. No, we cannot hear you. Can't hear you. Never mind, ladies and gentlemen. By the time Prakash joins us again, please enjoy another commercial.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep. Every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Welcome to Sharp Economy, the social fi platform empowering creators, communities, brands, and businesses. With tools like Contribute to Earn and Spend to Grow, we reward participation and put your skills on chain. A decentralized ecosystem built on Web3 principles, where transparency and ownership truly matter. Sharp Economy stands on 4 powerful pillars. The Sharp platform, bringing Web2 to Web3. The Sharp token, fueling growth and rewards. The Sharp Rewards app, where you learn, earn, and grow. And the Sharp Innovation Foundation, shaping the future. Step into Sharp Economy. Own your growth. Own your future.
look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
I'm sorry, ladies and gentlemen, just having some time. I see he has joined again. There you go, Ray. Finally. Hi, Prakash. How are you doing today?
Good, I'm doing great. I had to change the machine. There was some issue in the camera of the previous laptop, so I had to change.
I know, these devices, their camera, and when you have this browser-based streaming tools, it can be a little tricky. So, Prakash, thank you so much for joining. Right. I know we have already in like 5-6 minutes of your session.
Sure.
So we'll do chat towards the end.
Exactly. We will quickly get started. Give me a moment. Okay, here we go.
Let me see. I don't have your screen share until now.
Okay, I'm uploading something. So do I need to share a screen or uploading will work?
If you do uploading, your animations, everything will not work.
Okay, I see. Then I can maybe share a screen.
Yeah, you can do a screen share. Yeah.
Okay, I see. Okay. Okay, so please confirm once.
Yes, it is loading. You are inside your presentation, right? Once you go to the presentation mode, right? Or are you going to run it like this way?
I thought I'm in presentation mode already.
No, I think it's on the other screen. No.
Oh, is it? Okay.
Try again. Never mind. We can continue with this. It's okay. No problem.
Okay. Just give me try last time. That works. Okay. So thanks everyone for joining this. And I think we already lost a few minutes in setup. So let's quickly get started. So today I'm going to talk about CQRS, which is one of the key design pattern of microservice, which is getting like one of the baseline for any distributed system at this point in time. Any system which is complex, which is having user growth continuously. So it is kind of getting one of the default, I would say, design pattern to begin with. So we'll talk more on this as we progress. So here are some of the things which we'll be covering today. We'll dive a little bit on what is CQRS, why it exists at first place, what it's trying to do, some of the things where we should be using CQRS, some of the places where we can avoid it, don't overuse it, some of the tech stack that comes, and in today's session we'll talk more on Microsoft. I would say tools and platform more. So, but there are some open source as well available platform as well, which maybe I'll mention time permits. But yeah, we'll focus more on Microsoft toolings, and then of course depending on time we'll go through some of the code base as well, that how we can set up our code base to meet CQRS design principles, and we can make most out of it. So let's get started more. So pretty fundamental that this system design has evolved over time. We all know about monolith systems, which were there maybe in 18th and 19th. Then SOA, SOA thing came, service-oriented architecture came. And then, of course, the big leap happened when microservices came, maybe a couple of decades back. And of course, it got more traction in towards 2010 or 8 when this cloud platform evolved, right? So it took a lot of, I would say, leap there, where it got systems also supporting it. So microservices then again gone through multiple, I would say, tweaks in terms of toolings, in terms of how we can maybe make few components better. But yeah, I think it's still kind of there. There are few platform came and kind of gone, but microservice is something that stayed for longer, and also it is being used even now. Of course, there are some things that we need to take care so that we end up using in the right place instead of overusing or maybe using it at the wrong place, right? So we'll talk more on some of those guidelines that where it makes sense. Again, due to data growth, the need of scalability has evolved, right? We all know that user growth, growth is kind of
Prakash, I'm really sorry to interrupt, but
Hmm?
you need to move
Hmm.
to the next slide. You're still on the slide 1.
Okay, I'm moving. Is it not moving there?
No, I see. Yeah, now
There.
now you're on slide 3. This is slide 2. Perfect.
Oh, okay, I see. Somehow it is not moving. Okay, maybe I'll just interrupt me if it's not happening. Maybe I'll fix it. There is some issue.
You're on slide 3
Okay,
now.
fair. Thank you. So what I was telling that scalability needs has kind of made it to be kind of continue to be used because it really supports scaling systems depending on depending on where we want to scale, depending on different domains, depending on what kind of operations we want to scale. And the limitations with the traditional CRUD system was about that they can't scale after a point. So because the system, the databases were used to support maybe certain number of users, let's say in 1,000 or maybe million. But when it comes like a several millions or thousands of millions or even billion in some cases, it kind of doesn't scale and it gives trouble. So that's where we need to think about that. What is the right platform and kind of design to which can support that need. Is it move to the next slide, Simon? Or is it all on the same one? I moved it. Can you hear me? Okay. Simon, can you hear me? Okay. So here, let's talk more about CQRS, right? What exactly it is? It is command query responsibility segregation. So as the name suggests, command and query are their responsibility is segregated. So typically what happens in CRUD that we try to kind of mix and match both command and query together. Means if we want to query some data, typically the select queries, we keep generally along with commands, which are basically like insert, like update, like delete. So we generally try to kind of keep them together. So that was the problem statement why CQRS came in picture. So what it does it that it separates module of let's say writes module where we are writing into some databases or some files with reads where we just need to query that. We know more often than not that reads is more in any systems, right? Typically you take any social media, you take any e-commerce, or you take any other systems, reads are generally more than writes. Of course there are some systems where writes are close or even more, but they are very few. Typically reads happen more and writes happen less, right? So it kind of gives us I would say, idea that why don't we kind of separate these modules together? We keep them together. Sorry, we separate them and let them independently scale instead of mixing their modules together. So that was the initial thought about CQRS, that how we can separate, the querying modules with commands where we are basically making some manipulation or making some change in the database, right? Of course, with that, it enhances scalability because we can scale separately. Let's say it is a read-heavy system so where we want to put more infrastructure, more faster access. We can do that. And let's say system is having more writes and less read. So we can scale or we can put necessary, I would say, computing power or memory or cache wherever needed, depending on the business case, instead of kind of taking both operations together. So in practice, what happens that will have a separate command model or separate query model, and they will have their own handlers. So that way it is easier to scale them independently. Okay. I'll move to the next slide. I hope it is changing. I'm just confirming. Yeah. Okay. So if we contrast that CQRS with traditional CRUD, so of course, I think I mentioned a bit that traditional CRUD was like how we can unify read and write. So read and write are put together. And since they are put together, there is no chance that, if there is a read heavy system or write heavy system, there is no chance that we can scale them independently. So that's where the CQRS comes into picture, where we separate these models. And of course, I think we discussed that it provides a clear separation that we are not mixing this, let's say read with write and things like that, and we can independently scale it. So that's the major difference with traditional CRUD architecture or CRUD style of the design versus CQRS. Okay. So now, which are the core components of CQRS, right? Let's talk about that. So of course, we'll have handlers for command, and we'll have a query and query handlers, right? We'll also, we'll look into the code as well, that how actually they looks like, right? How to design those. So we'll have their separate query and command modules, and also their handlers, so that we can scale them independently, right? So there's a core component. There are some libraries. There are some other design pattern, like mediator comes into picture. You can also leverage a repository to make it end-to-end functioning, better. Apart from, of course, CQRS, right? To make the overall systems more, I would say, easy to design and take most out of it. But yeah, core components still remains these command handler, query, and query handlers. Okay. Now let's talk about a little bit more on internals of that CQRS, right? So there is a concept called event sourcing in there. Event sourcing, when we say, it is about, it's like a lot of events are sourced and stored, right? For example, let's say in e-commerce site, example of event sourcing can be, you have different events like for order created, order placed, order, payment made, order delivered. So these are the different events, right? And these all are kept into the database, and we can replay them as needed. As opposed to the traditional system where, let's say you got an order created, and once it is kind of order payment, you don't really care about order creation. So you basically care about what you are doing right now versus what it's like a scaling, or you can say, sorry, trailing. So don't really care about event trails in traditional system, but in even like CQRS, where you use event sourcing, you really care about audit trail, that what was the sequence of event happened when initially user came into action, or user started coming. So user logged in, then you will say that, okay, user placed the order, then you will say that, okay, payment made, and then of course you also track whether the order got delivered or not, right? So you really care about keeping all the event trails in the system, so that you can replay them as needed. So that is about concept of event sourcing, and that plays a major role in CQRS implementation. So yeah, I think we talked about event replay, because it has the data, so you can replay or like you can debug as needed. One other thing that it provides is temporal querying, basically. So it's like eventual storage, right? So or you can say temporary storage. So for example, you want to get data that, hey, let's say the order placed today, and actually it got delivered day after tomorrow. So you want to get that, okay, what was the data? Let's say there is a 3-day cycle. So you want to get the data of second day, right? Basically, you want to check that, or what different action happen on a day 2. So temporal querying can help you, because it stores the audit trail. If you just have about, let's say, you just have all the data. Let's say you are in day 3, and you're not having, let's say, any column to have your dates. It's really hard for you to say that, okay, what was my sequence of event, or what exactly happened on day 2. But temporal querying help you, or it gives you kind of time range that you can replay, you can review those, that okay, what was different actions or different data got stored on particular time range. So that gives you flexibility. Of course, the concept remains about this audit trail, because if you have audit trail, you can do that. You can play the events, you can check different actions on certain time. So that give you flexibility to do that. Moving on. Now, of course, we talked about CQRS and they how they are kind of helpful in microservices design. You can do microservice without CQRS as well, right? But with CQRS, you get additional, I would say, capability or power. You can power your microservices. How example could be that, of course, this helps you to scale different, I would say, different actions independently. For example, read and write, and it kind of help you to, I would say, cater to different needs, right, as per your requirement. It also enables the polyglot persistence, means you can have a different type of database for different use cases. For example, you may prefer to have your profile getting stored into, let's say, a typical RDBMS, like let's say SQL or Mongo, or not Mongo, at least you can say any other SQL server or MySQL, right? Any RDBMS for that matter. And you may want to have maybe let's say any mapping into key value pair kind of database. Let's say you can have any Azure table or any of those kind where you can store key value, right? Or you may want to have, let's say, more relationships of different you can say different nodes into graph kind of database, or maybe document DB like Mongo, right? So there can be different use cases, and you can use, based on the use case, you can use different database, right? This polyglot thing kind of let you do that. I think we already talked about independent scaling of these, so I think you understand already. Now let's see more about how you can visualize this, right? We talked about CQRS, where how you can, what are different key components, but now see that how this looks like. So of course, API gateway comes in picture for most modern systems, where it provides some of the out-of-the-box capability about securing your system, your APIs. It also provides, depending on the configuration, your I would say API can be explored, or it can be authenticated. It also provides some kind of additional features there. So API gateway comes into play for most modern systems. Inside that, you can have your both for commands and query. You can have independently. You can take care. For example, command service. If it is command service, you can have event bus, which is like a asynchronous bus or relay of the events, and you can store all those events into let's say in SQL, right? For query, you may decide that, okay, it is my queries module or query service, and I prefer Cosmos there, right? You may decide that. So you can independently have kind of data or database you prefer, depending on the use case that fits in better. So you can visualize at a high level CQRS in this way. Now we talked about a lot about benefits and where it makes sense, right? But every I would say tech comes with its own limitations, or maybe its own best preferred, or where it should be used, right? So pitfall is that where maybe it can put you some challenges. So you should be aware before you start, right? That it's really for system where you really need to scale read and writes, right? And it's like a read heavy or write heavy systems. That, okay, my reads are heavy or my writes are heavy. If they are like pretty much similar, you really don't care about it, because anyway you're not impacted, right? But if you want to scale, let's say, read more or write more, then you really think that, okay, should I put these read and writes modules separately? Does this make sense? If that's the case, yes, it does make sense. But if it is like almost similar and both is working together, and you don't see problem in reads and writes, then I think it's if you still doing that, it's like over engineering, right? You will not get what you want to. It will be like additional overhead for you. Simple case is not a right example to put this, right? It's more of a complex scenario. Eventual consistency, of course, CQRS for microservice, right? For most part, they follow the kind of model they have is like eventual consistency. You may have some service queue that takes its own time. Sorry, message queue, it takes its own time to kind of process depending on when it came. It may not happen immediately, right? So in modern distributed system, eventual consistency is kind of true for most cases. So you should be aware that, yeah, that may come. And of course, we all know that as system gets complex, debugging becomes a challenge. It becomes more complex, right, for a sync flow. So typical CRUD debugging may be fairly easy. You can find any issues sooner. But if it is a modern system, you may need to spend more time. You may need to have a lot of monitoring in place so that you can really know that, okay, where the problem is. So it becomes complex for sure. So what are the best practices we can use, right? So of course, as I said, you really need to really think about that, whether you have a right use case for scale and complexity, right? If it is not, then let's not use it. I think there are simpler model available where you can use it. Of course, if you are using it, as I said, you got to put observability and a lot of monitoring in place, tracing and all. Retry for sure, so that if it has failed, you are again trying in a system, especially the cloud and kind of remote system. Typically, it is one of the need that generally we don't get what we want to get in one time due to any reason. It could be network failure, it could be anything. So all those things should be there for sure. Okay, recommended tech stacks coming from Microsoft. I would say if we talk, there are of course open source system as well. But if I talk about Microsoft tech stack, so these are some of the tech stack that you can use. I personally use this, some of these, and Media is a good library, by the way, folks, which you can use. This simplifies a lot of things for you. You can take away, or you can reduce a lot of boilerplate code that you have to write. So Media kind of simplifies a lot of things for you. For messaging, of course, service bus you can use depending on the complexity, depending on ordering, queuing. Of course, your enterprise should also be ready to. And there are a lot of licensing as well involved, so you should know that which one is most relevant for you. Event stores, of course, you can use your SQL Ledger. Querying, query layer, you can use your APIs. You can have API. You can call those the operations, all the read operations, right? For reading, read database where you have a lot of querying. You can use Cosmos. You can use Azure Search. Monitoring, of course, Microsoft has this Azure Monitor and App Insights as well, right? Log Analytics is also used, though it's not written here, but yeah. So these are some of the tech stack that if you work in Microsoft heavy environment, these are some of the things that you can use. Of course, for each tech, there are alternatives available. For example, RabbitMQ is there for Kafka is also there for some of the messaging stuff, right? So that there are techs available, and depending on what company, what client you are using, you can customize it, right? For example, for read, you may use Mongo, right? You may use any other database for that matter. So that is something totally your individual choice, depending on what you're solving and where you're working. Okay, again, takeaway, and of course, I'll also show you. Simon, you there?
Yes, I'm there.
Okay, no worries. So I think I hope I have some time. Let me quickly check.
Yeah, you do have some time. We can take a few questions.
Okay, sure. Yeah. So again, just to summarize, it is for unlocking or maybe providing scalability, right? CQRS is not for simple use cases for sure. It is for how I can scale my reads and write operations like independently, right? It is very much aligned with the microservices and cloud native patterns. So pretty much modern tech design, right? That's where CQRS makes more sense. If you are a Microsoft shop, or you use Microsoft tech a lot, then of course these are some of the tech that you end up using it. Azure, Cosmos, even great service bus and all, right? Media library, I said I use a lot. That kind of simplifies a lot of boilerplate code, right? You don't need to write the same code over and over again. It kind of makes your code clean, right? There's something called clean architecture, right? So maybe it's a topic for some other time, but there are a lot of things involved in clean architecture, and this media are something that really plays a lot, making things simpler, and you can work in without getting cluttered, right? So that's pretty much. Do I have time to showcase a little bit code as well, Simon? If not, then maybe we can go with Q&A.
We have about 10 minutes before we start the session. So if you want to do some code, you can do it. We have 9 minutes about.
Oh yeah, really. So maybe what I'll do, I have something in this instead of time, I have something already handy. I'll quickly show that how we can structure our code for CQRS. Let me check. I changed my machine, so I need to check that it came here. Looks like it has not come here. But anyway, I'll certainly kind of I have one. I put that code into GitHub, where I think folks can take in and they know my place, like how I can be reached. So here's the place. Is site visible, Simon?
Yeah, it's visible. GitHub.com /CQRS.
Exactly, CQRS. So yeah, so this is the working POCs out there. So go, I would say make it, clone it, and play around. If you have any questions, you can reach out to me. I apart from course CSharpCorner partnership, I also do some blogging myself in my blog site called techieprakash.com. Here is it, and you will find all other credential of mine. So you can reach out to me in LinkedIn. You can reach out to me in Twitter, or whatever works for you. Okay, open for questions.
All right, let's see Q&A then. I'm gonna change my this. All right, let's take a few questions. The first one is actually from a LinkedIn user. We can't see the name of the person, but it is asking. The person is asking how to decide which architecture to adopt. I think that is what your entire session was about.
Okay, it's a pretty fundamental question, right? So what I would say that there are different architecture principle for different problems, right? It's like more of a fitment thing. So there are good guidelines and documentation available out there. One I use myself is Microsoft or architectural guidance. So they have some very nice documentation about more of a guidelines, because nobody can tell you exactly what to do, right? Because a lot of details gets into play when we actually get something, because we need to look at things like existing tech stack, kind of developers you have, right? And there are some licensing tool which are too costly, so company may not afford it. So a lot of tech decisions are also part of the company or client we are working for, right? But in general, if it is about pure tech decisions, there are architectural guidance available. For example, I was talking about if your system is like you have read and write, you have like either read heavy system or write heavy system, right? So instead of mixing your write and read operation together, you can use a CQRS so that you can scale them separate independently. You can have a separate infrastructure services boost for any of that, whichever makes more sense for you. So that is one approach. There are other kind of architectural scheme as well, depending on that what you're solving, right? So yeah, it is pretty broad question.
Yeah, that's you're right, but still, thank you for answering that. We'll take one question from Sophia, and Sophie is asking, can you describe a real world scenario where traditional CRUD architecture would have failed, but CQRS was the clear solution?
Yep, certainly I can tell that. So I used one of the system in the past where it is really read heavy system, so a lot of querying, right? So I would say 80% is read and 20% is write. We had this all mixed up CRUD operation, right? So in CRUD operation, we really kind of have read and write, all those things goes together hand in hand. So if we want to put some extra, I would say servers or in for read heavy operations, is really not possible, because we don't have segregation, right? But if we have that, we can deploy some of those modules separately, where we can scale them separately and we can get things done separately. So that is one example I remember. But yeah, if it is a straightforward example where you don't really care about, your pretty reads and write are pretty close, you don't need to get into that.
Perfect. Thank you for answering that. We'll take one final question before we move to the next session, and that is by Scott. Scott is asking, what are the key metrics you would recommend tracking to monitor the performance and health of a CQRS based microservice?
Good question. So there are tools. Good part is that there are good tools out there at this
Hmm.
point. You can use a variety of tool. If you're Microsoft tech more, you can use Azure Monitor. You can use
Yeah.
App Insights and Log Analytics. If you are open source, you can use Splunk, and there are a lot of tools available out there which can tell you that what is the performance of your services, right? What is the health? So a lot of manual things I think gone now. A lot of these tools help us to keep us ahead of time. They also have monitoring system, the metric. You can see that, okay, which service is kind of doing good, which is not. They also even send you message or ahead of time if they see that some services kind of getting a lot of failure. So you can use some of these tools for sure. Yeah.
That is all we have from the audience as a
Mhm.
Q&A, right? And any final thing you want to add before we wrap it up?
No, yeah, I would say thanks for inviting me, and I think it's always pleasure to share the knowledge
Yeah.
with the group, and look forward to contribute more in future. Thank
Yeah,
you.
thanks, Prakash. Thanks for all that you do for the community. It's an honor, and the all long-term relationship we had with
Yep.
you and CSharpCorner, and you generally with the community. Thank you so much for everything that you do. Have a lovely weekend ahead, and hope to see
Yeah,
you
thanks
soon.
to you, and thanks to all the listeners as well. Thank you. Take care.
Thank you.
Bye
Bye
bye.
bye. All right, ladies and gentlemen, that was Prakash Manit for you. We now move to our next session, but I see a few folks joining from Chile and Brazil. Ole. Yeah, I think I'm sorry. There's a question coming from LinkedIn user. We cannot take it because the speaker just dropped. We'll now move to our next session, and our next session is by, I'm going to mess up his name. I think it's Nikolay. We have hosted him in the previous edition of the Software Architecture Conference. He is the founder and CEO of Corroot, and today he's going to talk about. If I scroll down, I gotta find the agenda. Yeah, today we are talking about redefining developer experience with Backstage IDP powered by Harness. Oh no, I think that is not the session title. The website is messed up. But never mind. So we have him behind the stage. Hi, Nikolay. Welcome to the conference. And could you please tell us what you're talking today?
Hi, I'm going to talk about cloud native PostgreSQL observability.
Perfect. So thank you for that. I know you've already shared your screen. I'm gonna add your screen to the stream. Everybody else can see it. And next 35 minutes is all yours.
Okay, let's start. I'm Nikolay, CEO and co-founder at Corroot. We built open source observability platform that covers all aspects of app performance monitoring, database monitoring, infrastructure monitoring, and even AI-powered root cause analysis. And today we will talk about PostgreSQL observability. But before we start, I just want to say a few words about how our systems changed over time. So a while ago, our systems were pretty simple, and usually it was like a server that hosts an application that works with some database. Database could be run on the same node or on a dedicated node, but it was pretty straightforward, like we have in our app and database. And if something goes wrong, we just needed to check application log, application metrics, DB logs, and underlying hardware, and sometimes network between them. Currently, in modern systems, we have a bunch of services that communicate with each other. We have a bunch of database, primary read replicas. It can be pretty complicated topologies of databases. And all of these runs on top of cloud, which provide us basic compute units, VMs, block storages, and it's from the troubleshooting perspective, it's pretty complicated topology. And while troubleshooting, we should follow from the service to service and check a lot of hypotheses against each service and against each subsystem, such as resource usage, runtime issues, network issues, and so on, and even cloud issues. And to troubleshoot systems like that, we need to have a lot of pretty detailed telemetry. And before we start, few notes about what observability is. Observability is like being able to answer a question about your system, how it performs right now, how is performance change over time, are there any errors, any issues, and with latency, with response time, and the most important thing to understand, observability is most valuable during outages. So, and we should think about it. We should design it for being valuable during outages. So we should take a look at our observability from the outage perspective. And like, let's do for our examples. When we have pretty straightforward application that uses a single database, what can happen, what can go wrong in such system? First of all, application can be unavailable. For example, something happened with our server or with our application process, and that's it. We cannot serve our user requests anymore. And the same stuff can happen with our database, or we can encounter some issues in the network between application and database, or it can be a case with degraded performance of our database. It can perform slower than before. It can reject connection from our application. And to understand how our application interacts with the database, it's not enough to look at the database itself, because database monitoring, such as in case of Postgres, system views like pgstat statements, pgstat activity, they don't provide enough metrics and telemetry data to understand how our application feel its communication between with its database. And so we let's think about database as a utility service, like electricity or I don't know. And our application is just consumer, so we need to look at our database performance from the application point of view. So how application, for example, latency should be measured on the application side, because it's in this case it includes network latency. For example, a database can think that it responds quickly, but some delay in network between them makes it like slower for application. And I believe that the first step in our first layer in our observability should be gathered from the application side. And what we want to know, the first one, we want to calculate the number of queries made by our particular app to the database. Are there any errors and latency? So, and we can measure them using different approaches. The first one is we can instrument our applications with OpenTelemetry SDKs. OpenTelemetry is a vendor-neutral framework to instrument our applications. Think of it like wrappers around application to database calls. And it requires code changes. You need to, in most cases, you need to redeploy our applications with attached OpenTelemetry SDKs. Or we can use something like eBPF. eBPF is a Linux kernel feature allowing us to run small programs in kernel space and capture some statistics in network communication or different process behavior. Let's take a look at how it looks when we instrument our applications with OpenTelemetry. With OpenTelemetry, we just embed OpenTelemetry SDK for our programming language, and it somehow wraps application calls to database and measures each call. For example, here we have an application that performs a request to a database. So, and we, in our distributed trace, we can see all the stages of request pipeline, from accepting requests from user, then calling other services, they call databases, and so on. So in this case, about our database call, we know a lot. We know latency of this particular call. In this case, it's like 10 milliseconds or so. We know that this particular request finished with OK status, so no errors there. And we know the exact request made by our applications. It's cool, but there are some challenges because like in large scale, cover all your application call, all transactions with OpenTelemetry can cost a lot. So it generates a huge amount of telemetry data. We need to store it somewhere. We need to be able to query our database. And it's hard to achieve 100% coverage because there are always a legacy and third-party services which cannot be easily instrumented with OpenTelemetry. And like wrapping up every database call, every service call can bring some resource and latency overhead. Another approach is eBPF-based instrumentation, where something such as OpenTelemetry agent should be installed on the node, and it can capture all network calls from the application to its database to other services, and it can recognize and identify application level protocols such as PostgreSQL level protocol, HTTP, MySQL, and so on, and just measure latency and detect success and failure requests, and it can generate metrics or traces. And in some cases, in majority of scenarios, it can even capture encrypted traffic because of some tricks. Usually, eBPF has some guarantees about performance impact. Let's just a few words about performance impact. eBPF guarantees that our kernel space code will not be interrupted for a significant amount of time. So in worst case, when we capture a lot of traffic, we will lose some statistics, but there is guarantees that our application performance will not be impacted by this sort of instrumentation. And there are a lot of tools that already implemented eBPF-based instrumentation, such as Karoot. We built one of them, another one Pixie and eCapture. That it's open source, and you can just install them and see what happened between your apps and databases. And how, like, few notes on how it works. We just write a small eBPF program which captures system calls. System calls are calls from our user space program to kernel. For example, when we perform initiate TCP connect, syscall called connect is called, and we can trigger our eBPF program to capture such calls. So we from our program, like let's call it observer, which it triggers every time when an application establishes a TCP connection. So we can get process ID, initiate a TCP connection, file descriptor, and TCP or IP address and TCP port for this endpoint, and then we can capture all the manipulations with the socket, such as writing data or reading data from the socket, and it allows us to get payload of each call. So we can then understand that this is a communication between application and PostgreSQL server. We have some like easy way to detect the used protocols, and we can then analyze payload and understand, for example, current PostgreSQL query, and then we can measure latency for this particular query and detect errors or something like that. So it's easy to, and then we can produce metrics or traces. As I mentioned, performance impact, we have some guarantees, and it's, from my perspective, it's a great deal for observability. In worst case, we just lose some telemetry data, but we can be sure that performance of our application will not be impacted by our observer application. And like just now, I want to share some examples of which data we can have with eBPF-based instrumentation. Here we have an application and database cluster run on Kubernetes, which communicates with Kubernetes control plane, but it doesn't really matter now. And here we see that this application communicates with 3 database instances and performs here like around 300 requests per second, query per second, and we know that latency, everything okay with latency, it's sub-millisecond. And we know the amount of queries performed on each database instance initiated by this particular app. And it's super cool because we don't need to change anything in our applications. Then when we want to dig into some latency anomalies or errors, we can just select some latency outliers and see requests behind this anomaly. So it's super useful because it can give us some ideas why these requests are served slower than before. And like metrics usually just show you that latency changed over time, but why and which queries were affected, it cannot provide you with such details. And but there is only instrumentation for, like, we talked about only about understanding what's happened between the app and its database, but it's not enough to explain why. For example, eBPF-based metrics can show you that there is something wrong with a database performance. For example, it performs slower than before, or it started to reject client connections. But why it happened, we need to collect other metrics to explain this behavior. And before we talk about how, let's just imagine what can go wrong. What can go wrong? And there can be some resource-related issues, such as node CPU capacity, or our database were throttled because the CPU limit, or it competed for CPU time with other applications, or because databases are stateful applications. It heavily depends on the volume performance, how the database performs, because it's like it reads a lot of data from disks, and like disk performance issues can lead to database slowdown. That's why we need to understand what's happened. Another one is runtime specific. In case of databases, it's usually locking, where queries compete for some log, and like log contention can lead to slower performance. And like just a quick overview of what we suggest to monitor if you're talking about database performance. Like CPU-related metrics allows you to detect any issues with CPU. For example, the universal metric to understand whether the database is experiencing a lack of CPU time right now is CPU delay. It's a time that database processes waited for CPU being runnable. It means it can be considered as a additional latency. For example, CPU delay at 100 milliseconds mean all milliseconds per second means all queries. This 100 milliseconds were distributed and added to our query latency for this period of time. Then, if you understand that something goes wrong with CPU, we can dig into and understand why it's happened. Because check CPU throttling, check CPU usage on the node, check other CPU consumers on the same node. For example, here we have this case with CPU throttling. CPU throttling, when the application hit its CPU limit, the kernel started to limit these processes in CPU time. So it led to CPU delays and additional query latency. So if we have like our telemetry charts show us high throttle time, we just need to increase limit or understand why the database requires more CPU time than before. Or we can check capacity of CPU of the particular node. And then if we understand that the CPU usage is high, we can just break it down by CPU consumers and see which other processes on the same node consumed all like significant amount of CPU time. And in dynamic infrastructure such as Kubernetes, where the applications and containers can migrate from node to node, and if you run our databases on the Kubernetes cluster, we just need to understand what happened on this particular node in this particular time, because these infrastructures are pretty dynamic. And the last step here is understand. For example, you can see that your database consumes twice more CPU time than before, and why it happened. And PostgreSQL provides some statistics that allows us to explain these CPU anomalies precise to queries, database queries. We can use metrics based on pgstat statement system view or pgstat activity system view to see CPU like time consuming by the particular queries. And like few words between to explain difference between pgstat statements and pgstat activities. It's like they are system views in PostgreSQL database. Pgstat statements show us all queries performed over time. It's like cumulative counters for each request. We can see the number of calls. We can see total time consumed by each query. But it has some limitations. For example, if you run long-running query, it will not appear in this view until it's finished. So, for example, we run a super heavy, resource-heavy queries on our database, and it will not be shown in this view until it finished. And pgstat activity shows us currently running queries, and like to get the full picture, we need to combine all the statistics from pgstat activity and pgstat statements to see the actual picture, big picture, what happened in our database. And we implemented such monitoring in our PG metric exporter, which is open source, distributed under Apache 2.0 license, and supports all modern PostgreSQL versions. And it's compatible with Prometheus. We can use it even without Karut, but with Karut, it provides you out-of-the-box visibility into your database performance. And this is an example of how we can see the CPU spike here, and using PostgreSQL metrics, we can explain it precise to the query affected the performance. For example, here we run a query which scanned full table and checked the body column, which is pretty heavy, and we can see that at the same time CPU usage of our database increased. And also we should check IO related metrics such as IO latency. For example, it can vary between different types of storages. For example, local SSDs. Here are like some reference values. What should you expect from storage performance? For example, local SSDs have pretty low latency. HDD, old style HDDs, spin disks has like much higher latency, and different cloud network attached storages also have some reference value which is higher than local storage. Another good metrics to understand the I/O performance of your storage is I/O load. It's like total latency. For example, we made 100 calls to our disk, and each took 1 millisecond. It means load will be 100 millisecond. It's like it allows us to understand load in terms of compare load over time, and it also take into account latency of each request. For example, if we have the same number of I/O requests, but for example, your network attached storage started to perform slower, we will see the spike and increased I/O load on charts, and we can go deeper and understand what happened. IOPS also allows us to understand the number of read and write requests to the particular volume, and also if we work with network attached storage such as AWS EBS volumes, they have max IOPS and restrictions. So if you hit the limit, your performance will be you will see higher IO latency because your request will be throttled by the system. It's good to know that limitations. And also when we're talking about IO performance, another metric is IO bandwidth. It's a number of bytes read or written to a volume. And in case of using, for example, AWS CBS, you also have some limitations on IO bandwidth, and it's also needs to be monitored. And the last one is when we want to understand which queries led to increased IO performance, IO load. We can use some PostgreSQL specific metrics from pgstat statements and pgstat activities and see the particular queries. Here on my example, we can see the same query that fetched all the scanned all the table and read a lot of data. And the final, I want to encourage you to try Karoot. It's open source, licensed up under very permissive Apache 2.0 license. Just try it, and you will get instant observability into your application, even if it's super complicated microservice application. Karoot is built on top of eBPF, so it doesn't require any code changes. And GitHub link is here. That's it. If you have any questions, I would love to answer.
Thank you. We can take the questions. We have it from the chat. The first one is actually coming from Rohit, and he's asking, how would you recommend a developer choose between proprietary observatory tools and open source tools solutions like OpenTelemetry?
OpenTelemetry is a vendor-neutral format for even if you use a commercial cloud-based monitoring tools, you can keep your apps instrumented with OpenTelemetry and route your telemetry data to these clouds. I would say, from my perspective, it's super important to have enough data to troubleshoot. So in addition to tracing traces, you need a lot of other telemetry signals such as metrics. For example, if you have some trace and understand the bottleneck is some service and the stage of processing requests in this particular service took longer than before, having only OpenTelemetry based data, you cannot understand why it happened. You need, for example, it can be Java garbage collection or some network delay. So you need many other signals. And that's why we decided to build Corroot, because like we try to gather all data we need to troubleshoot efficiently.
Okay, so the Corroot will go along with OpenTelemetry and help you understand your statistics more.
It supports OpenTelemetry in addition to eBPF. So and database monitoring, because I believe we need everything to be able to troubleshoot precisely.
Okay, perfect. That makes sense. Thank you for answering that. We'll take a question from Scott, and Scott is asking, what is the biggest challenge when trying to correlate logs, metrics, and traces from a distributed microservices environment?
Yeah, it's a great question, because when we implemented our AI-based root cause analysis engine, it's like, I would say it's nearly impossible to correlate raw metrics with logs and traces. You need to build a model of your infrastructure and teach your algorithm to traverse dependency graph like an experienced engineer would act in this situation. So it's like, it's not about compare all existing metrics with some engine anomaly detection or something like that. You need to compare metrics that your system understand the physical meaning of them. That's the biggest challenge. So, and I believe our agent can do that so precisely, but it has some limitation, and it requires like much more resources.
Perfect. Thank you for answering that. We'll take one more from Sophia, and it is a question on how does an organization balance the cost of observability with the benefits, especially in a high volume application?
Yeah, it's also super interesting question. From my perspective, like before we had Kubernetes and dynamic infrastructure, it was pretty challenging to store your telemetry data. And now we have a lot of tools, existing tools, such as ClickHouse, that can run on your own cluster, and the cost will be significantly lower comparing to most of cloud vendors. And additionally, when we talk about high volume telemetry data, such as, for example, a lot of logs and traces, when you, for example, on AWS, it will cause egress costs, and keeping everything inside your infrastructure is much affordable if you want to store and analyze high volume telemetry data.
Perfect. Thank you. We'll take one final question before we move to the next session, and that is on eBPF and how does it differ from traditional instrumentation, and what is the main advantage for observability?
I would say eBPF, it's a way how to get instant observability. For example, if I install Corroot right now, I will have a lot of valuable data in a few minutes after installation. OpenTelemetry requires manual instrumentation, but it provides some additional context, which is in some cases can be valuable. And that's why we need to use both approaches at the same time to have comprehensive observability. And eBPF, I would say eBPF, it's a great starting point when you haven't started to instrument your application or to achieve 100% visibility, because eBPF can bring you like 100% observability without any blind spots.
Okay. I'm curious, Nikolay, you said that, it is open source. So do you also build in open source as your entire, timeline and project? Is it also there on GitHub? Do people raise PR and everything else?
Yeah, for sure. We work with community. We have community Slack, GitHub issues, GitHub discussions, and additionally, we offer Karoot Enterprise, which is like enable users troubleshoot instantly. For example, when the system raised some incident like SLO violation, you already in most scenarios you will have answer what happened and why and how to fix it automatically, just right to into your Slack channel.
I was just hitting the URL. I was just curious to see. Okay, that's really nice. I think it's single O. Okay, right. Anything else, Nikolay, you would like to add before we move to the next session?
No, I just want more users to try Karoot, and we also appreciate any feedback on GitHub, on our community Slack, everywhere, because we aim to build a truly useful tool that fits many modern team needs. So yeah.
Yeah, and I see you also have a 14 days. I know I'm going a little off track, but what does a 14-day free trial? How is it different than an open source one? Is it like a SaaS or something?
Enterprise edition. It's like the Karoot open source plus AI powered root cause analysis, plus role-based access control, and plus single sign-on and vendor support. That's it. Other products are the same.
Perfect. Thank you so much, Nikolay. It's always good to host you at this conference. Thank you so much for your time, and have a lovely evening and have a nice weekend.
Yeah, thanks for having me.
Yeah, thank you. Bye. All right, ladies and gentlemen, that was a very good session by Nikolay, and now we move to our next session. But we have about 10 minutes. Right, we have about 10 or 8 minutes, actually 8 minutes maybe before we move to the next session. And I wanted to a little bit talk about our upcoming conference. We also have an AI agents conference coming up in the month of October. I think the current date is October's first week, but we may have to move it to October last week because we're getting a lot of submissions. I think we already have more than 100 speakers applied for that conference, and we just need a little more time to filter all the sessions. So yeah, our next session is on Azure Digital Twins. I think we still have about 7 minutes, but we can take a quick 5 minutes break, and then we will see you very soon. So enjoy the commercial.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Welcome to Sharp Economy, the social fi platform empowering creators, communities, brands, and businesses. With tools like Contribute to Earn and Spend to Grow, we reward participation and put your skills on chain. A decentralized ecosystem built on Web3 principles, where transparency and ownership truly matter. Sharp Economy stands on 4 powerful pillars: the Sharp platform, bringing Web 2 to Web 3; the Sharp token, fueling growth and rewards; the Sharp Rewards app, where you learn, earn, and grow; and the Sharp Innovation Foundation, shaping the future. Step into Sharp Economy. Own your growth. Own your future.
All right, everyone, welcome back to Software Architecture Conference. This is the fourth year we are running this conference, and this is the fourth day. And joining us now is Saravanan, who is a Microsoft MVP, CSharpCorner MVP, a community leader. You will often find him across India, and also now in the US, speaking at many different stages, right? And today he's going to talk about Azure Digital Twin, and of course, it is on IoT. Hi, Saravanan, and welcome to the Software Architecture Conference.
Yeah, hi Simon. Actually, it's good to see you after a long time. Actually, thank you
Yeah.
for the opportunity to start my experience.
Nice house, right? When did you move to that new house?
I wish it could be, but it's not.
One day. So, Nan, please
Yeah,
feel free to go ahead and share your screen, and then we can get started.
yeah, sure, Simon. Thank you for the stage. Actually, 1 minute. Yeah.
Do you need any help there?
Yeah, actually, it's getting stuck. Actually, 1 minute.
Oops, he dropped. Never mind. Well, that's what happens, right? When you do virtual, when sometimes your devices doesn't work, sometimes you have a internet issue, but we are so lucky we have him back. Don't leave us alone, Savan.
Yeah, sorry for if there is a technical glitch. Sorry. Yeah, it's my screen is visible.
Yes, it's loading. It's loading. Um, yeah, it's loading. You are inside the presentation. I've added your screen. You want to click on that hide link, right? So that StreamYard pop-up goes away. If you can
Okay.
click on that hide.
Okay.
Perfect. Yeah, everybody else can see your screen.
Yeah.
And next 35 minutes is all yours.
Hello. Am I audible?
Yes, next 35 minutes is all yours.
Sure. Okay, Stephen. Yeah. Hello, everyone. Good evening, and thanks for joining the show. Actually, it's been like a great opportunity for me from a CharpCorner community for giving me this opportunity to share the things which are related to Azure Digital Twins and IoT. Actually, okay. So in this show, actually, we're going to see about how does Azure Digital Twins and IoT together explain making the architecture. We are going to see actually how this uh, go to things will be scraping our automation in an intelligent way by revolutionizing architectures actually. Okay, so um, we will be actually going straightly to our TPTs. Okay, so I will be explaining you about what is Azure IoT services, what is digital twin, and then actually we'll be discussing about how we need to architect as Azure digital twin, what are the components are there involved in this IoT ecosystem for architecturing the thing. So in this show, actually, if we have a person who wants to build any IoT related architectures using Azure, actually it will be very helpful for them. They also so they can learn more things into it and which services should be used for which operations in the and where it should be placed in one architecture. So that kind of information also will be given and how it can be extended to Azure Digital Twin services as well. Actually, by seeing the schema in the in a twin format, and then actually it will be like seeing the live streaming data in Azure Digital Twin Explorer. So coming to this, actually, you guys have been know about actually like we have IoT services in various cloud platforms like AWS, Azure, and then GCP. Now it's GCP has been closed. It has been suspended in IoT services, and so we have many more things like Clearblade and curiosity, etc., like that actually. But in that actually today actually, if it's I as a person actually, as a preferably, I want to tell that actually, if you are choosing any IoT related architectures or IoT related schemas actually, or if you want to build any use case out of IoT, please be in, and you want to do you want any cloud companion for that, you can be better actually move ahead with Azure IoT services, because in Azure IoT I can see a lot of things. These services which will be really helpful for the developers who are developing the solution for in IoT related use cases. Okay, and also we will be having a comprehensive sort of cloud based services which I have told actually, and then we have some SDKs actually which will be really helpful for developing standards actually, like developing the code, or if you are or implementing your logic to the to these services actually, and building the use cases actually. And also we have some more actually facilitating environment for deployment and managing this IoT solutions in this IoT ecosystem of Microsoft Azure actually. So this is what about yeah, glimpse about what is Azure IoT services, and what are the things we have in Azure IoT services actually. So moving to the next slide actually, if you see, we have a components of Azure IoT services actually. Okay, so in this components of Azure, if you see actually in this Azure IoT ecosystem, we have actually different types of these services like Azure IoT Hub, Azure IoT Edge, Azure Event Hub, device provisioning services, Azure Digital Twins, and Azure Functions as well. And in this actually we will be having a n number of services might be added based upon your use cases. But this six services actually, if you are using it in your IoT ecosystem, you will be feeling a fulfilled solution which you are going to be built in the Azure IoT ecosystem actually for your use cases actually. Okay, so we'll be deep diving into this each of these services actually, like Azure IoT Hub actually. If you see this Azure IoT Hub, it's nothing but actually we'll be actually it's a gateway actually. Okay, so for example actually we have a n number of devices actually. Okay, in the next slide I can explain you actually, like we have a edge components, that edge gateway. For example, edge gateway is nothing but the devices which will be connected to n number of sensors actually. From the sensors it will be extracting the data, and it will be pushing into the IoT hub actually. Okay, so what is meant by this IoT hub means actually, it is like it will be actually it will be mentioned as a gateway called the system. And then actually if you see in this Azure IoT gateway actually, the data will be moving and to various Azure components. So if any data which comes into Azure, actually it should can come via Azure IoT actually. And then also it can be also come via Azure Event Hub. But a basic difference between Event Hub and IoT Hub is actually like in IoT Hub actually we can have some device provisioning services actually. For example, if you are onboarding any devices in your client side, actually it will be automatically provisioned in IoT Hub actually, and it will be easy for you guys to monitor those things actually. That points actually we'll be seeing it up in our upcoming slides, and I will be explaining the same as well actually. Okay, so in this actually, if you see this is an IoT hub actually, it will be access a gateway for incoming message from the edge gateways actually, or devices which are placed in your shop floor. And then actually and the data which is getting gathered from the sensors, and it will be moving to IoT hub, and it will move to IoT from the IoT edge to IoT hub. And next component actually, if you see it's like a Azure IoT edge in this Lambda architecture actually. Okay, so in this actually, if you see here in Azure IoT Edge, which will be a component of Azure IoT Hub. For example, every device actually which is getting provisioned in IoT Hub actually will be also having an option of enabling it as an edge. and in Azure IoT Edge is nothing but an SDK actually, which will be running in a Linux machine or Windows machine actually, where the agent edge and agent hub plays a major role. In that actually, we can also able to deploy n number of custom modules actually. For example, if I'm getting any data from my temperature sensors and humidity sensors, it is Azure IoT Edge. This one. The data will be actually gathered into will be the I will be writing a separate module to get deployed. In that deployment actually, if the module will be performing some operations of processing the data actually. Okay, so in this case actually, so this is a main advantage of the IoT Edge. And once the data is processed, a particular module with this data, these devices or gateway which are here actually will be considered as actually the downstream devices, and then the data which will be sent to your IoT hub will be considered as an upstream devices actually. Okay, so downstream and upstream. From downstream, the data will be gathered and will be sent to the upstream, which is nothing but your IoT hub, I think other services, which is directly cloud components. Okay, so in the Azure IoT Edge, actually, if you see, we have a lot of things to discuss in Edge part actually. But since that there is no that we have a very limited time actually, I will not be explaining this thing, and I'll be planning for separate sessions with Timon in the future for explaining all these topics separately with some use case examples actually. Okay, and then actually, if you see. Once is Azure, these are two major components in this ecosystem: Azure IoT Hub and Azure IoT Edge, and then it comes in Event Hub actually. Okay, so in this Event Hub actually, whichever data which is here from IoT Hub will be routed to n number of services. Okay, why I prefer Event Hub means actually any data which comes here actually it will be routed. Any streaming data. Okay, it's not like a batching data; it's a streaming data. Any streaming data will be sent in from IoT Hub to Event Hub, and from Event Hub to make it, because from the IoT up to event up, we'll be getting the data as kind of a what it is actually, the streaming data is the form of a JSON. So the entire path is called the hot path, and this path is called the cold path actually. Okay, so if you see here. And this hot path and cold path actually, like actually streaming data, usually this path is called as hot path, and the data which is going for the storage and for some processings on for some machine learning related processings and all, for data models designing and cleansing and all is it will be called as a cold path actually. Okay, so the streaming data which comes from the IoT Hub will be passed to Event Hub, and then to Azure Stream Analytics, and then to Cosmos DB for storage. Azure Stream Analytics would be it is a place where it will be making the data in a datable format. That's a tabular format, because still in IoT Hub we'll be having the JSON format, but in Azure Stream Analytics actually it will be a service actually which is used to make your the data in a readable tabular format actually. And then actually it will be moved to any database actually, like a SQL Server or Cosmos DB or MongoDB, based upon your requirement actually. Okay, and then actually if you see here, in this cold part, the data will be routed to Azure Data Lake for storage, for dumping of the data, which is a batch processing way. So in the batch processing, it will go to Azure ML for the machine learning processes, and then to Azure Data Explorer. And from Data Explorer, the data can be moved to actually from digital twins as well actually. Okay, so that I'll be explaining you in the next slide, so that it will be clear for you guys actually. So this entire architecture will be placed under the Azure Virtual Network, and we have some good presentation components. The data which are captured in the cloud will be should be presented in a very neatable format actually, so that in a presentable format. So we are going to use any Angular dashboards or React dashboards or Power BI dashboards or Grafana or any reporting dashboards actually. We'll be creating it and presenting the data to our client actually. So this is about the different components and the different services of Azure IoT, which will be described in the Lambda architecture actually. Okay, Lambda architecture is nothing but actually extracting the data, processing it, and it will be presented to the client in a very neat, presentable dashboard format. Actually, that is called, this entire architecture will be called as a Lambda architecture. Actually, okay. And then we are going to going into the main picture actually, like what is in the Azure Digital Twins actually. So in this Azure Digital Twin, actually the digital twin means actually it's a graphical representation of a particular model actually. Okay, for example, if I have a car actually, in that car actually you have a engine, you have some sensors, and you have some actuators, transistors, everything will be there actually. Okay, so that the data which is that my entire car can be now showcased as a graphical format actually. So in the graphical format, each and every data which is flowing into my car will be easily identifiable actually. So that is called a digital twin. So Azure digital twin nothing but actually the digital twin which we are actually building up in Azure. It's called a Azure digital twin, which is used to design the digital twin architecture that represents active IoT devices in a either cloud-based solution, and which connects to IoT hub device twins to send and distribute live data. Okay, so for example, if I'm sending any data from IoT hub to my event hub and event hub to my other services, actually, it will be sent to my Azure digital twin, and from the digital twin, that ingress and egress of the data will be taken care actually. Okay, ingress means the incoming data, and then outgoing is egress actually. It will be called as the egress actually. So actually, in this case, actually, in next slide we are going to see about from which services and all Azure digital twins can get the data as per the architecture, and then it will be emitting the data to the other services actually which are present in the in the Azure ecosystem. Okay, so so actually in this case actually if you see here the data can be accumulated in the digital twins actually from here like IoT hub and the REST APIs or any logic apps kind of it, the data can be sent here, and from here actually it's a incoming data, and data can be flowed to outcoming into this services like storage, Azure Data Explorer, time series insights, analytics, snaps, Azure Synapse and all. And for example, actually, this Azure functions only will be acting as a two-way communication. Any communication has to be sent to this services or this services. Actually, it can be enabled via Azure functions only. Actually, or with some client apps only. So this is how input and output of Azure Digital Twin with these services present in our Microsoft Azure cloud environment. Actually, okay. And okay, this is called your the ADT, Azure Digital Twin Explorer, and this is the place actually we are actually really actually going to pay. And this entire the twins actually the down twins actually there's one actually this small balls actually 2D representation actually. Okay, so in this actually if you see in this 2D representation, in the storage representation of the twins actually if you see each this entire architecture, the entire hierarchy is it's called a topology actually. Okay, each shop floor or each use case have a different ontology and topology as well actually. Okay, so and each twins actually will be related to all the based upon this DDTL model which are all present in this year. These are the models, and these twins are made up based upon these models only actually. Okay, so and it will be like a top to top bottom to top approach actually. It will be following the bottom to top approach actually. This hierarchy can be scrutinized from bottom node to till the top node actually. Okay, like it will be like industry a country to take. For example, we can take a country called Argentina actually. Inside Argentina we have n number of cities. In cities actually we have n number of factories, and in each factory we have n number of machines, and in machines we have n number of sensors. Okay, like that this hierarchical structure will come, and if you click each node actually or each twin here actually, you can able to see the properties of the twin. What are the data this particular twin is giving actually. Okay, so like output or emission type is are the two main properties coming for this the twin which is selected called p underscore wind underscore 03. Okay, and then also if you see each twin will these lines are there, and actually these lines are called relationships actually. So each twin is related to another twin in some other way actually. Okay, based upon this DDDL models actually. Okay, so this is how we need to form the digital twin the topology of a particular use case, and then we can be able to see the data which is coming from the device which is coming from the devices to our digital twin in the digital twin using these twins actually in the digital twin explorer. So this is a 2D representation of your digital twin, and also we have some things called queries here actually. What is the purpose of this queries means actually, if I want to select star from digital twin, it will give the entire ontology, but if I have a select star from digital twins where DTIDs particular twin alone, if I want to see, means that ID alone, if I give here and run the query, the data will be available here actually. The particular twins data, the particular twin only will be available in this digital twin explorer, and it will be actually exposable with all the properties which are mentioned as per the GDDL models which are present here actually. Okay, so this is about the Azure Digital Twin Explorer, and this is how we need to create a twin in the Azure Digital Twin Explorer actually. Okay, and now this is because this slide describes about the 2D description of data which is flowing into the Azure Digital Twin Explorer. But here actually, if you see, this is 3D scenes actually. The 3D um, the 3D explanation of the digital twin actually. For example, we have some gobo terms and all here actually. Okay, in this gobo terms actually, if I click actually, what is the exact uh, efficiency of this packaging line, and actually what is the hydraulic pressure of a particular robotic arm and all, actually we can be able to see. Okay, so this is how the 3D structure of a particular topology will looks like. But if you want to replicate this 3D scene studio like this kind of thing, but still it's in a preview state. But actually, if you want to do exactly like this, actually you need to have some CAD related diagrams should be there actually for this particular shop floor. Unless then it can't be done easily actually. But 2D for the 2D representation for the kind of CAD diagrams and it's not required, and we need to only define the DDDL models based upon the topology chart given by the particular shop floor operators actually. Okay, so how to secure this digital twins actually means actually that actually we have some authentications like OAuth and 2.2 token is written. Once, for example, if I'm sending any request from Azure Digital Twins to Azure Functions or any other services, first that it will be authenticated via some OAuth 2.4 token, and also next it will be authorized with your specified authorized access which is given to your enter ID, which is present in your Azure Digital Twins services as actually. So once these two requests are matched only, the particular data retrieval will be possible using the Azure Digital Twin, and that's how we have been securing the Azure Digital Twin. So for if you are going to create any use cases for using an Azure Digital Twin, so this is the way you need to consider all these services and all these services and all the components. It has to be included in this as a part of this architecture to make a to get a very good result of your use case, and also the security is also you need to be followed to get a very good result about your data and use cases for which you have been implementing this digital twin architectures actually. Okay, so that's it about this thing actually. So if you guys have any queries, you can ask me. And before that, actually, I should really thank the Trisha for our community and the Stephen Simon for giving me this opportunity to share my experience of how we need to architecture digital twin services in Azure IoT ecosystem actually. So thank you so much for your time, everyone, and thank you everyone. Thank you.
All right, Saravanan, let's take a few questions from the chat. Right. Let's take a few questions. Let's take the first one. Okay. This is one question about how does DDDL model differ from
Hmm.
traditional database schema, and why is it essential for this architecture?
Okay. Gokik Tomar actually, if you see that DDDL is if you now we have DDDL 2.0 actually case actually. Okay, it's a second version of DDDL came. So why it is necessary to build a digital twins means actually it's like it's not a traditional database schema. It's a kind of a JSON like schema actually, which will be like you need to be known that which property inherits which property and which model inherits which property. It's like of it follows an inheritance kind of data schema actually. That is only it's making it different from our database schema actually. And why it is essential for architecture means actually if you are going to build a Azure digital twin use case means actually based out of an architecture. So in that case, actually, you need to know what kind of models will be occupying my topology. Unless we don't have that idea, you doesn't know how many twins can be created in your ecosystem. So it will lead to what it will become complicated in your costing part actually. Okay, so that is the one actually.
Perfect. Thank you for answering that, Saravanan. We have a few questions, so we'll take that. There's
Yeah,
one by Khan is asking, what's one piece of advice
yeah,
you would give to an organization looking to move from basic IoT setup to a digital twin architecture? That's a good question.
yeah. Actually, if you have a basic IoT setup, actually it's a form of dashboards or anything actually, but you want to move to digital twin architecture means you need to first consider the costing part actually. Okay, so the
Hmm.
costing is really important. Also, you need to map the uh, hierarchical format of your twins actually, in which hierarchy my twins should follow and my models should follow, and you also should have the particular necessary DTTL models or the schema for your particular twins or models. So based upon that only, your entire architecture will be framed. And also, if you see, if you are now currently in a on-prem setup and you want to move towards a cloud-based setup like in Azure means actually, and you need your technical team should be analyzing what are the services which are really required, yeah, for your what is it actually the required for use case to be get executed in Azure, because we can use the components whichever we discussed today. Some components can be used, some components cannot be used for your use case actually. So that your technical team should be clear to avoid unnecessary costings actually. So that's my piece
Perfect.
of advice. Yeah.
Perfect. Thank you for answering that. Let's take another one from Sophia, and she's asking, how do you manage the cost and scalability of Azure Digital Twin solution, especially for a large scale project like a smart city?
Okay, managing the cost and scalability actually. For example, if you see, usually Azure Digital Twin Explorer is an open source project only. Actually, it's not like it's not licensed with the Microsoft itself. Actually, so whichever the twin which you are creating or n number of twins which you are creating, actually, it doesn't have any cost. But querying the twins actually, for example, if I am going to query some millions of twins actually, that also will cost actually some less than. $10 or something only actually. But anyway, actually, they are not going to query some millions of twins in a project actually. But in future, actually, it'll be like less than $10 USD dollars means actually it's like kind of the costing will not be a part if you are going to large scale the project like a smart city actually.
Okay, that's a good answer. We'll take another one. That's by Sakshi. She's asking, can you give practical example of how digital twin of a factory can enable predictive analytic for maintenance and automation?
Okay, actually, if you see, the digital twin is only the representation of data in the digital PD format or 2D format, actually. Okay, so in that case, actually, for if you want to implement a predictive analytics, the data whichever you got from it, actually, you need to create a model using Azure ML or with many of the number related frameworks, actually, and you need to give the predictive related data. To the system. But digital twin will not be directly sharing the predictive analytics later data or the futures or anything to the users actually.
Okay, we'll take one final question and then we'll take a break before we move to the next session. And that is by Scott.
Yeah.
Scott is asking, beyond smart cities and industrial IoT, what's a less common but powerful use case for Azure Digital Twin?
Yeah, yeah, smart buildings actually. If you see in Europe, in yeah, most of the Europe cities actually now having a the smart buildings actually. Okay, so in the smart buildings actually, Azure Digital smart buildings is one of the major use case of Azure Digital Twin actually. So apart from the smart cities and in industrial IoT, the smart buildings also plays a major role actually as a use case for on Azure Digital Twins actually. Yeah.
All right, Savan, that is all we have from the audience, right? Thank you so much for joining us today. Any final thing you want to add before we move to the next session?
Yeah, actually, it's been great for interacting with you guys, and these questions are really awesome. I guess actually, I really happy that actually people are really they know about digital twin, and we are actually they got prepared for this session and they asked this yeah queries to me actually, and there is time and I'm really thankful for you for giving me this opportunity in this conference actually. Yeah.
Yeah, hope to see you soon, right? If the Chennai thing works out, right? Then I'll see
Yeah.
you in just about 5, 6 weeks. right? That
Correct,
would be
yeah.
lovely, right?
I'm waiting for it, yeah.
Right.
Hmm.
And yeah, have a lovely evening ahead. And thank you so much once again.
Yeah, thank you everyone, and thank you. Yeah, happy weekend for everyone. Thank you so much. Bye bye.
Yeah, thank you. All right. All right, ladies and gentlemen, that was the wrap. Now, before we move to the next session. We still have about 12 minutes. I don't know why is it happening today. Usually, we often have we are falling short on time, but today we have a lot of time, right? But Scott says thanks, Saravanan. Rohit says thank you, Saravanan. All right. So let's take like 5 minutes, 5-6 minutes break, and then we'll move to the next session. So enjoy the commercial.
Welcome to Sharp Economy, the social fi platform empowering creators, communities, brands, and businesses. With tools like Contribute to Earn and Spend to Grow, we reward participation and put your skills on chain. A decentralized ecosystem built on Web3 principles, where transparency and ownership truly matter. Sharp Economy stands on 4 powerful pillars: the Sharp platform, bringing Web 2 to Web 3. The Sharp token, fueling growth and rewards. The Sharp Rewards app, where you learn, earn, and grow. And the Sharp Innovation Foundation, shaping the future. Step into Sharp Economy. Own your growth. Own your future.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
All right, everyone, welcome back to the Software Architecture Conference. We now move to our next session, and our next speaker is Nikita. He's a software architecture in industrial AI, and today he's going to talk about designing intelligence for the shop floor, a software architect's guide to industrial AI. It's a very interesting session. Hi, Dr. Nikita, and welcome to the conference. You're muted. Hello, can you hear us?
Yeah. Hi, hello.
Yeah, hello. Thanks for joining us, Dr. Nikita. Where are you joining us today from?
Today I am from Germany, from Erlangen. It's a Siemens city.
Yeah. So is it not a holiday period, like a vacation time in Germany, right?
Yes, August mainly it's some vacation time. That's why I will have vacation 2 times in August when all my colleagues have, and next time in September when my official vacation.
That's lovely. Thanks for taking out your time on your vacation and sharing your pearls of wisdom. I know you have shared your screen. I'm going to add your slides to the stream. Everybody else can see it. And next 35 minutes is all yours.
Yep. Thanks a lot. Yeah. So, hi, hello, colleagues. My name is Nikita. It's a pleasure to be here. And I am a solution architect working at the intersection of AI and industrial system, industrial automation. And mainly I'm responsible for bringing AI to the shop floor and to the factory level. And today I would like to talk about a topic which usually overlooked in AI discussions, that building intelligent AI systems for the shop floor is not just a data science challenge, it's an architect problem also. So maybe just to start, let me share a story from my experience. Once upon a time, we created a model, super cool model based on computer vision. And this model was responsible for detecting defects on a steel strip. And in a laboratory, it performs very perfectly. It gives around 98% of accuracy. So we decided to deploy it to the shop floor, and we did it. After a week, it started to failing. Accuracy decreased to 70% and even lower. And at the end of the day, operators rolled back to the manual inspection process. But why did it happen? So, of course, because factory, it's not a laboratory, we have a lot of lighting condition changes between shifts, dust accumulated on sensors, operators even using our software in a way we are not suspected. That's why it's not even about modeling issue, it's more about general architecture failure. But in general, why it's important to talk about AI together with architecture. So it's not a secret that AI is no longer an experiment, and it's highly embedded into mission critical systems, into production systems. That's why we as an architect should design a robust system around these models. Otherwise, we are setting ourselves up to a failure. That's why we need to apply our architectural way of thinking. For instance, such metrics as quality, ability system to be modified, availability, monitoring becomes essential for AI systems. And it's not even about building a better AI solutions, better AI models. It's about building and designing better software and solution architectures around these AI models in order to create robust, explainable, understandable systems and built for realities of the shop floor. But once we start talk about bringing AI to the shop floor, we face some issues, some problems, and my speech will be, I would like to share some of these issues we have faced, how architecture approach helped us to solve these problems, and maybe even give some kind of recommendation or maybe some kind of technical architecture patterns which can help your colleagues in your journey. So first of all, the biggest problem, it's dirty data. So industrial environment data is fragmented, noisy, undocumented, rather dirty. And for instance, from my experience, it was was a project when I discovered that firmware update of a concrete sensor changed order of sensor fields, and nobody has noticed it. And at the end of the day, model silently failed. What kind of architecture solution we can propose in this case? So first of all, we should treat data as a product. Maybe define data contracts, track data, where this data came from, formats, quality, maybe create some kind of data passports where we can define sources, schemas, transformation, quality metrics, try maybe to build, or at least try to build our systems on some kind of reliable systems with the explicit schema, immutability, and data validation mechanism. And in general, we should try built-in observability from day one into our architecture. For instance, we can try to use such kind of tools like Great Expectation from Python environment, or even OpenTelemetry to validate and trace data. So that's why architects also responsible for data quality. It's not only data scientists. The next problem, it's a split between edge and the cloud environment. So models are usually trained in the cloud, but need to be inferenced on the edge level, close to machines, with all this limitation of computeral power, of, I don't know, latency, and so on, so on, so on. So for instance, another experience from my previous projects, we try to deploy a model trained in the cloud to the shop floor device based on Jetson, and it crashed because of TensorRT compatibility. What can we do in this case? So first of all, we can try to use so-called separation of concerns. So at least try to create a very thin inference layer with pre-validation before we deploy our model to a device, to check whether this device supports one or another format, what kind of transformation do we need to perform in order to support this device, or maybe, for instance, I don't know, make some kind of hardware optimization on the end device. In this case, model became a plugin behind the well-defined interfaces. For instance, as a practical example, we can package trained in the cloud model in an Onyx format, and before we deploy this model to a concrete device, we can make a check, and for instance, we can even transform this Onyx format to TensorRT on a concrete hardware device. Again, from the architecture perspective, we see a clear separation of concerns. Maybe even we can talk about so-called hexagonal architecture, when model is a black box behind ports, and inference code is rather thin, which make it deployable, testable, and make it work in isolation. So the next problem we faced was the model degradation. So one of the biggest problem, even a killers for AI systems, because performance drop over time. Nobody noticed it until it became too late. For instance, another example from previous experience, it was a project about predictive maintenance. A model was given a false positive for a long time, even for a week. Nobody noticed it, and because we don't have a feedback loop, what can we do in this case? We can add logging, we can add validation, we can collect model health metrics, we can even create some kind of dashboards. Based on this collected data, collected metrics, we can create some kind of triggers which trigger model retraining included in our pipeline. So in general, we need also to include feedback loops in our architecture, maybe even store training data together with inference in order to be able to monitor model drift and maybe even retrain models so-called on fly. Another problem also well-known problem. It's a misaligned domains. Very often, models created by data scientists bottled onto process without any context. Example: we had a very cool model which performs perfectly, but operators ignore it because they did not trust on its prediction. What we did, we wrapped this model with a bounded context. We exposed this its confidence score, inputs, outputs, reasoning. What we see at the end of the day, trust increased. I would say it's a classical problem of software architecture, software design, because previously we saw likely the same problem between developers and business when they were talking on different languages, when there was a necessity to bring them on the same page. And previously we used domain-driven design techniques, approaches provided or proposed by Eric Evans. From this perspective, we also see a high potential for DDD, for usage DDD in this sphere, how to collaborate domain experts, data scientists, architects in order to create this model which work in a concrete context, understandable for business, for domain experts. The next problem, the last but not the least, is the team structure. Problem is that, as you know, architecture is not only about tech stuff, it's also about communication between engineers who participate, who work in our system. That's why we should also take this into consideration. As an example, again, it was a rather cool model optimized by data scientists, optimized for a throughput. But on the same time, plant manager was scared about downtime. Why does this mismatch happen? Because team were structured in a way which not reflects the product boundary. What we can propose, for instance, we can create a so-called stream-aligned team where architects, domain experts, data scientists can be coupled, paired together. Just to summarize, so after fighting with all these problems, we try to summarize our architecture recommendation, what we can as architect propose, recommend to our colleagues how to solve these problems, and we shape it as a 4 main patterns, 4 main advices. First of all, smart data first. So before you start building any kind of model, before you start building your architecture, spend time, invest time to understand your data, whether you have enough data. Is it some kind of reliable data? Is it enough to make some kind of hypothesis? Is it clear data? For instance, another example, from my experience, we spent around 6 months just to optimize our neural network model. But at the end of the day, we identified that half of our sensors had a timestamp drift. What will be the best solution for this problem is to build observability, to build in observability as a part of our architecture. Log completeness of data, freshness of data, quality of data. And just keep in mind that without good data, your AI system, it's just guessing or maybe even a trash. Another approach, try to decouple models from infrastructure. So what we see very often, AI models are closely coupled with PLC logic, with service logic. In this case, you cannot update it, you cannot monitor it, you cannot, even test it. How to fix? Define clear contracts between your AI logic and surrounding system, rest of your architecture. Use clean interfaces. Even as I already said, apply hexagonal architecture when a model just a black box behind the port. This approach will give you versioning control, stability, resilience, And even if model change, it will not break the whole of your architecture. And of course, your model should not be dependent on delivery mechanism. The third one, you need to close the loop. So you need to build your architecture for a feedback. For instance, log outputs, log prediction, log monitor accuracy, define the logic how and when model should be retrained, give operators a way to report about false positive or some kind of misclassification or any kind of misalignments. Why do they disagree with the system? Use this feedback as a part of your pipeline. And in this case, you can talk about building a learning system, not just about static one. And the last but not least, try to use so-called AI adapter layer. So you need to isolate, you need to treat your AI model like a separate component. Try to isolate your model with a specific layer. This layer should be responsible for data transformation, for normalizing inputs, outputs, error handling, fallback logic. Why? Because you are part of industrial system, and industrial system does not forgive it. For instance, if your system will send some kind of non-null moon to outside, something real will break. And this adapter will be some kind of shield between your system and the rest of architecture and make this integration safer. So main takeaways, just to generalize, treat data like a code with the contracts and observability, design for model drift, not just for accuracy, embed feedback loops into your architecture, make your AI components explainable, replaceable, and try to structure, to shape your team around value stream, but not technical silos. Maybe it's main lessons I have learned from my experience trying to bring AI to the shop floor. And maybe the last idea from my side, I would like you to reflect on. So you don't have to be a data scientist to build intelligent systems, but you must architect for them. So thanks a lot for your attention. Here you can find my contacts. I will be happy to answer your questions and stay in contact and discuss different interesting use cases around bringing AI to the shop floor or building AI solutions in general, how to, And for sure, I will share my slides after this conference in the LinkedIn or in any suitable format. Thanks a lot.
That was a very short and quick session, right? I think we are wrapping all the sessions very quickly today, so no problem. We'll take a few questions that we have from the chat. I'm gonna first change the layout. And there's okay. We don't usually have a lot of sessions, so I think we wrapped it quickly. We don't have a lot of or any questions. Anything you want to add before we wrap up this session? We don't have a questions, Nikita, from this session. Oh, you cannot hear me?
Yeah, I can.
I mean, we don't have a lot of questions from this session. I don't see any comments coming in. So anything you want to add towards the end before we move to the next session?
Just use best architecture. Just reflect about data. So you need enough data to build good AI solutions, and try to apply architecture practices you already know from building software to build AI solutions. And we'll be happy to stay in touch and to have a private discussions and share knowledge.
I'll pull in your contacts once again, so everybody who's watching, you can actually connect with Nikita on LinkedIn. Also, maybe just scan this QR code, and you should be able to get in touch with him. Thank you so much, Nikita, for joining us in this conference. I really look forward to hosting you in next year edition and in the other conferences that we do. Thank you so much and enjoy
thanks
your
a lot.
vacations.
Yeah, thank you. See you. Bye.
Yeah, bye-bye. All right, ladies and gentlemen, that is it. So it looks like we are wrapping all the sessions very quickly today. We still have about what? Oh, there's a question just came in. All right, never mind. We have what, 9:10? Okay. Our next session is in our next session is about 25 minutes or what, or think so 22 minutes. So never mind. I know the next speaker is already there, but we won't start that early. Ladies and gentlemen, let's take a break for 10 minutes, right? You can relax, you can grab a cup of coffee, and then we will see you soon. Enjoy the break.
Good afternoon. I'm Alexander Potapenko, and today we'll see why API-first banking is no longer just an idea. It's the standard banks must follow to stay safe, scalable, and fully compliant with fast-moving rules from FCA, DORA, MiCA, and FINMA. Most banks still run on one huge, tightly coupled system, a monolith. When one piece fails, the whole thing stalls. Under the FCA new 24-hour impact tolerance rule, a full outage is not an option. EU-wide DORA adds hefty fines if you can't prove resilience. So we need a different tech model, one built for failure, audit, and speed. Regulators are convergent. DORA demands operational resilience by January 2025. MiCA sets clear crypto custody duties. FINMA's 2023 Cyber Circular tighten cloud controls. All these frameworks ask for the same three things: clear APIs, strong audit trails, and fast recovery. API-first architecture hits all three. API-first means we write the interface contract first, usually an open API file. That contract defines how clients talk to each service. Then we build each service to honor the contract. This flips the old model. The API is not skin on top of a database. It's the core design driver. Because every call hits a secure gateway, gate, uniform auth, login, and rate limits. Teams work in parallel on well-defined services. New features drop in weeks, not months. And every request is logged and time-stamped. Perfect for audits. In practical terms, we break the big core into dozens of small services: payments, KYC, lending, crypto, etc. A single API gateway stands guard. If KYC gets slammed, payments still run. If lending needs an upgrade, we deploy it without touching the rest. If we will look through some actual cases, we could find that such guys like Scarlett used API first to launch a mobile bank in 4 months, quick enough to beat competitors. It now supports over 800,000 customers. That speed comes from clear APIs, not big bank releases. If we will talk about such newcomers like Finraise with product like CoreBank and BitConto that allowed you to keep fiat money and crypto on the same ledger, what is compliant with MiCA's travel rule is automatic because every crypto event flows through the same audited APIs as fiat events. We are not locked to one vendor now. Mambu and Scarlett give us a plug-and-play software-as-a-service model. Third Machine lets you code custom products. Saskada bolts one as a modern ledger beside an old core so you can migrate to SaaS gradually. And only Toom and newcomer Finray lets you self-host. Mark these dates: 17th of January 2025, Dora Live. 31st of March 2025, FCA's 24-hour tolerance fully enforced. Even Mika take its action from the end of 2025, and the Mika license is required. FINMA's cloud guidance is live now. The clock is ticking. Microservices and new risks. Network hops and latency. Services must agree on data consistency, and partial failure is normal. We need retries, circuit breakers, and strong contracts. And good news, with proper design, failures are isolated, not systemic. To manage the complexity, we need deep visibility. Distributed tracing with Checker tells us how a request hops through services. Prometheus metrics show real-time health. Grafana dashboard turn raw numbers into clear traffic lights. API first doesn't erase risk, it reshapes it. You now guard many small doors, not one big door. Each endpoint needs scheme of validation, short-lived tokens, and positive security models. But breaches are easier to contain because domains are isolated. The hardest shift is people. The teams must become domain squads that own code to production. That needs DevOps, Git, and SRE skills. Upskilling or hiring is essential. Culture eats architecture for breakfast like in a strategy. So plan culture change early. In an event-sourced ledger, we need override. Each change is an event. Finance teams can replay history at any point. Great for audit. But it requires new reconciliation methods. The upside? Instant traceability, no silent data corruption. And if we are talking about possible best practice cases, we have to emphasize: write the API specification first, enforce security at the gateway, version every interface, automate tests and rollbacks, stream every event to secure log. Follow these and DORA audits became a routine. Once APIs and logs are in place, we can add intelligence. And now meet MCPI, a model that reads new laws overnight and checks if any API change breaks them. MCPI watches Prometheus metrics and predicts overloads hourly basis. It maps strange traffic flows and alerts. It even writes draft tests cases, reducing manual toil. API first delivers clear structure, speed, strong audit trails. And at the same time, MCP turns those trails into foresight, predictive compliance, and resilience. Together, they future-proof your core tech. Thank you for listening. API first give us the facts in real time. MCPI mechanisms makes those facts actionable.
Thank you for joining us today. I'm excited to talk with you about a powerful approach in modern software development, feature flagging. If you worked on a project where releasing new features involved some praying and cross fingers, you'll appreciate the control and flexibility that feature flagging brings. Today, we'll explore not only what feature flagging is, but also how it enables gradual rollouts and A/B testing, giving development teams the ability to release features in a smarter, safer, and more data-driven way. My name is Maxim, and I'm currently part of the engineering team at Google, where I focus on developing Android Auto to enhance user interaction by enabling smartphone projection onto supported vehicle displays. In my work, feature flagging, gradual rollouts, and A/B testing play a major role in helping us deliver new features safely and iteratively. I'm excited to share some insights and practical approaches to using these strategies, particularly in Java, that can make development both faster and more reliable. And before we dive into the details, let me briefly outline what we'll be covering in this session. We'll start by looking at the fundamentals. Then, I'll walk through some of the key benefits, especially in Java applications, gradual rollouts, and A/B testing. I'll share some practical tips on implementing A/B testing with feature flags, as well as metrics to keep in mind to get the most out of your test on my way through the presentation. And to round things out, we'll talk about best practices and some common challenges, like handling security, managing technical debt, and ensuring that feature flags are used effectively without introducing complexity. Then, let us start. And let's start with the basics. What exactly is feature flagging, and why has it become such an important part of modern software development? Feature flagging, sometimes known as feature toggling, or in some cases kill switches, is a development technique that allows us to enable or disable specific functionalities within an application without deploying new code. Essentially, it gives us the ability to control which features are visible to users through configuration settings rather than through code changes. At its core, feature flagging serves a few key purposes. First, controlled releases. It allows us to roll out features gradually, targeting specific user groups or regions, which reduces risk by letting us test features in production but with more limited exposure. Second, improves stability, which is always a top priority. And feature flags provide an added layer of control in production, allowing us to roll out features gradually, reduce potential risk, and quickly disable a feature if any issue arises. Third, experimentation. By using feature flags, we can experiment with new features, gather feedback, and make improvements based on real-time user interactions, helping us make data-driven decisions. And finally, faster development cycles. Feature flags decouple deployment from release. This means teams can deploy code even when certain features aren't fully available, as those features can be hidden behind a flag. Overall, feature flagging is a powerful tool for teams aiming to deliver stable, high-quality features more quickly with less risk. By giving us greater control over what and how features go live, we can iterate, experiment, and refine in ways that would be difficult to achieve with traditional release methods. Now, let's take a closer look at the benefits in Java. First, faster development and deployment in Java. Feature flags are highly comparable with Java's mature ecosystem, particularly in CI/CD and microservices. Java developers can integrate feature flags directly within frameworks like Spring Boot through conditional beans or through remote configuration, which makes it easier to toggle feature based on environment-specific properties or configuration servers. Additionally, Java's extensive support for dependency injection and modularity lets us easily manage features and their configuration without extensive recording, making deployment faster and smoother. Moreover, It gives us improved stability for JVM-based services. Java applications often operate in a JVM environment where stability is paramount. Feature flags provide an extra stability layer for JVM-based services by letting us conditional load classes or modules based on flag states. For example, we can use Spring or Micronaut to set flags that control feature-related beans, enabling gradual rollout or selective rollbacks on specific server instances. And it gives us enhancing experimentation and A/B testing within the JVM ecosystem. Feature flags empower Java teams to implement experimentation at the JVM level, which is quite crucial. In summary, feature flagging in Java not only accelerates deployments and increases resilience, but also brings experimentation capabilities that are deeply integrated with Java's ecosystem. Now, let's a bit discuss gradual rollouts or partial rollouts and their advantages. Gradual rollouts are a feature flagging technique that lets us release new features incrementally, initially targeting only a subset of users. This strategy offers two key benefits: reduced risk and improved user feedback. Reduced risk. Gradual rollouts allow us to fine-tune the scope of a feature release, whether it's 5% or 10% or specific segments of users, providing a safety net for Java applications in production environments. We can manage rollout configurations at runtime, deploying features only to selected instances or user groups. By limiting the initial exposure, we can monitor for any potential issues, such as memory leaks or latency spikes, and check overall performance on a smaller scale before releasing the feature to a broader audience, and we can instantly disable the feature without any downtime. Then, improved user feedback. When we roll out features gradually, we capture valuable real-world feedback directly from early adopters. This detailed feedback is critical for identifying what's working, what needs adjustments, and whether any usability improvements should be made. Now that we've discussed the concept of gradual rollouts, let's look a bit at how to implement them in Java application. This involves using tools that support feature flagging and gradual rollouts, along with some practical code examples. There are several popular feature flagging tools compatible with Java that make it easier to set up and manage gradual rollouts. Tools like LaunchDarkly, Unleash, and FF4J provide robust support for gradual rollout with features like user segmentation, percentage-based targeting, and real-time flag management. Each of these tools lets us define feature flags, set percentage rollout, and control which users see which features, all from a central dashboard. Now let's shortly take a look at some basic example on how to implement a gradual rollout with a percentage-based flag using FF4J in Java. Suppose we have a new feature that we want to gradually roll out to users. Here's how we might set it up in code. Here we create a new feature and enable for some percentage of users, like 30%. And with quite a flexibility, by passing a user ID to the context, we can evaluate each user individually for the new feature flag. To move further, let's explore another powerful application of feature flagging, A/B testing. Feature flags provide an ideal setup for running A/B tests, where we can test different versions of a feature on separate user groups, gather data, and make data-driven decisions based on real-world feedback. What is the purpose of A/B testing? A/B testing allows us to compare two or more variations of a feature to determine which one performs better. With feature flags, we can easily control which version of a feature each user group experiences. For example, let's say we're testing a new recommendation algorithm in our app. With A/B testing, half of the users can be shown the new algorithm, the B group, while the other half will update to a placebo version of the update to see the old one, the A group. This lets us evaluate if the new algorithm improves user engagement or satisfaction before fully rolling it out. Feature flags simplify this by letting us toggle features on and off or adjust them for specific user segments, making A/B testing more flexible, controlled, and scalable. Then, metric collection. After that, to make informed decision from an A/B test, we need to define and collect key metrics. Here are a few common ones. Conversion rate, measure whether user take a desired action like completing a purchase, signing up, and clicking a specific button. Engagement metric, track metrics such as time spent on a feature, page views, and interactions. Performance metrics. It's important to also track any technical metrics like load times, error rates, or memory usage. And finally, user satisfaction. Direct feedback from users can be incredibly valuable too. Some A/B tests may use surveys or feedback prompts to understand how users feel about the feature. In summary, A/B testing with feature flags allows us to release new features experimentally, collect meaningful data, and use the data to optimize the user experience. This data-driven approach ultimately leads to more successful and when-received product updates. Now that we understand the basic purpose of A/B testing and the key metrics we need to track, let's discuss how to implement A/B testing effectively using feature flags in your Java application. Here are some small practical tips and details for successful implementation. And the first one, define clear hypotheses and metrics. Before you even start your A/B test, it's essential to have a clear hypothesis. For example, if you are testing a new feature or UI change, your hypothesis might be the new design will increase user engagement by 10%. Once you have a clear hypothesis, you need to define the metrics that will help you measure success. This could include conversion rates, click-through rates, time spent on a page, or even user satisfaction ratings. Clear objectives will help you interpret the data correctly and ensure that you are testing for meaningful outcomes. Then, ensure proper user randomization. A key element of A/B testing is ensuring that users are randomly assigned to the A or B group so that external factors do not skew the result. As I already mentioned, many feature flagging tools like Logically or FF4J allow you to easily manage randomized user assignments, but it's also possible to implement it manually. By assigning users randomly, you minimize bias and ensure that the result of your A/B test are reliably and statistically valid. Then, keep the test simple and isolated. When running A/B tests, it's important to keep the changes small and isolated to a specific feature or interaction. Avoid testing too many variables at once. For example, if you are testing a new algorithm, only focus on that algorithm's performance and not on other unrelated changes. This isolation will help you identify the direct impact of the feature you are testing. Now, monitor in real time. During the test, it's crucial to monitor how the feature behaves across groups in real time. Java feature flagging libraries and platforms often provide monitoring dashboards which can be used to track performance metrics like errors, crashes, and response times to identify any issues early on before the feature is fully rolled out to the entire user base. Then, ensure statistical significance. A common mistake in A/B testing is sending the test too early. You need to make sure that you've collected enough data to draw a meaningful conclusion. The size of your sample, the number of users in each group, is critical for statistical significance. Generally, you'll need a large enough sample to ensure that the results aren't just due to a chance. There are tools and platforms like Optimizely or A/B Testifying that can help calculate the required sample size and ensure that your results are statistically valid. If you are manually implementing this in Java, you may need to track sample sizes and perform statistical analysis once the test concludes. Gradual rollout during testing. Since A/B testing often involves testing a new feature, you can combine it with gradual rollouts. This way, you can minimize the impact on your users. Start with a small percentage of users for both A and B groups and gradually increase the percentage as you collect more data and confirm that there are no major issues. Feature flagging tools like Launch Darkly allow you to control the user percentage that sees each variation, making this process easier to manage. And then post-test analysis and iteration. After completing the A/B test, you need to analyze the results carefully. It's also important to iterate. If the test results aren't clear, or if neither version performs better, it might be a sign that more changes or different variables need to be tested. A/B testing is not a one-time thing. It's part of an ongoing process of optimization. Feature flagging is a powerful tool, but like any technology, it comes with best practices and challenges that need to be managed carefully. In the next session, we'll go over some of key best practices to follow when using feature flags, as well as the common challenges that teams face. And first one, keep feature flags organized. If your system scales and you add more feature flags, it's easy for them to become unmanageable. To prevent this, maintain a clear naming convention and organize your feature flags based on their purpose. Then, remove flags as soon as possible. It's critical to remove feature flags once a feature is fully rolled out and stable. Leaving unused flags in your codebase can lead to technical debt, and maintaining them introduces unnecessary complexity. Every flag should have a defined life cycle. Make it a point to clean up flags regularly and eliminate dead flags to keep your codebase tidy. Next one, use feature flags for safe rollbacks. Feature flags are not just for gradual rollouts, they are also incredibly useful for rolling back features if something goes wrong. If a feature is causing performance issues or bugs in production, you can disable it immediately without requiring a redeployment. To act quickly in response to production issues, minimize user impact. And the last one, use A/B testing and metrics for data-driven decisions.
Hi everyone, and welcome back to Software Architecture Conference. I'm your host Simon, and we are on the final day. It has been a little different day where every session is concluding very soon. That is why we had to conclude the first session very quickly, but we are on time now. Our next session is by Roman, who's a software engineer. We love software engineer at the Software Architecture Conference, right? And he's talking about a really exciting topic. We all use APIs, right? But it's a very interesting one. It's about navigating the world of API gateways, a comparative analysis of open source solutions. I'm really excited. Roman, welcome to the Software Architecture Conference.
Do you hear me well?
Yeah, you could be a little more loud.
I will try.
Yeah. I'm sorry, Roman. So where are you joining us today from?
I'm joining in from Hungary, Budapest.
Oh wow, I was in Budapest last year. Yeah, there was a conference. I love the city.
Nice.
All right, Roman, I see you've shared your screen. I've added it to the stream. Everybody else can see it, and next 30-35 minutes is all yours.
Okay, thank you. So hi everyone, my name is Roman. I'm a software engineer, and for my previous project I was researching open source API gateways to find best solution for the needs of our project. So today I want to share my findings with you, comparing API 6 gateway and also Kong, Tick, Kraken D, and Glue H API gateways, so that maybe it will help you make the right choice for your own project. Whether you are deploying in Kubernetes, managing multi-cloud environments, or just exploring API gateway options, this session will give you practical insights to guide your decision. And also, I wanted to say that this presentation contains links to the documentation and other useful websites. So just in case, I will publish it to my GitHub account, so you can use it as a reference if you ever need to choose the right open source gateway for your project. So yeah, I hope you enjoy it, and let's get started. So in the scope of this presentation, we will discuss what is API gateway, why do we need them, and then compare those five API gateways of my choice. And see at the end, we will see the future trends of evolution of API gateways. So why do we need API gateways? Over the years, applications have transitioned from monolithic architectures to microservices in cloud-native environments, and this process is going even nowadays. So as the number of services grows, so does the complexity of managing API traffic, security, and performance. So without the API gateway, we may face the following challenges. First is uncontrolled API traffic, where there is no centralized control over how services communicate. The second is security risks, which is lack of consistent authentication and rate limiting. The next one is performance bottlenecks, because without load balancing and caching, APIs suffer from inefficiencies. And the last but not least, the lack of observability, when there is no way to monitor API performance, errors, or request patterns. So here comes the API gateway as a solution to solve those problems. And what is actually API gateway? API gateway is a reverse proxy that sits between clients, which are users, application, or external services, and backend services acting as a centralized traffic manager. It controls how API requests are routed, authenticated, transformed, and monitored. API gateways are essential in microservices and architectures, cloud-native applications, and distributed systems. So let's discuss how API gateways solve those problems. The first problem, traffic management and request routing, it solves by routing incoming API requests to the correct backend services based on URL paths, headers, query parameters, user identity, etc. They also support the L7, which is application layer routing for REST, gRPC, GraphQL, WebSockets, and even TCP UDP traffic. And they also provide traffic splitting, enabling A/B testing, blue-green deployments, and canary releases. So regarding the performance optimization, API gateways improve performance by load balancing requests across multiple backend instances, caching frequently used responses to reduce backend size, backend load, by using compression to reduce response payload size, and by request response transformation, changing headers, payloads, or protocol versions. Regarding the security and authentication, API gateway acts as a central security layer for all API calls and implements authentication mechanisms such as OAuth 2, JWT, MTLS. It also provides rate limiting and throttling to prevent DDoS attacks and API abuse. Regarding the observability and monitoring, API gateways provide detailed analytics on API traffic. They collect metrics, logs, and they also provide the real-time dashboards for API traffic insights. And finally, API gateways support pluggable architectures. That means that they have their own built-in plugins. And they also allow you to extend the functionality of this API gateway by writing your own plugins using different programming languages. So yeah, let's go to the comparison of chosen API gateways, but let's first answer the question why I chose open source gateways for the topic. And the answers are maybe obvious. First is they are less expensive. For example, large enterprises save millions annually by switching from commercial gateways to self-hosted open source solutions. And open source gateways, they like you don't have the black box, so you know what exactly is inside. And open source projects evolve faster than commercial projects because there are large developer communities that contribute new features regularly. And unlike proprietary vendors, you don't have to wait for feature requests. They are faster, and you can even make your own changes or fix some bugs. So that's why. And in the scope of this presentation, as I already stated, we will take a look at the following API gateways: Apache API 6, Kong, Tick, KrakenD, and GlueH. And I will go over all of them one by one. I will provide this table of characteristics of each API gateway, and I will tell you from the start that this is not obviously this is not the full list of features, characteristics that they have, but because I wouldn't be able to put it everything to the presentation, but at least you have the brief understanding what they have, and also those links are very useful if you want to read more information. If you need this presentation, it will be available, and you can look at it. So Apache API 6 is an open source high-performance API gateway built for cloud-native, multi-protocol, and high-throughput applications. It provides dynamic configuration, rich plugin support, while maintaining ultra-low latency. So it's written like behind the scene. There is the OpenResty with Nginx and Luajit. The license is Apache 2.0, so it's fully open source. The storage options include etcd, which is distributed highly available storage. And for configuration options, you can use admin API, so you can change the configuration dynamically, and no restart is needed. Or you can use the files for configuration. It's like YAML files or Kubernetes CRDs if you run this API gateway in Kubernetes. Apache API 6 actually supports has the ingress controller for Kubernetes. Plugin system, there is the rich amount of built-in plugins for security, traffic control, observability, transformations, etc. And you can write your own plugins in Lua. Go, Python, or WebAssembly. From the authentication plugins, as you can see, there are JWT, OAuth 2, API key-based authentication, MTLS. Also, they support rate limiting, firewalls, and bot protection. And from the observability and monitoring, there is the Prometheus, Datadog, OpenTelemetry, Skywalking, and many others, which I couldn't put everything here. This API gateway fully supports hot reloading. This means that you can apply dynamic updates via admin API without restarting. And and that's basically, they also have the commercial support by API 7. So yeah, let's go to the next one, which is Con. Con Gateway is a high performance open source API gateway designed for scalability, security, and extensibility. It's built on OpenResty, which is Nginx and Logit also. And it offers a powerful plugin system, multi-cloud compatibility, and enterprise-ready security features. The license is the same, Apache 2.0. Storage options include DB-less mode, where you don't need any persistent storage, traditional mode, where you can use PostgreSQL, and hybrid mode. In hybrid mode, you can use, if you know that there are like data plane and control plane components of API gateway. Control plane contains the configuration and the functions to update this configuration, and control plane is actually the runtime that does the gateway logic. So in hybrid mode, you can have the PostgreSQL you should have PostgreSQL on control plane, but on data plane, you are not required to use any persistence. For configuration options, there is also the admin API and also files configuration, which includes YAML, JSON, and also Kubernetes CRDs if run on Kubernetes. Plugin system has over 50 built-in plugins for rate limiting, cache and security, traffic control, and you also can customize this API gateway, creating your own plugins on Lua, Go, Python, and even JavaScript. For authentication, the same list, I think, of plugins for JWT, OAuth 2, LDAP, and so on. And also for observability, pretty much the same list of plugins. This API gateway supports hot reloading via admin API. It applies dynamic updates without restarting, and DB-less mode also allows instant config updates with zero downtime. The next API gateway is TIC. TIC is a high-performance open-source API gateway designed for scalability, security, and multi-protocol support. It's built in Go, and it provides native GraphQL support, authentication, rate limiting, and flexible deployment options for cloud, hybrid, or on-premises environments. The license is NPL. Unlike previous API gateways, the storage options have Redis for gateway and MongoDB or Postgres for dashboard. Plugin system has a lot of plugins for security, transformation, and observability, and you can write your custom plugins in Go, Python, JavaScript, Lua, and WebAssembly. And yeah, for authentication plugins, you can see there are JWT, OAuth2, MTLS, auth tokens, pretty the same lists, and hot reloading also supported, and also DBLS mod allows instant configuration changes with zero downtime. The next API gateway is KrakenD. KrakenD is a lightweight, high-performance API gateway designed for API aggregation, request transformation, and stateless architecture. It's built in Go also. It's optimized for low-latency microservices, offering high scalability with minimal resource consumption. The license is Apache 2.0. Storage options, as I said, it's stateless. It's their philosophy. They don't support any persistent storages. And configuration options are files, so JSON or TOML files, so Kubernetes CRDs, actually not CMs, CRDs. And yeah, their motto or philosophy is that the configuration should be version controlled, so they don't support the admin API to update the configuration. It should be updated via files and stored in version control. Plugin system is middleware based, and you can write your plugins in Go. Yeah, and it supports many authentication methods also, including also Auth0 and the scope. And for observability plugins, there are also many options that you can choose of. Hot reload is not supported. There is such option, but it's only for development purposes, so it's not recommended to use in prod. And they also, like all of those API gateways, have commercial support. So yeah, let's go to the last but not least, GlueEdge API gateway. GlueEdge is a high-performance cloud-native API gateway built on Envoy proxy. It's designed for Kubernetes, multi-cloud, and hybrid environments. It offers deep integration with Kubernetes, advanced traffic control, and enterprise security features. It's built like the control plane is built in Go, but as long as it's Envoy-based gateway, the runtime of data plane is C++. License is Apache 2.0. Storage options, it's also stateless. For configuration options, you can choose files like YAML or CRDs if you put it in Kubernetes, or you can save configuration as key values in console. Plugin system is also Go, and yeah, there are many authentication methods and the plugins for observability and login. Hot reload is supported. It supports dynamic configuration updates without restarting. Yeah, so it's basically it's a brief discussion, brief comparison of those gateways, and yeah, let's let's also talk performance, because when choosing an API gateway, performance is a critical factor, especially for high traffic applications, microservices, and latency sensitive workloads. So I've prepared a small table here to discuss the specifics of these gateways, and this slide compares the data plane and concurrency models behind each gateway, which is what really drives the performance. API 6 and Kong both run on OpenResty with Lua JIT. Each uses multiple single-threaded workers with an event loop and Lua coroutines. Lua coroutines are fantastic at non-blocking I/O, as long as plugins don't block. If you add heavy regex routing, synchronous login, or a blocking database call, you stall a worker and tank throughput. Tick and Kraken-D are Go-based, so concurrency comes from Go routines over a pool of OS threads. That makes fan-out and aggregation very natural and tolerant of occasional blocking, but you still need to cap Go routines, like set timeouts and avoid CPU-heavy JSON transform in the hot path. On the other hand, GlueH uses Envoy in C++ with multi-threaded workers and per thread event loops. It often gives stable P99 latency under richer L4, L7 features like MTLS, WAF, or external auth, but those filters do add overhead if you turn a lot of these things on. So generally speaking, the big picture is that none is universally faster. The biggest performance killers across all of them are blocking plugin logic, synchronous access locks, per request external calls, TLS everywhere without offload, and heavy regex routing complexity. And I also provided here the links to their official benchmarks, but you should understand that like all those tests that they have been doing, they did for their own setup, and setup is different, and we cannot choose, like we cannot say that one of them is faster than another, because those comparison, if you compare all those benchmark results that I put here as a reference, it's not like apple to apple comparison, because there are a lot of things, like how many plugins are turned on, and so it's really hard to say which one is faster. Yeah, but apart from this, we can also see some properties of their API gateways, some features that they provide or don't provide. So, for example, Kraken-D doesn't support the web sockets. Supports only in enterprise versions. And also I wanted to say that I forgot to say that this commercial support that those API gateways provide, they allow you to have the support center to ask questions, to troubleshoot some problems if there are any in your setup. And also some of them provide more features, like those enterprise versions. They provide more features for you, like additional plugins. So for example, for API 6, there are built-in plugins for route limiting, but if you if you use the enterprise version, you can configure it more precisely, and it has more features. Yeah, and the next slide is gRPC support. CrackND doesn't support it in any of the versions. The license TIC has MPL license, which is a little less permissive than Apache 2.0. And also, I provided the list of the real customers that currently use those gateway. So you can see, and maybe this also can affect your choice of choosing API gateway for your needs or for your project. I don't know. Okay, let's finish with future trends, and for the future trends, I added 4 items here. So first, it's worth to say that as modern applications evolve, API gateways must adapt to new challenges in performance, security, and scalability. So those are the key future trends shaping API gateways. So first is AI built-in. So gateways will natively handle AI traffic, pick the best model provider per call, filter unsafe prompts or outputs, and cache answers to cut latency and cost. For example, AI-driven rate limiting or anomaly detection, they are already emerging in API 6 and Kong gateways. The second is Kubernetes Gateway API, which is the new standard, and it's supposed to replace the Kubernetes Ingress Controller for better API traffic management. And it offers improved scalability, performance, and extensibility over legacy solutions. So API gateways will fully integrate with Kubernetes native networking and service meshes. So, for example, Glue Edge and Kong Ingress Controller are early adopters of Kubernetes Gateway API. The third item in this list is identity-first security. The built-in blocks you will hear about in the future, but maybe you have heard this already before, like MTLS for service identity, OAuth 2 OIDC for user app tokens, JWT tokens, also short-lived credentials, only short-lived credentials that should be rotated often and refreshed automatically. And it's just like it's not a new thing, but it's becoming standard because like the standard in the future will be zero trust for accessing your application or to work between applications. So this is how it should work in the future. And the last, but also not least, API monetization and marketplaces. Companies are like nowadays are turning APIs into revenue-generating products. API gateways will provide built-in monetization, including billing, API usage metering, subscription-based API models, and self-service API portals for developers. And as far as I know, TIC and Kong Enterprise already offer API monetization features. Yeah, so I think it should be it. So thank you for your attention. And if you have any questions, I will try to answer them if I can.
Perfect, Roman. That was a really lovely session. I love the pace and everything that you shared. Right. Let's take a few questions from the audience. We do have it. Starting from the first, let's say, which one was it? Yeah, this one is the first one. It is, how does a team effectively handle the governance and standardization of APIs when using decentralized approach with multiple gateways? And you can pass it if if it, yeah.
Yeah, I'm not sure about governance and standardization.
Yeah, I felt the same way. It went over my head, to be honest. And maybe Rohit, you would like to, add more clarity there. There's a question from Dario. Dario is asking, what is L4 L7?
Yeah, so those are the layers in API gateways world. So, for example, L4 is the transport layer. You should think TCP, UDP. You can balance, allow, deny traffic based on IPs, ports, and connection properties. And L7 layer is the application layer. And you should think HTTP 1 or HTTP 2 or gRPC, WebSocket, the actual application protocols. Yeah, I would say.
Perfect. Yeah, thanks for answering that. I hope, Dario, that that question helps. We'll take another one from Sophia, and Sophia's asking, what are the key metrics you would recommend tracking to monitor the performance and health of an API gateway?
I don't know, like the maybe RPC, RPS requests per second. Also errors, any errors that happen in during the work of API gateway. I don't know. Basically, like. You need to choose your monitoring tool, and I don't know. It also has like some default metrics that you can collect. Yeah, but I don't know. I would say like this.
That's more than enough, right? Let's take another one from Anatis. I don't know how to say that name. Can these gateways run outside Kubernetes? I think, of course, yes.
Yeah, they mostly they are they most of them they support Kubernetes, and it's like the must-have. But API 6 can run on VMs and containers, and I tried it actually. It works okay. Conk runs. Also in VM containers. Yeah, you can look at the table. There are the deployment options. You can look at also Kraken-D is it has very simple VM container deploy. You can run it in Docker or usually in Docker. And QH, yeah, it's best for Kubernetes, but it can run off, and like for development purposes, you can obviously definitely run it locally.
Perfect. We'll take
locally or not in Kubernetes. Sorry.
Okay, you mean locally on your system, not on the Kubernetes. Okay. All right. Let's take one final question before we move to the next session, and that is by Claudio. And Claudio is asking, hi, I would like to ask, what's the difference between Lua coroutines and Go coroutines in these gateways?
Well, it's actually a good question because, and maybe I will show this. No, it's not. It's not the presentation, but it's okay. Lua coroutines they run outside inside OpenRest single-threaded worker, and they are cooperative. They like coroutine runs until it yields. So this lets one worker interleave thousands of requests with tiny overhead, as long as the plugin code never blocks. So this, like those coroutines, they hate blocking, I would say. On the other hand, the Go routines, they are lightweight threads scheduled by Go runtime over a pool of OS threads. OS threads. They are preemptive and can run in parallel across CPU cores. So they are more resistant to those blockings like this.
Perfect. Thanks for asking that. We have Scott saying loved this session, Roman, and we have a comment coming. Very interesting presentation, Roman. Thank you so much, Roman, for sharing your pearls of wisdom. Any final thing you want to add?
No, I would say no.
No, you will just say, let me go. It's weekend.
Nice
It's
to
evening. Let me go.
Yeah, nice to participate, and yeah, it was interesting experience.
Yeah, thank you so much, Roman. Have a lovely weekend ahead, and hope to see you in some other events. See ya. Bye-bye.
Thank you. Bye.
All right, ladies and gentlemen, now we move to our next session. But before we do that, let's take a quick minute commercial break, and we'll be back soon. All right, everyone, welcome back to this conference. We are now moving towards the end. We only have just maybe 3 to 4 sessions before we wrap up this conference. And joining us now is Alina, who is a software engineer at Amazon, and she's going to talk about building AI apps with AWS. I love Amazon Q and Bedrock. So without any further ado, hi, Alina, and welcome to the conference.
Hi, everyone. Yeah, nice to meet you.
It's so good to see you. Where are you joining us today from?
From London.
Oh, wow, London. Oh, that's nice. What time is it? 6:30 or something?
Yeah, 6 Friday.
All right. So we won't take much of your time, Alina. I know it's a weekend coming up, right? So I'm going to add your slides to the screen. Everybody else can see it. And next 35 minutes is all yours.
Thank you. So hi, everyone again. So I'm Alina, software engineer at Amazon. And today I'm excited to walk you through how it's possible to build real AI applications on AWS. So from foundational models to fully integrated agent systems. So this, I would say, isn't just about features. It's more about architecture, patterns, tooling. So let's start. So yeah, just to review again. We are going to follow a journey starting with foundational models, the Bedrock. Then we'll dig into RAG, retrieval augmented generation. So then we'll move through AI agents and orchestration, and close with key takeaways for your architecture decisions, design projects. So think of it more as a system level view with just enough depth to take action and start building your applications using AWS. So let's start with foundations, literally. So foundation models are these giant pre-trained networks that serves as a springboard. Think of LLM models like you will know Claude, ChatGPT, or AWS-specific Titan. So we are no longer training from scratch. Instead, we are specializing and integrating. So, why Bedrock? So the Bedrock let us tap into these models without hosting them. It's serverless, fully managed, and supports text, chat, embedding use cases, so on. So it simplifies development workflow, I would say, dramatically. And since it's API-based, we plug in our applications, projects, without, I would say, heavy MLOps overhead. And literally that's it. With simple LLM, you can start and have your application hosted running, and it will work in a classic vanilla style query response. But there is another important moment. So think about your prompt structure. It's a key. So it's production. It's not enough just to ask model a question. So it's important to define the role, context, constraints, and define them very clear, because this is your runtime logic. So getting this wrong means your model acts in unpredictable way, and it might be a bit dangerous. So this is what it looks like in practice. So in Bedrock, it's available just invoke model or invoke model with response stream. And these are your gateways. And this abstraction makes it ideal for integration, like from scratch in applications, workflows, chatbots, and even in internal developer tools. So as what's the reason for like response stream? LLM response here latency heavy, and if you expect really large output, maybe that's the case to use like the response stream. So at least you can show some information for your user while you're waiting for the full reply. And yeah, so that's a good starting point for AI application, and it might be powerful, but I would say power comes with responsibility. And there is a tool called AWS Guardrails, and it lets control harmful output. So whether it's through filtering unsafe content or defining what the model can or cannot say. There are other tools as well which might help, and we will deep dive into them a bit later. But for a start, let's think of guardrails, and it's just here how it looks architecturally. So you have guardrails to kick it into interface time. So the first response goes to the guardrail, then to LLM, and then back. And I can give like practical use case. Imagine you have a shopping assistant bot, which might help user to think what sort of products user can buy in your shop, and LM might provide recommendations. Sounds great, but if we don't have guardrails, users might abuse your setup. And imagine user can ask LLM, please write me a perfect plan for my vacation in Italy, and LLM will do the job, burning your money, burning your infrastructure. And because LLM, it just works on request and response, so definitely control it from the prompt or from specific surfaces like a guardrail. And we are moving to the second part, and it's getting into retrieval augmented generation. So here I would say models, they are generalists. So, and RAG turns them into experts. So how it happens? It happens by feeding them your data at query time instead of fine-tuning, and we retrieve relevant docs and add them to the prompt. So that's the RAG. That's the context knowledge base, I would say. But let's do one step back before comparing. What are the options for us when we think of turning like generic knowledge of LLM into specialized context, when we would like to have pre-trained LLM on something? And there are two ways. It's pre-training, it's fine-tuning, a knowledge base RAG solution. And fine-tuning it means you need to define a labeled data set, and data set should be balanced. It should be properly structured to achieve good results. And then you need the GPU, some knowledge how to train a model on top of your data set. And then model will understand your specifics. So again, fine-tuning is retraining on your data set, and it's costly, it's static. And RAG, on the other hand, it dynamically retrieves updated content from vector stores, enabling agility. So it's cheaper, I would say faster, better suited for rapidly changing domains. That's the brief overview between two methods. And definitely, if you have like changing setup and you cannot retrain the model every time, that's the way to go. And it already shows good results. So, and here's the typical flow. So user asks a question, we retrieve top chunks of information from the knowledge base, we send it to the prompt, we again get it back, and it provides more accurate results. So it's pretty elegant. But how do you define the RAG? For example, sounds interesting, so you would like to test in your setup. And here where it gets interesting. So moving forward with RAG implementation. And you would like to tune your chunk sizes for context retention. Then you will need to store full original chunks to reuse it. And when you store your text in the embeddings form, and embeddings, again, it's vector representation, how LLM understand the context from the input. And then you store it in knowledge base, and most probably you will think of isolation in this setup, considering of some filters, metadata filters, so user will be able to access only specific sections from the setup. And all this, it dramatically improves the relevance. So when you move with RAG approach, so choose a solid embedding model, and there might be different options, and proper scalable vector database. And we will review like OpenSearch or Kendra, and we will review them later in the presentation. So just to recap how the ingestion process looks like. So we have multiple files, and we would like to store them in the data source. And it should be scalable. It should support multiple formats. It might be S3 if you work with AWS. So then from this data source, you do the chunks of each document. From each chunk, you do the embeddings. It might be Titan embeddings in AWS. And then you store them in the vector database. So there are multiple parameters you can tune here. So you can use fixed or sliding chunk strategy, depending on the type of documents. Example might be legal, product data, some Asana tickets, Slack conversations, and size of chunk might affect on your RAG accuracy. So it's minor tunings in the RAG setup. So what are available options in the AWS stack for it? And the first, it's OpenSearch. And with OpenSearch, we manage vector database with full control. So document ingestion, embedding, indexing, it's all customizable. So it's great for scaling across multiple different use cases. And on a picture, you can see two flows. The first one, it's how you insert a document in the knowledge base, and it goes through as you can see, first it's you need to generate specifically embedding, then to put in the OpenSearch, and then there's a second workflow, how it works with the query. When user asks some questions in your chatbot assistant, again, it converts input text to the embedding. Then it goes to the knowledge base. It performs semantic search, selects top ranked replies, puts all this context into the LLM, and returns reply. That's the workflow or the process in the OpenSearch. And there is another option in AWS. It's Kendra, and it's more, I would say, plug and play. So you drop all the documents in your S3 bucket, and then you just define how often you would like to run synchronization on top of this source bucket. And AWS handles indexing and retrieval. So it's optimized by default for semantic search, and it integrates directly with Bedrocks. And with Kendra, there are already defined mechanisms how you define files metadata with filters. So it's easy to separate different topic projects in the knowledge base. And there are some, I would say, built-in crawlers, because crawlers like from Quip, from Slack, and what you need is just to provide your token, and then you can from the UI in your account, just click, and crawler will be pulling your data and placing in S3 just for you, and then it will be automatically after synchronization included in your knowledge base. So how to choose between them? So I would say Kendra gives you simplicity. It's a bit more pricey. So OpenSearch gives you flexibility. I would say for quick projects, maybe for some startups, if you want just to test ready solution, you can test Kendra, and you can start with Kendra. But for more control and customization, so in scale, it's more likely OpenSearch. What's about security and how it's controlled in the RAG solution? So definitely when you build your RAG solution on top of data sources, you should be responsible for cleaning all the data. So, and there is a tool called Comprehend, which it can anonymize your logs, sensitive data sets, it can clean documents before ingesting into knowledge base. So it complements previously mentioned guardrail setup to ensure like whole loop compliance and data privacy. So here how it looks. So Comprehend handles pre-processing, data cleaning. This is especially critical as we discussed in data storages, knowledge bases, or compliance-heavy workloads. And then your information is PI cleaned, and you can be pretty safe to use it in other processes. That's the workflow. So yeah, and once you're live, I would say observability, it matters in your knowledge base. And there are multiple tools. One example might be just Ragas library. And such libraries, they can help to track hallucination rate, retrieval hit rate, and relevance in your knowledge base. So this feedback loop lets you continuously tune your RAG quality. But what's inside this library, I would say, because it's not classic NLP task, and classic approach, they don't fit well, because when you think of metrics, first step you need to define a data set with some query answers expected based on the information you have. And it's not like text-to-text match. So usually there is another LLM evaluating reply from LLM, and that's how recent metrics are based looks like. So just to again set up your monitor. So create evaluation data set. So choose your metrics, set the schedule like cron job, who will trigger from time to time, and then plan to have manual audit reports just to track and understand what happens in your setup. And here you can see example of possible board for the knowledge base. So you can see metrics like faithfulness, context relevance, answer similarity. Also, you can filter and see what sort of questions usually fail and they are outliers in your metrics. And it might be important. Going back to the chunk size or specific data, specific type of information that you pull in your base. I can give you an example. LLMs, they might not understand table formats, and if you pull automatically some information in the context like in a table format, and you have specific query answer in your data set related to some information in the table, you might track and see where in the flow you have some issues. Like maybe you should update your crawler, how you parse the table format, represent it in a different view. That's why monitoring is important and observability matters. So going to the agents part. Yeah, let's talk about the agents. So I think up until now we focused on just answering questions. But agents are different, so they take action, they reason, they follow instructions, and they can connect to different APIs. And Bedrock now supports creating robust agents with built-in orchestration. But before going to architecture pattern, let's review what provides reasoning inside agent. And it's called React technique. It's from publication, you can see the link. So and React stands for reasoning and acting. So it's a prompt technique. The model reasons out loud, takes an action, observes the result, and loops and reiterates in these actions again. And this approach makes LLM behavior transparent and controllable. And recent AWS Bedrock, it supports this React prompt pattern. So there is a question, thought, action, observation. It's a hidden system prompt, so you cannot see it, because when you define the agent, you write some profile instructions, some default prompt, but then this prompt with user query, it's wrapped under the hood with system prompt, with this React technique. And just a note, at this stage, agent knows all the tools and actions available in the setup. And this allows the model to reason, to act, and adjust based on results. And here, just let's go for the real example. Imagine a user says, I can't access the dashboard A. And this is the query. That then it's hiddenly wrapped in this prompt, React prompt. And then happens the first reasoning call. So, and the fault is just, okay, user cannot access. Maybe I should check permissions of specific user. And if this action is available, it's performed, received output from the action. Then will be observation, then maybe a couple other actions, couple observations, and then additional call for reasoning. And then LLM might decide, so, okay, user cannot access the dashboard because of external network restrictions in the network. So in total, it will be more LLM calls than in simple. This example, it will be 5 calls. And that's the logic behind the agents. And that's the idea how you can work with LLMs at scale. Here, it's how you define them in AWS Bedrock. So first step, choose a model, set up instructions, connect to the knowledge base, the RAG we previously discussed, or some APIs, define some action groups and its permissions isolation. It's Open API plus Lambda. It's default recommended setup. And this, it's giving your model tools and letting it use them. So the full flow, user asks a question, then agent reasons, call actions, process results, and continues in the loop. So each component is modular, so you can version, test, and trace every step. Yes, most probably you can, on the diagram, you can see S3 bucket. And most probably you will ask why I need S3 bucket here. Is it for memory of the agent? And here it's a place just to mention the setup, how tools are connected in the current Amazon Bedrock setup. So you have Open API schemas. So agent knows what is available. And it's recommended to use Lambdas as implementation for Open API schema. So you define the schema, connect to Lambda, then expose it to the agent, and it is used to connect models to internal system security. But what happens if you already have a server and you don't want to rewrite everything in default recommendation with the Lambda? And for longer running tasks, right, like return of control. So there is a implementation that agent hands-off work, and app should complete the process, and then it calls back the agent, and that way agents stay responsible without timing out. So how it happens? Tool takes long, and usually you call the Bedrock from your tool, and Bedrock says, okay, I think the action should be specific from the specific tool with specific parameters. Please do the job and then return me results with invocation ID. So I will proceed with my decision making. So understand your timeouts, limits. Maybe it's 15 minutes Lambda runtime. Maybe it's Lambda event payload. So consider this when you set up your agents in your projects. Let's talk about versioning. And so, of course, you can version agents, alias them, and inspect detailed orchestration logs, like an audit trail or every thought and action. And it makes testing, debugging easily, or you can create different versions of agent and filter it on parts of your traffic and measure accuracy and improve on top. So there are multiple available traces from agent execution, runtime, and there are multiple of them. And here you can see example of orchestration trace. So moving next. And let's review what is Agent Core CDK, because it's recently announced a preview this July of Agent Core. And what happens in Agent Core CDK? You define your agents in Python. Here you can see example of execution graph. So then AWS builds container on top of your Python package, Python setup. It goes to manage runtime. It gives you endpoint, and you communicate with this endpoint. So it's like Lambda, but for your AI logic. What happens? How it is deployed to the account? So Agent Core wraps your agent in a container. It is pushed to ECR. So it spin-ups runtime similar to ECS Fargate, but it's fully managed. And you don't need to deal with ECS or Lambda. So all this is abstracted. And once it is deployed, you can connect with your agent using the endpoint with the classic bot-of-free calls. And literally, it's just like open interface in how you can list resources and understand the information of your agent or invoke agent, etc. So here, a quick comparison. CDK, so it's provisioning infrastructure, buckets, lambdas, and SDK. It's for invoking and interacting with those resources. So the output. So just to repeat, CDK defines infrastructure, and SDK interacts with it. It uploads files, invokes agents. So think of a CDK as provisioning and SDK as operating. And you likely use both. So let's compare with like Agent Core CDK recently announced with the previous setup. I explained with you about agent with OpenAPI, schema, lambdas, return of control, all this setup. So the same Boto interface, they support exactly the same. But Agent Core gives you Python-defined agents that AWS runs for you. And classic agents are easier for a quick start. But Agent Core, it gives you some, it's also good for quick start, but it's kind of custom logic. So here, let's go through the Agent Core summary. So again, it builds ECR image, deploys for you. There is no infrastructure control. It's called Agent Core Runtime. So it's managed runtime, and you communicate with the endpoint. So you don't directly see resources in your account. It's just runtime. So, but what you can control the execution flow in your Python. It's more flexible because you can use multiple different libraries like LangChain or other in this Python setup. You can create some infrastructure around this agent using CDK, but it's just IAM roles or communication with the database. And that's how you can connect it with your other stacks. But again, you don't control the infrastructure itself. And it's just a preview because it was announced in July, but it gives a lot of flexibility, and it's definitely worth to test it. So moving to the takeaways part, and so let's recap. So Bedrock lets us use powerful models and pretty fast. Knowledge-based RAG connects them to your data. Guardrails comprehend, they ensure safety. So if you need some acting, reasoning, it's agents, and they are available. And Agent Core CDK, it gives you development velocity. So if you are building AI at scale on AWS, definitely this is your stack. And yeah, so thanks for spending the time with me. I hope this gave you both architectural clarity and inspiration. So it's not a magic, it's systems, pipelines, careful design. So yeah, thanks a lot.
Absolutely amazing, Aline. I really love the entire structure of your presentation. Right, we do have a few questions from the audience. Let us quickly take that. The first one coming actually from Rohit. He's asking, what's a good tool for orchestrating different AI services on AWS?
So yeah, the orchestrating of agent. So you can have like this idea of MCP protocol, or your Lambda can connect to the different resources. In terms of orchestrating, well, in Agent Core CDK, you can create the flow, or you can use a step function if you want to control execution graph. So I hope it answered.
All right, I think that helps. I have only used AWS through Terraform, so I don't know much. So yeah, there's another question from Sophia. She's asking, what are the key considerations for designing scalable AI agents? Is there anything like scalable AI agents at the moment? People are just making AI agents, right?
Yeah, good question. And that's the slide I mentioned about like CDK, Agent Core CDK, especially this infrastructure part. And we'll see how to evolve at the time. But right now, like I think AWS just open for experimentation, and it will handle scaling for you, and you don't control this agentic runtime. But if you are building, and it's good when you test, but if you have it in your own setup, of course, it will be controlling everything infrastructure on your end.
Yeah, I think what I see, nobody really knows how to build AI agents now. Everybody is just experimenting. It's still very new. I know there are tools, other open source tools, and everything else, but yeah, it's still relatively very new. There's another question from Khan Singh. He's asking, how do you manage an AI agent's memory and state across interactions?
Yeah, it's a good question. And for the memory, when you go with a default agent, the classic one I mentioned, there is built-in memory, and you can define like the limit of the memory. So all the dialects they stored or some preconceived information. But when you define the agent using LangChain or agent core, you specifically define the memory storage in the code, and then it's attached to the agent. So you can control what you put in the memory, what is stored there, and what will be the limit, and how to operate with this memory.
Yeah, I think you could be using any database that you want, right? One comes inbuilt, and then if you want to go beyond and experiment a few things, you can put any one. Let's take final one from Hemant. He's asking, how do you handle data privacy when it comes to AI agents, acts for users? I don't know what acts for user means. But...
So yeah, it's a good question because acts might be different. So no one wants to give admin permissions in the runtime, in the production runtime. But the services I mentioned at the start, like guardrails comprehend. So because the actions that observability is text. And at this stage, you can filter what happens, and you can define the rules in the prompt to limit possible actions.
Perfect, Alina. I think that is all we have from the comments, right? So thank you so much for sharing such a lovely session, right? Anything else you want to add before we move to the next session?
No, thanks a lot. Thanks everyone for attention, and yeah.
Yeah, thanks for accepting the invitation, Alina. I really appreciate it. I know it's Friday evening, so I won't take much of your time. Have a lovely weekend ahead, and hope to see you soon in some other events. Thank you.
Bye.
Bye-bye. All right, ladies and gentlemen, that was you learning about AI from the AWS ecosystem. I encourage you all to go ahead and try it out. AWS is free for 6 months. You get up to $600 credit, and I should be developer advocate at AWS. Why am I promoting AWS? The other speaker, ladies and gentlemen, is not here, right? So what we're gonna do, we're gonna play a very recorded session, and it's a lovely session. Oh, what happened? Did I get an email? No. Yeah, okay. Yeah, I'm gonna play a very lovely session that's on, a scaling multilingual podcast from podcast to podcast. Please enjoy it, and the last 2 sessions are gonna be live, so please join us. Thank you so much, and enjoy this session.
My name is Rustam, and today we are going to talk about my little project, scaling multilingual podcasts, automating end-to-end content localization with the OpenAI API suite, how to automate podcast translations with Whisper, GPT-4o, and TTS-1. In short, this is a talk about how to get a podcast in some random language and translate it to your favorite language so that you can understand everything, and that's it. Now let's move on. The first question you would ask, why do we need this thing? And there are multiple reasons. First one is for content creators, so that when someone creates a new podcast, they they record it in some language, but they want it to be understandable by people from different regions, from different countries, for people who know and who don't know English. For example, if the original language was English, and so on. So if they could take their podcast and translate it automatically to some other language, then they would just increase their audience without much effort, without re-recording their podcast again. The second reason is that why we need to automate it, and it is because we want to record the original podcast as good as we can, with with all the tones and styles, with all the jokes, with everything, and we don't want it to be lost in re-recordings. When well, if you speak two languages, for example, if you speak English and some other language, you can make, and English is your main language, native language, and you can make jokes in English, you can add accent to your words, to your speech in English, but you cannot do the same for the second language. But if you use some software, it will do this for you, and this is a very good reason to use some automation instead of manual re-recording your podcasts. And the third reason is, of course, to work less, to reduce manual effort, because the less you work, the more time you have to do some other things, and you can spend it on recording new podcasts, or on your life, on your work, on anything. So it just saves time. So this on this slide you can see some of our core features which we have. I will go from the first one to the last one in sequence. So the first one is Podcast Downloader. This is a sub-module which we use to download original podcasts. So we have a platform which downloads podcasts from somewhere, and this is a module which does it. The second module is transcription module. Transcription stage is when we take the podcast and make it, I would say, take a transcription from it, and so after that we have just a text without any audio recordings, and then we will work with this text mainly. Text processing, we need to process the text because audio recognition tools may not recognize something, and also when you just speak in a podcast, you can have not finished sentences, and you don't want them to be present in the translated podcasts. So if you can make your podcast even better, why not, right? The next step is speech synthesis. So we take this improved text of your podcast and synthesize speech. We can use multiple voices for it, different voices. We can play with the speed of the podcast. We can do anything with it. It's just take your text and make it to a speech. The next one is auto assembly. This is, I would say, a bit of an artificial problem, and it arises because models which can generate text, audio from text cannot take a lot of text and generate audio from it. We should do this chunk by chunk. And for example, if we have a very long podcast and we have 3 different chunks, like first part, second part, and last part, then we have to merge them somehow, and it's not as easy as you might think. It's not like you can take byte array of the first file, audio file, second file, third file, merge them and be happy with it. No, because there are some problems, mainly with the metadata that you have in these files. For example, like length of the file of the recording, or different kinds of codecs that you use for producing these files. So you can have multiple problems and you have to solve them somehow. we did solve them, and I will tell about it later. And the last step is RSS generation. So the RSS feed is a thing which we can send to the platforms with podcasts, so that on these platforms, how does it work? They fetch these RSS feeds from somewhere. For example, if we host this RSS feed on some website or on some host, doesn't matter. These platforms check these RSS files from time to time, and when they see that there is a new entry, and the new entry is a new podcast episode, they add it to their platform, send notifications to users about this new podcast, and do other stuff. So this is only used by these platforms. Okay, let's go next. The key technologies that I used for this project. Well, I say we because we made it with a friend, but he's not here right now. But yes, I did it with a friend. The first and most important one, the language, the programming language, and we used Kotlin for it. And there are multiple reasons for that. First reason is that it's pretty easy to write stuff on Kotlin. It's a mixture of Java and Python, and you have best of both worlds. You have the speed and type safety of Java and all the libraries that you can use in Java, you can also use in Kotlin. But you also have much better syntax than Java's in Kotlin. It's more like Python-y style, but with all the type checks, with the reflection, with everything. The next tool we use is Podcast4j, and it's just a library which we use to fetch podcasts from a library of podcasts. And for the library, we use podcastindex.org. This is a very huge library of podcasts, and it has pretty good API so that we can fetch info from there, and not only the podcast audio file, but also the name of the podcast, description, some images, some links, the list of authors, everything. The next one is OpenAI API. This is the heart of this project, and we use it for three purposes. First one is to transcribe audio, so that when we have the audio for the podcast, we can take just a text from it, just a speech. Then we can translate it to a language of our choice, and we use OpenAI to translate because it translates stuff like jokes, and it doesn't keep half sentences in it. So you can just translate it. You can just open ChatGPT and send a text to it and say translate to my language, and it will translate it with a very good quality. And the third model which we use from OpenAI API is to convert text to speech, so that when we have this text, we can create the speech, which is the final product of this service, final product as an MP3 file with the podcast on the different language. So we also use OGHTTP with Cater, like OGHTTP engine for Cater, to do HTTP requests to OpenAI API. And that's just it. Cater is a very nice framework written on Kotlin for Kotlin, which supports coroutines and all this stuff. And it has very nice syntax for Kotlin. So it's really easy and comfortable to use it. Then we use Jackson for JSON data, and we have a lot of JSON data actually. The first stage when we have JSON data is when we download stuff from podcastindex.org. It all comes to us in JSON, and we have to parse it, handle it, save it somewhere, and so on. So in these JSON files, we can have like title of the podcasts, description, authors. We can have links to the to the images for this podcast. We have links. We also have a link to the MP3 file itself. We don't download it directly from the API. We just have this link, and then we hit another endpoint with this link and then download the MP3 file. The next one is XML APIs, and it's just to build an RSS feed. RSS feed is an XML file actually with structure like you have the root of the XML file, then you have an element which corresponds to a specific podcast, and then inside of it you have like title, description, and so on, and then you have a list of episodes with similar fields like description of the episode, title of the episode, authors of the episode, and also the MP3 file, a link to the MP3 file. So this is what other podcast platforms will take from this RSS feed to understand when they have new podcasts. And FFmpeg, FFmpeg is going to be used to merge the MP3 files. You remember I was talking about chunks of big, large MP3 files when we have a long podcast. So FFmpeg does a great job of concatenating these files. So far, we only worked on pretty normal length podcasts, 30, 40 minutes, and they all fit into one file. But if a podcast, let's say, lasts for 1 hour, 30 minutes, it's pretty much guaranteed that you will not have one chunk, but you will have multiple chunks, and you will have to merge them. We don't do that yet, but it's in our plans. So yeah, just a bit more about fetching podcast metadata and audio from somewhere, and we use podcastindex.org to download all the related information from them. So we download the title, description, publish date for audio file location, and also some additional metadata, which we are sometimes interested in, sometimes we are not interested in. And this data may include, for example, I don't know, copyrights or something else. It's not very important to us right now. And this is the first step when we download this data. And the second step is to download the actual MP3 file and work with it, work on it. And this JSON which we download contains a link to the MP3 file, so we just download it and work on it. The transcription process. The transcription process is when we take the MP3 file and produce the text from it, and we use Whisper1 API to do this, to take the audio and convert to English text. We use English as an intermediate language, and yeah, so mainly podcasts are recorded in English, and we decided to start with English so that it converts it to English. It produces this English text. Works well for most recordings under 25 megabytes, and it's I would say about 40 minutes of a podcast, sometimes even more. And yes, if you have longer episodes, then we will have multiple chunks of this text, but it's pretty easy to just merge them. So, but in the end, if you have a long text after all these manipulations, and you want to produce an audio file, you have to split it into chunks, and you split them, you then merge them, and it's just a matter of a few days of work actually, but it's not very important right now. Improving translation transcription using GPT-4o. So here you can see a little bit of the prompt, a simplified actually prompt that we use to translate the podcast to English. So we take the initial podcast, we take the text from it, then there are two possible options, three I would say. The first one is the ideal option when we have just English podcast and with just English speech. Second case is when we have English podcast with some other language somewhere in it. Let's say, I don't know, French phrases in this podcast, which we want to translate to a single language. And the third case is when we have the podcast in some other language, any language, French, for example. In any of these cases, first step is to translate everything to English and then work with English text. And only after that, we will translate it to the final language. So yeah, in this, I will just read it. So context, this is transcription of a podcast in some language. Fix the grammar and punctuation or translate it to English or source language. We have English for now. It's in the wrong language. The text where podcast starts and cut unrelated content at start. Yes, so there might be a very beginning part of the podcast which we're not interested in. It's mainly the part when authors of the podcast introduce themselves, talk about what they are going to talk about in this podcast. Most of the times it's not important and we just cut it and go straight to the main topic. And as an input, we give the transcription of the podcast. The next step, so we use Russian language as a target language. And here you can see also a part of the prompt which we use to translate the podcast to the final language. And it says translate text below to the Russian language. Keep the translation as close to original in tone and style as you can, so that this part says that we want to keep the jokes, keep the tone, keep everything we had in the original podcast in the final podcast. And we pass the text from the previous stage. Next up is converting text to speech. So how it happens, we have this Russian text and we pass it to TTS1 model. It generates us the MP3 file with the speech and we can use it after that. It's that easy. It's just one parameter to this model and it returns you the audio file. There are multiple challenges with it. First one is that we have limited voice options, and so for OpenAI there are a few voices that you can use, but not really many. The one we use has slight American accent, and it's actually there are better voices for Russian, but we use it because then listeners can hear that this is not the native language for the author. This is a translated podcast, and if your speech has slight American accent but it is in Russian, then you will understand that it's not what the author was saying by themselves, but rather it was something translated. Or it can also be the case that the author says this by themselves, but with the American accent because he's not native in Russian. And as an example here, we have a little sentence from a podcast. A Lovely Nature podcast host gets an upbeat TTS1 voice saying "Здравствуйте" with a slight American twang. So I wouldn't replicate it because there are not many Russian listeners here, I believe, but it will sound like you don't speak English, but you speak some other language, and it will sound like you have your mother tongue is English, but in another language you sound a bit non-native, right? Now let's move on a bit. Overcoming technical hurdles, file size limits in Whisper, So if we have a very long podcast, a very long text to translate it to speech, then we will need to split it by chunks, chunk by chunk. And the more difficult part here is not just splitting them, but is to understand where we want to split them, because you don't want to split them in the middle or somewhere like that, because then you will probably cut in the middle of a word, or even if not, then in the middle of a sentence. You don't want that. You want to keep sentences clear. You want to keep them in the single part. So the idea that we can use, that we want to use, is to split this text into not just sentences but like paragraphs, where we talk about one thing, then another thing, and so on, and then we can translate these parts one by one, and they will not hit the size limits for Whisper model. The next problem, hurdle, is style preservation and translation, and by that it means that even if we say to ChatGPT, to their model, that we want to preserve the style, we want to preserve the tone, it's not always possible, because different languages work differently, and you just cannot have the same kind of style into different languages. At least like 100% you can have it. You can have parts of it, you can translate jokes, you can translate some context, but not everything. And the third problem is audio merging complexities. I was already talking about that. Now let's move. Audio merging challenges. So why the exact reason why we cannot take multiple MP3 files and join them together is because we will lose some metadata. And this is a problem because if you want to play the podcast not from the beginning, but from the middle, then some players can just break, because they will think that this audio file, well, they will read the metadata description in the beginning from the file, and it will say, for example, that it lasts for 15 minutes. But actually, you have 3 chunks merged together, each lasts for 15 minutes, so the whole podcast lasts for 45 minutes. And when we try to scroll to, let's say, in middle, the player might think that, well, the middle of 15 minutes is like 7:30, and it will move to 7:30 instead of like 45 divided by 2, whatever it is, like 22.5, 22.7 minutes, doesn't matter. So it can create playback issues, but if we use FFmpeg for that, for merging the files, it will update this metadata and everything will work smoothly. And yes, in the middle you can see that current method works but breaks seeking, and the current method for us is to just join these MP3 files together, just byte by byte. It's not perfect, but it works. Optimizing GPT-4o for translation. So how we use it? We use it first to correct the grammar, and again, this is used to take the sentences and drop unfinished sentences, merge sentences if the author was talking about something, made a pause, then was talking about something again. So this might be 2 different sentences, but recognized as 2 different sentences, but actually this was just one sentence. GPT-4o will work with that, and we will merge it into a single sentence. Time preservation techniques. We are trying to tell GPT-4o to preserve the tone. We're trying to do that. It's not perfect, but it works. We are thinking about better ways to do that, but so far it works. And handling mixed language content. Right now it works like that we take the whole podcast, translate it into English, and then work on it. Ideally, it would not require us to translate it to a single language, but we could probably work on the original podcast text and only after that translate parts of it into the final language. But it's a whole different story, and I would say most of the podcasts, more than 90% of all the podcasts, probably even much more, are in a single language. You don't need to work with multiple languages in single podcast, so it's not a problem for us right now. And as an example of translation, we can see that an input is actually what the transcription model will give us from the sentence AI is cool and in Russian kruto. It says that, well, this part was in English, this word is in Russian, so I will translate this part into English, this part into Russian, and I'm good. So we will first do the transcription. We will translate everything to English, and it will stay the same. So AI is cool and in Russian kruto. It's absolutely the same, just transcripted, forgot this word, transliterated. And as a translation, then we have и крутой, и по-русски тоже круто. This is a sentence totally in English, totally in Russian, and this sentence will go into the final episode, into the final result that we will have. There is also an interesting thing, which is BU scores, and basically this is a metric which can tell you whether your translation is good or not. It's an interesting stuff, and how it works is basically you have your English text, you have your, in our case, Russian text, and you run through this algorithm, and it will tell you some number. And let's say this number is from 0 to 10, where 0 is this perfect translation, 10 is the perfect translation, 0 is a very bad translation, and we can set the limit of quality for us, the lower limit. So let's say if this score is 8 or above, then we are good. If it's lower than 8, then we need to review this translation, understand what went wrong, probably change the prompts, change the way we think about this podcast. Maybe it has some multiple languages, maybe it has some phrases which are not translatable to another language, maybe it has something else, maybe it's just some of the models didn't work well and we need to rerun it. There may be multiple reasons for that, and this scores is a simple thing, but it really helps to maintain the quality of the podcasts. And here I will show you a bit of the code snippets. The first one is downloading podcast episodes by the podcast ID. So we have the podcast ID, we have this client for podcastindex.org, and using this code we can download all the podcasts information, all the podcasts with the MP3 files actually, and yeah, we will have that after calling this method. And as you can see, it returns a list of pairs of episode, where episode is information, meta information about the episode, and path is a path to the MP3 file which we saved on disk. Next one is transcribe audio, and you can see it's very easy, very simple. And to transcribe audio, you just we use the OpenAI SDK, and it allows you to say, well, I want to use Whisper One model. This is my audio file. Please give me the text from this audio. And this is the way to do this. The next one is improved transcription function. So it says I will read it here. Context: this is transcription of podcast in English, fixed grammar and punctuation, or translated to English if it's in the wrong language. Detect where podcast starts and cut unrelated content at start. Output format: formatted text in source language. Output with no introduction. Output only text. And the input. So this does exactly what it says. Next one is generating speech with TTS1. This step runs after we have actual text and we want to generate speech from this text. And what it does right now, we split the whole text into chunks, and right now it's just splitting by sentences. And we are taking, this model takes not more than about 4,000 characters at a time. So we first split all these text by sentences. Then we take chunks consisting of as many sentences as we can fit into it, but not more than 4,000 characters. And then we have multiple chunks probably of it. And send these chunks to the model, then save them to disk, and then merge them together. This is how it works. And to publish the translated podcast, there are two steps. First, we need to generate the XML file, the RSS feed of the podcast episodes. We generate it, and then we also have some metadata for the podcast, for the initial podcast, like the name of the description and so on. And we can translate it into, for example, Russian, if if the final episode will be in Russian, and then it will translate and it will work flawlessly with the podcast platforms. This is a little piece of code which is used for generating RSS feed, and it's a little piece of code and not full code because the RSS feed has a lot of fields and they are repetitive and boring. So I just showed you how to create the RSS feed using standard Java's utilities. We didn't use any kind of libraries for that. It's just Java. Yeah, and here you can see that it's just a new XML file with the RSS tag in it, and we just add stuff to it. That's it. And yeah, so future improvements that we want to do. First is automated episode splitting. It's not great right now, and we want to think about how to split the episodes for generating speech better, not just by sentences. But so far it works okay, but we're not sure if there are better techniques, but I think there are. Second problem is with FFmpeg-based merging. So right now we don't work on really large episodes, but if we will work on them, we will need to add FFmpeg to this. And well, right now it works somehow. It may not work in some players. In mainstream players it actually works, but it may not work in every player. And the next one is custom voice training for TTS. This is an interesting thing, and by that I mean that you have an author of the podcast in English, for example, and you want them to translate their podcast into another language. They use this tool to translate their podcast to another language, but it would be really nice if we can preserve their voice and keep it so that even in Russian, for example, it's like they speak Russian in this podcast. I think it would be nice. It sounds like sci-fi actually, I don't know, but I think it would be nice to have. And some key takeaways or the conclusion of this project First one is idea to realization process is challenging but possible. And it is challenging because when you first think about it, it may not sound that it's possible at all. But when you split this idea into chunks, like, okay, let's take the original podcast, what we can do with it, we can take the text from it, okay, we can translate it in another language, okay, we can improve the transcription, okay, we can then maybe use some models to generate speech from it. So it's actually possible and not that difficult, but at the beginning it felt really challenging and we were not sure if it would be even possible. The second thing is that AI evolves with an incredible pace, and you could see here that we're not using the biggest and fastest model right now available, just because the model which we use in this project, it just works and it is enough for us. But of course we can use better models, and they are right now even better at transcriptions, at generating speech, at everything. And I'm pretty sure that translated podcasts will be a thing in the future, in the very near future, because it doesn't even take that much effort to make. But with the current technologies, with the current AI, it's interesting to see where we will be in a few years. And the last thing is that lots of future improvements is possible, and yeah, we could see that it still doesn't sound like it doesn't sound native to people with the final podcast. We still may lose some context, we still may lose some jokes, we have some technical problems right now, and we still have a lot of stuff to do here. And as a conclusion, I would like you to listen to two episodes, to one episode, a part of the episode. One episode is in English and it's an original one. The other one is in Russian. Again, I'm pretty sure that you are probably not Russian, and there are not many Russians right now here. But you can just hear that we have the source and the result, and it's actually incredible. Let's listen to it. Just a second.
This is episode 2 of What's in a Name. In the previous episode, we learned how scientists name species and the controversies that can result from those names. But names don't just matter to scientists, they can impact all of us. In this episode, we're moving out of the universities and scientific publications where names are chosen and into the public realm where names chosen by scientists meet non-scientists.
This is it in English. This is the original part of the original podcast. And now let's listen to the same, but in Russian, when we applied all the described steps to the original part of the podcast.
Это второй эпизод «Что в имени?». В предыдущем эпизоде мы узнали, как ученые называют виды и какие могут возникать споры из-за этих названий. Но имена важны не только для ученых, они могут оказывать влияние на всех нас. В этом эпизоде мы уходим из университетов и научных публикаций, где имена выбираются, и переходим в общественную сферу, где имена, выбранные учеными, встречаются с непрофессиональными людьми.
This is it. This is what we have right now. I hope you enjoyed the session. Thank you very much for listening. If you have any questions, please come and ask. Thank you.
Hey, look at that ad. Walk, earn, repeat. What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.
Welcome to Sharp Economy, the social fi platform empowering creators, communities, brands, and businesses. With tools like Contribute to Earn and Spend to Grow, we reward participation and put your skills on chain. A decentralized ecosystem built on Web3 principles, where transparency and ownership truly matter. Sharp Economy stands on 4 powerful pillars: the Sharp platform, bringing Web 2 to Web 3, the Sharp token, fueling growth and rewards, the Sharp Rewards app, where you learn, earn, and grow, and the Sharp Innovation Foundation, shaping the future. Step into Sharp Economy. Own your growth, own your future.
All right, everyone, back to the Software Architecture Conference. We now move to our second final session of the day, not just of the day, but also of the entire conference. And joining us now is not a new face. He is Sunny, and I remember his nickname, if I'm not wrong, right? Because for me, it's a tough name. It's not an easy name. So joining us now is Sunny, right? He is a principal software engineer. I think he got promoted, right? How easy it is to build distributed polyglot microservices using .NET. So hi, Sunny, welcome to the conference.
Hey, hi. Happy to be here again. How are you
Yeah,
doing?
it's so good to see you, right?
Yeah,
How are you doing?
Yeah, wonderful. Life has been good. So yeah, dealing with an infant and toddler at home. But yeah,
Oh,
apart from that,
wow.
everything is good. Yeah.
Were you married, when we last had a
Oh,
chat?
yeah. So last time when we were, I think, we had a session on my birthday, if you remember, August 15th,
Oh,
right? So
yes.
yeah. So at the time, we were expecting, and this February, we had a baby
Yeah,
boy.
congratulations,
So
my
yeah,
man. I'm so happy
thank you.
for you.
Yeah,
Right.
thank
So,
you.
okay. So
Yeah.
it means, you must be, always, you must be needing a lot of energy and everything else. I won't take much of your time, right? I
Yeah.
love this topic, .NET Inspired, especially since we're in the CSharpCorner ecosystem, right?
Mhm.
I'll let you go, and next 35 minutes is all yours.
Okay, awesome. Yeah. Hi everyone. So welcome to the session. So I'm gonna talk about the .NET Aspire and how you can build polyglot systems, polyglot microservices using .NET Aspire. So let's start with who am I? So so I've been a Docker captain recently. I blog at DZone. There's this site where I actively blog, and I also do active mentoring on AWS and author of 2 books. So one just got released yesterday. This is on .NET Aspire, so I'll talk about it a little later. But the other one is on Azure Container Apps. So please definitely check this out. Yeah, so let's start with this today's agenda. So I'm gonna quickly talk about the distributed application problems that every developer will face when you are trying to build microservices, right? On your setting up environment on your local dev box is always challenging, and how .NET Aspire will simplify it, and how easily you can build microservices from different languages, and then you can combine that into one platform. So let's talk all about .NET Aspire, and I'll also show you the cool demo towards the end. So yeah, so looking at the cloud native applications, right? So everybody knows, about the cloud native application. So we have to follow all these different characteristics. We want to reduce the cost, provide reliable services, easy to manage, and faster releases. And when you are trying to build this, right? So initially you'll start as small, and then over the period of time, your application will develop into something very complex. And as a developer, if you're onboarding anyone into your team, right? So setting up this infrastructure on their local development environment is always crazy. So they end up spending a lot of time setting up the infrastructure. And yeah, to be honest with you, like, there will be a lot of questions asked, what are the URLs for the backend services, how you can, which port to call into, and, and a few other things. Like, let's look at the next slide where it will mention about all the details, like how do I set up the monitoring for it, how my front end talks to the backend, what URL to use, whether it's HTTP or HTTPS, how can I configure Redis, and how can I, add retries, exponential backup policies, how many retries to use, what libraries to use. So all these things are kind of headache to any developer, and then setting this entire system locally is always a challenging thing. So what .NET Aspire will do, so let's get into that. But before that, every application that we currently develop, it has to have this few basic things, which are observability, resilience, scalability, and manageability. So with .NET 9, you provide all these things out of the box. But the problem with the problem that we currently see is you have to still pull in all the NuGet packages into your application, and over a period of time, your application will again, become more complex, and it's really hard for you to manage each and everything, right? So what happens is basically with .NET Aspire, as I mentioned, your application gets complicated over a period of time, and the choices or the paths that you take, you need to make sure that it is scalable application, right? It's not just you're creating for 100 or 1,000 users, but then your application cannot scale to tens of thousands of users, right? So that's why the .NET Aspire, the .NET team, they have come up with this new product, .NET Aspire, which was released in early 2023 during the Build conference. It's still evolving. It's still pretty new, but there's a lot of promise in using the .NET Aspire. So that's why I kind of got fascinated by this stack, and I ended up learning more about it, and then I wrote a book also on it. So what exactly is .NET Aspire, right? So .NET Aspire is an opinionated cloud-ready stack for building observable, production-ready distributed systems. So there are a lot of jargons here. So when you talk about the opinionated, right? So .NET Aspire team has, it has specific ways of doing things, which does by providing specific guidelines. So when I show you the demo, you can see how your project setup will be, what kind of new projects will be added into your solution. So they have specific ways of doing things. So that's what they mean as opinionated and cloud ready. So as I mentioned, these days everybody is building for cloud any application to be cloud ready by utilizing the cloud computing characteristics such as scalability, reliability, availability, performance, and security by default. So that's the advantage when you move to the cloud. And then observable, right? So your application are to be easy to monitor by providing insights into their internal state, behavior, performance. If there is any exception or anything going behind the scenes, you should be able to easily look into the metrics, logs, and traces, and then you will be able to identify how to fix this, right? So that's one thing about .NET Aspire. So so it contains like a bunch of different tools, frameworks, stack. It's not just a simple framework. It contains multiple things as part of .NET Aspire that we will take a look when we look into the demo. But as I mentioned, it is easy to build resilient, observable, and configurable cloud-native applications using .NET Aspire. By default, it gives you the ability to add, telemetry. You can easily do health checks before calling any APIs. You want to make sure that API is up and running, right? So all these things is provided out of the box for you, so that as a developer, you don't have to worry much about setting up the infrastructure or managing it. but you focus more on the business logic. Like, what is needed for your application, you will go ahead and you will basically work on that piece, and the rest, everything is taken care by .NET Aspire. So let's look at so let's look at this site. Like, most of you guys are familiar with web application development, right? So let's say you are trying to build this web application. It's a simple site where you can buy some sport related equipment. So when you start with it, right? So okay, let's go ahead and create a Blazor application and have this data source. Initially, you'll start with hard coded data or data coming from JSON, but over a period of time, like once you're out of the development phase, then you will integrate with real world database, like it could be SQL Server, Postgres, or anything, and then you will create a backend API which talks to the database to get that data to be displayed on the web application. So simple enough, right? But over a period of time, your application will become like this, very complicated. If you can see here, you will end up creating multiple microservices for dealing with identity service. You'll have one, and then there's one for catalog services, order services, basket, admin service. So this is how your application will grow eventually when you're dealing with any, building any cloud native distributed applications. But the problem here is when you're onboarding a new joinee into your team, right? So when they look at this architecture, okay, they'll understand, okay, what are these different components and how to integrate and how to talk to them. But when they want to fix a small bug, they have to set this entire environment locally, right, in order to solve the issue. Everybody wants to debug it, right? Then only you'll be able to understand the workflow, and it's easy for you to fix the issue. But setting this is actually, it will take a lot of time for any new join. Even for the senior resources also, there could be small things here and there. You can miss a small connection string, then you will end up not talking to a database. One of the service will be down. So setting this up will be really tough, and that's where .NET Aspire will come into picture. So when I show you the demo, you will understand, like, how easily you can build this microservices and set up your local environment with just pressing F5 on your Visual Studio. So so what exactly is, like, let's talk more about the .NET Aspire before getting into the demo part. So in .NET Aspire, it has like multiple features. There are different features like smart defaults. There's a cool developer dashboard, which is readily available for the developers. And then there is the orchestration, integration, service discovery, and deployment. So let's look at each and everything, like, very briefly, so that when we go into the demo, it will be really easy for you to understand. So when we talk about the smart defaults, right? So what exactly is smart default? So every application, like, as I mentioned, it needs to have the observability, resilience, and health checks. So these are all provided out of the box for you. Like, you don't have to spend writing a lot of code for dealing with this kind of scenarios. So if you look at this code here, all I did is, like, just plug in some of the methods into my code, where it will automatically provide me with open telemetry or tracing or even health checks, right? So I can also add resiliency by just calling one method. So behind the scenes, the magic happens, but as a developer, you are not spending a lot of time in recreating what every developer has to do, right? So every application needs to have this basic template, which is automatically provided to you. And for health checks also, you can just plug and play another method, which is add health checks, and this will help you. You can also create an automation. End of the day, you can just create one API endpoint, which you can hit from your automation to check the live, whether your API is live or not. So you can do the health checks by making use of the .NET Aspire by just adding this one method. So yeah, so that's about the smart defaults. And let's talk about the developer dashboard. Like, everybody, whoever has touched .NET Aspire so far or used, they love the dashboard that they have created. So behind the scenes, they used Blazor for creating this. But the way they have created this dashboard, it's easy to identify and manage your resources in one place. So in this screen, you can see what all services are running and what are their endpoints. And if you want to look more into their logs, you can also do that. right? So this is very easy when you are building a distributed application with hundreds of services in it. There's one single dashboard that is automatically given to you, where you can go and look at each and every service along with their logs, traces. Everything is automatically embedded into this dashboard. So that's the beauty of this dashboard. Yeah, so I'll show you the demo, and you can see what kind of projects are created, how the solution will look like. When I say opinionated, right? So what exactly is that about? How many projects are automatically integrated when you go ahead and create an .NET Aspire template, starter template. Yeah, we'll see all that in the demo. And let's talk about quickly about the orchestration also, right? So when we discuss about the orchestration, so imagine I've done this over my career of 15 plus years. When you have multiple projects, you have to go into Visual Studio and add set all these projects start at the same time, so that when you click F5, all the different dependency projects like your APIs, they will all spin up at the same time, right? So you don't have to do that. Earlier you have to do that, but with .NET Aspire you don't have to do that. So what we do is, in our project, in our app host, we will create this is like builder pattern, right? Basically you create your builder and you try to inject each and every project into this builder. And the beauty of it is, I can tell my front end to start only when API service is up and running, right? So I can add the dependency on one service, and before starting the API service, I can also add another dependency saying that only when my SQL server is up and running, then only start the API service. And once the API services started, then only start the front end. So you can create those kind of dependencies automatically. Otherwise, when you're dealing with containers, sometimes the container will not load up or will not spin up immediately, and then you will have these issues, right? So that issues can also be solved with the use of .NET Aspire. I'll show you that in demo. Yeah, so that's how you can add the dependencies, and the Visual Studio tooling is also there. Once you add this the app host, or you create the application from scratch, when you want to create a new application, you can just make use of the .NET Aspire template, which is automatically available for you. Yeah, so that's about the orchestration. So let's talk about the service discovery, right? So everybody will face through this problem. Okay, I spin up a API service, or let's say your team, another team is sitting in different location and they are working on another service, and you need to talk to them and get this details about where exactly they deployed it, what's the production URL, what port they are using, and then you can integrate that in your system, right? So this issues we have dealt in the past. Like if anything goes wrong, then you will automatically go and check at the URLs whether you're pointing to the right APIs or not. So with .NET Aspire, you simply provide information about, once you add and integrate everything into the Aspire, it will automatically do the service discovery for you, right? You add the service like this, and then you use this API service. If you can see the code here. So here I'm saying add my project, which is API service, and then I took that variable, and I'm passing that as a reference to my front end. So now .NET Aspire is smart enough to understand, okay, for this particular service, when you are invoking from the front end, it automatically knows where exactly to talk to, and then it can go ahead and hit the endpoint. So this is done behind the scenes. So you can look into the connection strings, so all this information is abstracted away to you. You can still go to the dashboard and you can take a look at how the connection strings are configured. I'm not saying that everything is completely automated and there's a magic behind the scenes. You will still have connection strings, but the good part is you don't have to deal with it. .NET Aspire does it for you. Here, if you can see, we still have the connection string. If you're talking to databases, or if you are talking to another services, you will still have that information, but this is abstracted away. Okay. Yeah, and another cool part is integrations, right? So there's a wonderful community out there. They have built this .NET Asper community toolkit, so they are integrating other services into .NET Asper. So let's say today you want to go ahead and use Redis or RabbitMQ. They already the community toolkit, they have integrated that. So all you need to do is just add one single line, add Redis into your project, and you'll be able to get the container up and running in your Docker, and then you can directly invoke that in your code. So this is as simple as easy, rather than you dealing with all the NuGet libraries, pulling in the client libraries, and then writing all sorts of code. So that is completely avoided when you use the .NET Asper. So here you can see how easy for me to spin up a new container with a Postgres on it, and then behind the scenes it will automatically pull that image and run it in the Docker. And from my code, I'm just calling one line to talk to the Postgres, and then I can attach that as a dependency when I'm trying to invoke my API service, or when for spinning up the web front, I'm again giving the dependencies as API service needs to be there before spinning up the front end. So this is extremely easy for any developer when they are working on a distributed application. Yeah, so this is how easy to integrate cache in your application, or add service defaults, health checks, logging, telemetry. Everything is added automatically. So this kind of also making developers a little lazy. But if you look at the speed at which you can develop and release your application, this will be exponentially helpful for startups, or even for bigger enterprises to develop any applications on .NET Asper. So yeah, and the development also, so they're not forcing you to only use Azure, even though it's the product is from Microsoft. They want to make it as open source as possible. So you can, if you're in your application, if you're using AWS, right? So you can still deploy your application to AWS. Even AWS team also creating a lot of SDKs to support the .NET Asper. So wherever you want to deploy today, you can do the same thing with the .NET Asper. So nothing is changing, but the way at which the developer is getting all the benefits with the developer dashboard, the open telemetry, metrics, logging, all these things will be really helpful as a developer to spin up your application, debug your application, and release your application. Yeah, so let's look at a couple of demos. So let me share my screen, and I'll open up my Visual Studio. Yeah, I hope you can see my screen now. Yeah, can you see Visual Studio? Yeah. Hey, Simon, if you're still there, can you help to shift the screen? Currently, I think people are still seeing the PowerPoint.
Santosh, all right. Are you done with your session?
No, I still need to show the code. So can you help me, switch the screen from PowerPoint to my...
Perfect.
Yeah.
Okay, you want me to show your screen? Okay, I'm gonna this one and add it to the screen.
Yes. Thank
Perfect.
you. Thank you. So I hope you can see my Visual Studio now. Just
yes,
confirm.
we can.
Okay, perfect. So Yeah, so this is an application that I've created for writing for my book. So I got permission from my publisher to also share this in our session today. So I'll just go ahead and run this, and I'll show you how this looks like when this application spins up. So it's going through a bunch of settings, and then it spins up this dashboard. So this is the dashboard I was talking about, right? So this application is built on .NET Aspire. So here you can see all the different resources. So what I'm doing is like I'm spinning all these different containers. So I have this create order was created using Go language. Front end was created using React. Process payment I created using Python, and then ship API was created using Node.js, and warehouse API was created using .NET. So different applications using different languages, but I'm able to still pull up everything into one dashboard. So here I'm able to easily manage each and every service. So how did I do that, right? So if you go into the code, so when you create the .NET Aspire template, then this two projects will be automatically added. One is the app host, and then is another one is the service defaults. So if you go into the app host, right? So in the program.cs, I've created, this is following the builder pattern. So once you create your builder, I'm attaching SQL, like for one of the application, one of the backend API, I need to talk to SQL database. So all I'm doing is like, creating a SQL server and then adding a database to it. And I can also use scripts, like, in order to create your database and dump in some data. So I've created some scripts and able to run that. And the beauty of this is it will wait, like, other services are dependent on the SQL server. So before starting my warehouse API, which is written in .NET, I am saying that, wait for this SQL server. And I'm also using another cool open source product called DAB. It's Data Application Builder. This is again created from Microsoft. So what they do is you don't have to write those complex code for doing CRUD operations talking to your database. So you just onboard to the DAB, and it will create automatically the REST APIs or GraphQL APIs endpoints. So for everything, like, you can mention this inside the configuration. I'll quickly show you that configuration also, how it will look like, so that it will be easy for you guys to follow. Yeah, so this is my DAB file. So here all I'm saying is, okay, this is my connection string to talk to the database, and I want APIs and also GraphQL endpoints. I can also enable CORS. If you're invoking from front end, make sure that CORS is enabled, otherwise you cannot talk to those APIs. And then I can create some permissions for create, read, update, delete. And you can specify what all tables you want to include in this endpoint. So automatically it is creating an endpoint for doing create order or read order or update order, delete order. So you don't have to write a single line of code. So that is what DAB is doing for me. So I spin up the database, and then I'm adding the data API builder. And once this is done, then only create my API. Okay, so I am adding this with reference DAB, and also I'm saying wait for DAB. So without DAB, my API will be nothing, right? So this is the beauty of .NET Aspire. So you can add each and every project into it, and also you can say wait for it before the container spins up, before it is in the running state, then only spin up my API API project, or before that, before the front end, create the API, and then once it is ready, then only spin up another API. So that's how you can add each and everything. And I mentioned about the .NET Aspire Community Toolkit, right? So it's as simple as adding one line where you are bringing an API which was written in Go language. You are integrating that into the .NET Aspire. So the Go is not here. If you can see, this project is completely .NET related, right? So I have only the warehouse API, which I created using the .NET minimal web API. But apart from that, I'm still able to pull in Go API, which is create order. And then there is the Python one, there is the Node.js one, and then there is the React one. So So before I spin up my React, I'm giving all the information here that, hey, wait for this API to be there. Wait for the create order API to be present. Wait for the process payment API. So once all the backend is done, then only go ahead and spin up front end. So that's what I've done in this file in the app host. And this is how easy for any developer. So if a new joinee is joining in your team, all he has to do is he doesn't have to do anything else. All he needs is a Docker desktop on his machine, Visual Studio, set this project up, set the app host as the main project, and then just hit F5. Once he hit F5, it will come to this page where you can see the list of all resources running. So if I restart it again, I think you can quickly see how this will go, so that it will give you a good understanding. So I'm starting the project again. So once the console spins up, right? So immediately the dashboard will load up. And if you see, it is going from waiting into running. So I don't know, it will be very fast if you can see that in the live. But if you can see, SQL started first, and then DAP started, and after that, Warehouse API started, and then create order, front end, create order, process payment, ship API. These are all separate individual projects written in Go, Node.js, and Python. They will also spin up. And once everything is done, then only the front end app will go ahead and start. So that is the beauty of having a polyglot microservices. You're able to integrate well into .NET ASP.NET. And if I click on my front end application, right? So it will go ahead and now internally it will make a call to my web API, which is using the DAB to talk to SQL Server and pulling in all the data and displaying it here. So if I want to see what's happening behind the scenes, right? So I can go into the tracing and I can get each and every detail, how the request is made, what endpoint is it calling into. See if you can see, yeah, this will have the trace ID. It will give you the URL, which endpoint it is going and hitting, and what kind of data it is able to return it back. So the logging and metrics has been automatically added to you, added into the .NET ASP.NET. You don't have to do anything. It is automatically included in the template, and all you need to do is whenever you are dealing with a microservice development, you are able to understand if there are any issues going behind the scenes. You are able to get the trace ID and look more into it, and then you can understand what if there is only one service is having an issue, you are able to identify it very quickly. Because earlier, if you are developing a microservice distributed application, one is written in Python, one is written in Node.js, you have to deal with multiple environments and get the logs, and then you have to understand what's happening. And if you're not passing the right information, right traces, without the trace ID, you'll not be able to figure out. But with .NET Aspire, everything is made very easy for you. You can just pull in what's happening in one service, and you can able to identify how the request went from one service to another service. And the beauty of the new release, recently there was a 9.4 version released, and before that they released 9.3 also. So they also integrated GitHub Copilot chat into it. So the beauty here is, like, if I want to analyze something about the span, right? So I'll just quickly click on this, and Copilot is automatically integrated into it. So it will give you information about what happened, what kind of details that you need for debugging, right? So everything is automatically given to you. So it's making it even more lazy as a developer, but the rate at which you are able to identify an issue with the help of all these tools will be really, really beneficial when you're creating a new application. And you can also bring in old application into .NET Aspire. So it's as simple as just adding a couple of methods and integrating this project. And the .NET team has done a really good job, where in Visual Studio they are already providing automatic templates. Even in the Visual Studio, if you just right click on your project, you can bring in and add it to the .NET Aspire. So it will automatically spin up this new 2 projects that I mentioned, app host and service defaults, into your project, and then you can just every time whenever there's a new release, all you need to do is bump up your version. That's it. You will get all these features automatically. And one thing before I want to end, I want to show you is there is this new cool roadmap that they have published it. So in the .NET 9.4, I still have, over the weekend, maybe I'll spend more time integrating into this particular new release. But the beauty, which I really love it, is they integrated GitHub models into the .NET Aspire. So in future, if you want to just, yesterday ChatGPT 5 got released, right? So if I want to integrate it, all I need to do is just add one single method. It says add GitHub model. You provide your API keys, and then you can plug and play. You can just change it to GPT-4 or Mini to GPT-5. So imagine you're building a really good, distributed application, and integrating that with your LLMs is very, very easy now. So you don't have to deal with any infrastructure. So that's the new feature that they have released in 9.4. I still have to upgrade my application and go into all these features. There's a bunch of features, and there's a new roadmap also given by the .NET Aspire team. As I mentioned, this is still very in the early stages of the release, but already a lot of companies have onboarded into it. Even in Microsoft, a lot of teams have completely onboarded into .NET Aspire. So the future is really bright and it's solid. So I will always encourage you guys to, whoever is watching this session, please go ahead and look at the .NET Aspire roadmap so that you can follow. You can also, if you have time, definitely do join the community toolkit GitHub repo, fork it, and play with it. If you see there is any new language that you want to integrate, please go ahead and add it. And before I conclude, so this is a new book that just got released yesterday. So please give it a try. Whatever the application that I have shown you in this demo is completely included in this book. I'll talk about each and every service, how you can write it as a developer. So this book is not just only for senior developers, it's for junior to senior. Everybody can easily follow, and they can understand about this .NET Aspire and how to use it in their production environments. So with that, I'll conclude my session. And thank you. I'm looking forward for questions. And I can be reached out on LinkedIn. So if you have any questions related to .NET Aspire, just shoot me up. Yeah, back to you, Simon.
Absolutely lovely, Sunny. I have put in your very first second slide where people can find all the details, right?
Perfect. Yeah. Yep.
And congratulations on the new book. Actually, I didn't know about that.
Yeah, like lot happened in last 1 year. So this took me almost like 8 months.
I remember.
To
I was looking at the previous year video. Man, you looked so young then. I was you had a very different look. You have
I
changed
think
so much.
It's mostly sleep deprived right now, dealing with kids. But yeah, hopefully it will get better.
Exactly. So let's take a couple of questions. I think we have one from Sophia. Sophia is asking, how does Aspire's local debugging experience for a polyglot system compare to the traditional method of using Docker Compose and separate debugging tools?
Yeah, I think this question may be asked before I started showing the demo. So earlier, this is how you have to do the debugging, like set up everything on your own. Now you don't have to do that. You just spin up the .NET Aspire developer dashboard. Everything is automatically there for you. So behind the scenes, Docker, you can also see the Docker spinning up the containers. You can see all the images. But the beauty of it is you don't have to manually look into the traditional methods of doing the debugging. Everything is automatically integrated into the .NET Aspire. Looking into the logs is just a single button click. And with GitHub Copilot integration, you don't have to look at the logs also. Just ask Copilot directly on the dashboard.
Yeah, Copilot is everywhere.
Everywhere.
Every
So
every app I use of Microservices. We are CSharpCorner and everything. Even the clients we work, it's all Microsoft. It's literally everywhere. There's a right chat
Right
box
chat,
where
yes.
it just sits in every ecosystem.
That's yeah, exactly. Yeah, exactly. It's
So let's
making
say,
a developer's life little easy also, right? So
yeah,
yeah.
I mean, exactly. I was using Dynamics CRM the other day, and even there you have it's same thing, right? So let's take
Yeah.
this question from Rohit. He's asking, how
Yeah.
does Aspire's approach to service wiring differ from traditional service discovery mechanism, and
Yeah.
what are the
So
key benefits?
yeah, in the traditional service discovery, you have to pass in those URLs. Like, you have to
Mhm.
tell, let's say your other team which sits in India, they have created this cool web service and they hosted it somewhere. They have to give you which URL you need to talk to, which port you need to talk to, right? So
Hmm.
that's the problem when you are doing a local debugging or local development in your environment. You need to talk to the staging environment and get all those URLs and plug into your solution. Then only you can spin up and then you can debug. Even for spinning up, you need to set multiple projects in Visual Studio as startup, and then only you can do that, right? Otherwise, debugging is really hard when working with distributed applications. With .NET Aspire, if you could see the demo that I showed, right? So I didn't mention anything about my backend API. All I said was use this as a reference in frontend. It knows which URL to talk to. It knows about the connection strings. It knows about all the parameters that needs to plug into the front end, and it automatically makes the call. So that is the beauty of the service discovery, which is built in .NET Aspire.
Wow, very lovely answer. There's a comment from Scott. He's saying this app looks like MS Teams. Have you used their library or something?
Yeah, I mean, so this looks like a Blazor application. Like, if you guys worked
Mm.
on Blazor, so behind the scenes they started using the Blazor, but yeah, they changed all the colors. They always use this little greenish pinkish kind of thing for .NET
Yeah.
Aspire. So even the publishers that I wrote with, the BPP, they also use the same theme. So it was coincidence that my book was also printed in those colors. But yeah, it's just a decision made by the .NET Aspire team. So yeah. So
No, there's a question in the YouTube chat. For some reason, yeah, it is not showing
not
inside
showing
here.
up here.
It is also by Scott, so I copied and pasted here. I'm
Yeah.
gonna show it on the screen like this. This is a question from Scott. Actually, he's asking, what is the learning curve like for a developer who's new to Aspire but experienced in one of the non.NET languages you showcased?
Yeah, I would say 0. Okay. So if
Oh
you are
wow.
if you are an experienced developer writing services in Go, Python, Node.js,
Hmm.
right? All you need to do is you'll still continue to build your services just like that. But when you build a new, when you integrate .NET Aspire into it, all you need to do is just add one line into the app host. It will automatically know, but you need to provide the information. Like, if you're
Mhm.
saying, hey, go and pull this bits, you have to provide the folder where your Go
Yeah, makes
application
sense.
list or your Python application list. But apart from that, there's nothing, no learning curve you needed. You can still write your services in the languages that you love and you use, but you're simplifying with the use of .NET Aspire. Now there's only one dashboard. You don't have to look at multiple machines, multiple environments, looking through the logs, traces, and breaking your head what's going on with one service, right? With .NET Aspire, you just come to the dashboard, look at the logs, and you can understand, okay, one of my services down there. How can I fix that? Okay, you have all the debugging endpoints, and you can see the logs, and based on that, you can fix it. So that is the beauty of .NET Aspire. So again, I'll reiterate. So there's absolutely no learning curve here needed. All you need to know is basic stuff of how to use Visual Studio and how to integrate. Even the .NET Aspire template, they used it. They are giving this templates in Rider and other IDEs also, not just Visual Studio. So they want to make sure that they're not forcing you to do something which you don't want to do. If you're using other IDEs, definitely you can go ahead and use that.
Lovely, Sunny. Thank you so much for sharing, all this knowledge around .NET Aspire. I know, we're gonna trim this video and put it individually, and and everybody in the C Sharp Corner community, they're going to love it. I know
Yeah.
it's Friday. You have a young baby, so I won't take much time. Any
Yeah.
final thing you want to add before we move to the next session?
Yeah, so it was lovely meeting you, and again be part of the software architecture live. So
Yeah.
last year this was the first conference I started when I
Wow.
again restarted my journey, and over the
Yeah.
period I completed like 20 plus sessions, 20 plus speaking sessions, multiple
Wow.
conferences. So yeah, so I always have a very soft corner towards software architecture conference. So definitely
Well,
when I'm in India, I'll definitely catch up with you. So yeah,
definitely, you just let us know. I keep on traveling all around the world, all around India. Right, we would love to
Hyderabad.
host you in my. Yeah, Hyderabad. I keep coming. I'm actually going
Yeah.
Hyderabad next month.
Oh, okay. Awesome. Awesome. Yeah.
All right. All
We'll
right. Thank you
definitely
so
meet in
much.
person. Yeah. Thank you.
Perfect,
Thanks,
Sunny.
everyone.
Please take care of
Yeah.
yourself, and yeah, have a nice weekend. See ya. Bye bye.
Yeah. Bye-bye.
All right, ladies and gentlemen, now it is time we move to the final session of the conference, right? 4 days, right? 4 days, and we have been waiting for this speaker, and I think you all know him. We recently hosted him in one of the episodes that I do with AI Dev Tools, right? He's Uday. He's a lead software engineer, cloud computing. He's an architecture AI enthusiast, and today he's going to talk about a very interesting topic, that is microservices and containerization. Uday, welcome to the Software Architecture Conference. It is so good to see you. And you are muted. I cannot read your lips.
My bad. I was listening to Sunny's session, so it was interesting.
Do you know
So,
Sunny by any chance? Do you know him?
no, this is the first time
No?
I'm seeing him.
Oh, there
So,
were quite Indian Americans at this conference. All of a sudden,
no.
and even for this AI dev tools, and I was asking to one of the speakers, like, why is it, all of a sudden, there's so many Indian Americans applying for this conference, and it's like the lawyers
Yeah.
are saying Trump is getting mad.
No. I'd say one thing why I'm doing conferences. I do my own other things too. Why I'm doing conferences and these things. I got a lot of time now after having my best friend. In last session we talked about, right? After my
I
best
remember.
friend, so I had time. So I thought like, okay, whatever I know, I thought of sharing,
That's
giving back to
lovely.
the community to see like, okay, how things are going.
Yeah, thank you so
So
much for
also
that.
like
Thank
it's a
you.
refresher, right? When we go to conference, I talk to people, like we'll get to know more things than
Yeah.
sit in silos and see like, hey, it will be like always like a professional thing. It will be like always you and your team and what is happening within
Yeah.
the organization. So when we go to these conferences, we'll get to hear like any new things happening, which will be useful for me for learning, or which will be useful for the company, like those sort of thing. Because time, time is a thing now. So we have a lot of
Exactly.
time.
If we have your friend Copilot from the last session, Uday, please feel free to go ahead and share your screen, and then we can get started.
Let me share my screen. Share screen. Unable to see the screen.
It's loading. Yeah, I see your slides. I have added it to the stream. Everybody else can see it, and next 30 minutes is all yours.
Okay, let me. Thank you, Simon. Let me go into a slide mode. So, as Simon was mentioning, like, hi, my name is Uday. I'm a lead software engineer, basically responsible for creating cloud native applications or migrating them. And I have a new friend these days, which I call it as AI. So he's helping me a lot in doing a lot of my job, and which is making me easier in my professional day-to-day life. So apart from engineering, I'm a blogger. I do like write articles and research papers where I targeted first nationally. Now I'm going to international conferences to get them approved and present these cases. So that's about me. And mostly I'll be active in LinkedIn. You can see that in there. And I have like a couple of projects free to go in my GitHub if you really want to check on the latest trends on AI, microservices, how to create agents, and how to use agent modes and everything. So with that, let's start. What are microservices? Why we need, and why we need to make our enterprise system modernized. So let's go to a situation like you may have seen this in a lot of movies where epic hero will come and defuse a bomb and it will never explode. So consider a situation you are in the same situation where you're trying to deploy a huge application where like 4 or 5 teams, different teams are looking after your shoulder saying like, hey, what is happening? What is Uday is doing? What is some person is doing? And you may need help from 3 or 4 different teams to make sure your deployment is success and you make sure like the application is up and running. So if you really in that situation, that means you are definitely in trouble and you are definitely using a big monolith application where you may or may not know end to end of the application functionality, or you may or may not know what are your integration points with the other application, other teams you have. So if you are in that situation, you're sure like you'll have a lot of issues when you're going forward to a production with any of the change. With that, let's get into agenda. As I said, you are in this situation, and this session next 15-20 minutes, I think we'll talk about like what are main issues we see in monoliths and what are the advantages in microservices, why we need to go for it. And as I said, my good friend, so I'll introduce him in the last couple of minutes, and I think he'll try to explain and convince you like why microservices better in his way of looking. So end of the day, I think I'll make sure you'll have enough buzzwords to talk about when you go back to your team on Monday, saying like, hey, I know this, I know that, or why don't we do this, and why don't we do that? So with that, let's get into what is a monolith. So Azure an application where a huge application where you have user interface, backend APIs, and we have message consumption is happening, and you are eventing out something. So all these components are clubbed together into one big application, and we have one big database where you are end of the day you are exhibiting reports to someone to check it. So assume this application where you have. So you will be in a situation whenever you have a deployment, you'll be in nail-biting situation saying like, hey, whether it will be working if I deploy it, or whether it will be okay to have my time to be spent like 4 or 5 hours there and test it and everything is done. So we never know if it is a big application. So the main issues what we see with monoliths. So any application, why we do it for customers, like where customers can see it and customers can use it and customers can request some changes and where we can deliver it. With this big monolith, the major issues what you see is like, even though if users are looking for a small change, it may take months or weeks or months at least. So because like if you touch one of the component, let's say like there is a performance issue in the consumption of the messages. So you need to do a change in that module, and you need to test entire thing. So that's the issue. Let's say you have a big performance issue there, you want to improve the performance, but your application stack is a little behind. You want to upgrade the application stack. You cannot apply that or upgrade that only for that particular component. So you need to upgrade whole application, which is again a huge change what you need to go through. So all these things, like if you compare the business impact on this, technical challenges we have anyways because of the huge application, and we cannot deploy it without testing it fully, which will take a lot of time. Also the biggest issue what you see, like the monoliths can be on-prem or can be on the AWS. Let's talk about both the scenarios. If you have that in on-prem, so in case we have a huge performance issue, you want to scale it a little, you cannot do it on the fly because it's an on-prem. You need to physically wait for a person to come in, allocate a virtual machine and deploy all your changes out there and make sure it tests and everything is working fine or not. We never know like that. That's definitely a big rabbit hole to do it. And in case you have deployed your application into AWS, there will be a concept called cost, right? So let's say like current monolith application is taking $100 per hour. So if you want to replicate it, it will be $200. Though you have a performance issue in one of the component, which is a message consumption, you're trying to replicate whole system, and you try to buy a huge machine or compute machine where you have, and you're trying to duplicate it. So that's definitely scaling can be possible, but it's cost effective. It's cost effective? No, I don't think so. So that's main technical challenges what you see, and business impact you see, like as we discussed, like it will take a lot of time for delivering a small change to them, and it's a huge customer dissatisfaction what you will see. So for that, so instead of that is a slogan I've copied from Google somewhere. So organizations need agility, not just stability. So people say like, okay, let's say like I don't have any issues with the application. It's running from past 3 years. Yes, it is stable, but are we agile enough to make a new changes, new upgrades, new features added to it? Maybe not, because We are stable and we don't want to touch it. So with that, going to next slide for the solution. So as we discussed, like we have all the components where we discussed, right? Like we have user interface, APIs, consumption part, and the eventing part. So let's divide that into microservices, what it says. Like, so instead of having a big chunk of work, divide them into individual pieces where you can independently manage and deploy. So the major advantages of big one and a smaller chunk of ones, you may see like, oh, if I have 10 applications and I may need more people to manage. That's not true, because in huge application, what you have, you may have same number of people. So you can divide them and or you can reduce them to see like, okay, one person is for this service, one person is that service. So even then, even if you have more applications, the manpower might not go high. It will be still the same. You can convince your lead saying like, hey, that's not the case. So microservices is basically like having a smaller part of the functionality, making it as individual application on its own. So that's it for microservices, if you want to say. So it's just a small independent service which is focused on a specific business capabilities. Maybe it can be like interactive session, or which is using an API, or it's an async session where you have messages coming and processing it. So main characteristics, what you see, it's a key responsibility. So if we see the earlier case where we have a performance issue, right? So we have a performance issue on one of the queues where we are reading. I think that's what we discussed is. So instead of in this microservices case, if you have divided or decouple the application into small chunks of applications, so only we can go ahead and change the technology, or we can upgrade it, or we can scale it when needed instead of doing everything. Let's say earlier example, it's taking $100 per machine. Let's say like each, I mean, there are messaging component itself, if we ballpark it like $20. So previous case, if you want to scale it, scale it by one more, so it will be like $200. Now in this case, it's $20 more. That means like 100 plus $20, because other services which we are using, which are less used, or they may not be heavily loaded like the other components what we have. So in this way, so the manpower, we can have the same manpower coming and working on microservices, where you don't see a cost increase, as well as whenever you see the scalability and flexibility of development and deployment, we still have an advantage with microservices, where you don't need to duplicate everything, or you don't need to scale everything. You just need to scale that portion of the app where it is needed more resources. So that's it, like huge monolith to small microservices. It's maintenance easy and cost effectiveness. So also, like in case like microservices.
I'm really sorry to disturb. Your slides are not changing.
Oh, is that?
Yeah.
Can I share it again?
Yeah. Now it's moved to the solution microservices architecture.
Solution microservices. I don't know. Let me do one more way. I think I'm connected to monitors. Maybe it's connecting to different monitor and not showing. So let me present it now. Now you can able to see mine.
Yeah, I see it. You're on solution microservices architecture.
Yes.
Right?
Yeah.
Do you want to move to the next slide and check?
Yes. You can see it now.
It did not change.
Oh, do I need to?
So we don't see the full slideshow of your slides. We're still in your we're not in the presenter mode.
Let me do it. Let me see.
Maybe you want to change the screen. You want to make this as a presenter screen.
I just connected to laptop. So share my screen. I'll share my entire screen instead. That way. Okay. Hope this time it should solve.
Yeah.
Can you see my screen?
Oh yes. Oh yes. Now it works. Yeah. Hooray.
Hey. Yeah, I think my earlier demo, I was afraid because it's a technical demo, it might fail. That was success. It's a presentation, it got failed. Yeah. Yes. Let me resume where we left. So the big monolith to microservices, whenever we split it, so we still have advantages of reusing manpower. We have less cost, and moreover, like we don't need whenever we wrote those monoliths way back, right? You may have people who knows all the code. If they have left the team, And with this new microservice approach, the functionality has been reduced per application, then easy to learn, and we don't need the expertise who have initially developed the application. So that's one more advantages of having microservices, where you can have people changing so that they can improve their knowledge, and new people come in and learn it, and cost effectiveness, and so on and so forth. So let's go through. I mean, this is a monolith, and how we need to, why we need to go for microservices. Let's see, like, what is containerization? Containerization is a concept where you have application and related dependencies having merged together and have as one deployable component, and which you can give it to a orchestrator. Maybe like, I'm not talking much about orchestration here, like that's a separate topic. So I'll be only saying about containerization a little, where the containerization is packing everything and having one deployable component which is given to any of the orchestration engine like Kubernetes or Elastic Beanstalk, or if you want to talk about AWS. So you can give it to that, and we shall with the configuration saying like, okay, this is how you need to autoscale in case my CPU is going high, or in case CPU is going low, so increase it. What are the default systems which I need to have? And how many systems, I mean, I can go, how many instances I can go up, like what time. So all these configurations we can give, so where we can have a lot of scalability instead of wasting money on it. Like we can have a scalability to see like when we need, with that scalability option what we have, we can save the money too. So these are like how we can containerize and give it to orchestration to manage the scalability. And going to next slide. So microservices, they say like to have microservice, there is a 12 factor principles which we need to follow. So I'm not covering that. We just going to the core components, like whenever you do a microservices, how or what the components you want to have it. Like API gateway is one of the things where you have all the services or backend APIs or authentication can happen at one way, and service mesh is a security orchestration, I mean, security things which we can look at it, and container orchestration, I think we have seen it, and service discovery where you have DNS, where the load balancer is there, where it can look at your services and group them together as one. Configuration management, and I think Polyglot we just discussed. I think Sunny has told about something. So what's the relation between microservices, Polyglot, and the other one he said? So the earlier like monoliths, we can have only one database for the application, right? In this microservices way, you can divide all the databases, like whatever the database you want to use for any of the service, you can go and use it. That kind of polyglot what we are talking about here. Polyglot. So let's go on to next slide. What are design patterns? What we can do? Let's talk about one each due to interest of time. So reliability pattern, like circuit breaker, so which is a famous pattern wherever like you have orchestration of APIs in your application where you're calling. In case one of the API is down, you don't want to call it again and again because it will anyways fail. So you'll give it a pass, you will skip it, and it, whatever the, I mean, if you can skip it, you can skip it. If it is a blocker for you, you just block it there and come out. Same thing like the timeouts, which are interrelated. And coming to database management, as we were discussing Polyglot, like we can have one database per service. It can be anything. It can be MySQL, Postgres, or any other database, whatever you have. And CQRS method, like where you can have, as we were discussing about reporting, right? We can have one database for live transactions, another database for CQRS, where the reports may be pulling. It may not be real time. Maybe we can have a read replicas of the database so that like we don't have a full performance impact or the pressure on the original database, whatever we have. And deployment patterns, what we can see, it's a blue-green deployment where we have a zero downtime. Traditional method is we'll stop us undeploy a application and deploy application. Even then, if somebody hits through that application, we still might have a small downtime. Where in this blue-green deployment, you will entirely create one new environment for you, make sure it is up and running. After that, you just flip the DNS to active to inactive. That way, like you'll be having a 100% deployment strategy. I mean, 100% deployment out there. So we can have regular releases because of these microservices are so simple, and you don't need whole teams to be watch out from your shoulders to see like, hey, what is happening. It's a small scope of work which will be deploying. You can do it more regular intervals and also make users happy. And rolling updates, which is in line with what we're talking. And yes. So Uday said about monoliths are bad, and I'm happy, and we are all on microservices. Are we done? Are we good? Are we go to space right now to enjoy our life? Maybe not, because every technology which you see will have challenges and limitations. That doesn't mean you should not be implementing it. Let's take an example of monolith, which is as nature itself, it's very small. It's not a huge one. Those kind of microservices, you don't need to migrate to microservices. That itself is a small application. Maybe it may have, instead of 10-20 components, maybe 1 or 2 or 3 components out there which are easy to manage, easy to maintain, easy to upgrade. Then it is fine. And let's say like you have a big microservices, then big monolith, you should be doing technical strategy migration to microservice. Let's see like what are different challenges we have. So first we'll talk about organizational level challenges, where mainly the team structure. You may not have the team ready for implementing this because of lack of technical knowledge, or it may be a cultural shift. What we may be seeing, like some people are not happy to see a change, maybe I would say, or it may be cost associated with it, where initial days we might have both the systems up and running, right? The new system and the old system, maybe it's cost involved for managing a system, or hiring a new team which will be helping in this migration. That's organizational level challenges, what we have. And technical challenges, what we see is like, it's all like, if we have, we discussed about one to many, right? If we have many systems out there, how the data consistency should be managed, that's one challenge. And how the latencies we should be managing, service discoveries, and how we can test it, how we can debug it. We all have tools for this. It's not like if you have 10 applications out there, we cannot monitor them. We have dashboards, like we can create dashboards and New Relic, Datadog, Prometheus. We have all other sorts of things out there. So what you can do, though you have more applications, we don't need to worry about debugging or monitoring it. We have excellent tools available out there. Only challenge is we have to make sure we have enough capacity, technical knowledge of the team, and we have a good investment to go ahead. So if we have those two things, I think we can definitely make this challenge happen. So what should be our strategy towards it? You might have heard about strangler fit, which is a plant. What it happens is like it cannot live on its own. So we need to have that branch tied to another existing tree, where it will start growing and it will eventually kill, or I think it kills, which is bad. So the original tree will kill and have a new strangler fig grown. So this is a pattern which is a nature given pattern for microservices. You have a huge monolith. So what you do, you introduce a new microservices by detecting one of the component which we can be, or core functionality which can be migrated to microservices. Slowly we'll migrate one component after the other. We'll slowly make this legacy application vanish. That is a good strategy where we can go for, and where we can, with the small steps, we can have huge application formed into microservices. So it's not a one-day job or two-day job. It will take a lot of time for making a monolith to microservices. It depends on the situation of the application what you have. So with that, I'll introduce my new friend. So we might be hearing about AI these days a lot. Maybe at least if you're not hearing from a long time, at least from past 6 months or 1 year. So AI is doing a major role, or performing a major role in your organization in various ways. So I myself was doing R&D on AI capabilities on monoliths versus microservices. It is performing better in microservices because the scope of the application, or the functionality of the application, is so small. Not so small, considerably small when you compare to monoliths where you have huge things. So the setting up the context, or giving the memory of a huge monolith to a AI agent, or AI enabled like Copilot or Claude, or you name something else. So that one, the context, it will be huge to make it understand. So like it will get confused, and like AI is still in hallucination mode if you don't let it know properly. So it is going into a hallucination mode, and it's not giving us good results or good outputs as a developer, which we are looking for. So when you compare to microservices, as itself is a small application, when we compare to monoliths, so it's giving good results and it's fast and it's performing well. So hope you guys can start looking at migrating to microservices and try AI with it, which will give definitely a good advantages in the way you do development, testing, debugging, whatever you do today. So with that, thanks for attending this session. Have a nice weekend. Happy Friday, everyone.
All right. That was very short and crisp. Thank you. Weekend's here, so we all want to wrap up very quickly. Right? Let's take a few questions, right? But we have got a few questions, right? There's one from Hemant is asking, how does team effectively handle distributed tracing and observability when a single user request might spam multiple containers and microservices? It's quite often the case.
Yeah, how distributed tracing and observability when single user request might span multiple containers. Yeah, we have this DNS, what we call about, right? The load balancer in between. So whenever in every application, like if you talk about basic like web applications will have a concept called sticky session. So most of the time, whatever we have, in case we want to have a statefulness managed, we'll enable the sticky session out there. Like most of the other APIs, what we generate mostly these days are stateless. So you don't really need to manage that tracing or observability. Like it'll just go one request per, it'll get the response and it'll end there. So it's mostly a stateless.
All right, let's take one more from Scott. Scott's want to know, how do you choose the boundary of for a microservice? Is there a common anti-pattern you see that makes a service too large or too small?
Yeah, this is a great question. I would say, like I myself, like I've seen a cases where sometimes due to laziness or cost, I would say like lazy pattern. One lazy pattern, I quite often see or hear is like we say like one service, one database. That's a pattern which we want to follow. Sometimes what we end up doing is like my database performance or the usage is very low, and I have one more service which want a new database instead of going for a new database. So we'll have two microservices calling to the same database. That will be definitely an anti-pattern where I think like that way we'll end up compromising ourselves in implementing anti-pattern, assuming the microservice is slow. We can do that, but it's not like no hard and fast rule, we should not be doing it, but we can. But the issue is with that, like in future, in case those services got a huge number of requests, then we might end up failing the other one. Still, we have that. We are not serving or defeating the purpose of microservice.
Perfect. Thank you. We'll take one final question that is coming from Rohit is asking, what are the key trade-offs between using a container orchestration platform like Kubernetes and a simple container approach like a Docker Compose?
Yeah, I would say like if you have a small applications, like we don't need to go to Kubernetes. Kubernetes is huge. Like we have in some applications we are using Elastic Beanstalk, which is in AWS, which is quite good in managing small applications. And Kubernetes is like a big orchestration engine where it can manage. Like I heard, like I haven't had a chance to work on them, but I heard like in Kubernetes, like we can have both on-prem and cloud orchestration, or the applications have orchestrated together. So I would say like Rohit, like if it is small application, I would say like if you want to go with smaller like Elastic Beanstalk like orchestration engine, what you have, which is given by your cloud provider, that should be good. Kubernetes is a little for little bigger versions, like where you have a retail platform like Macy's or Walmart or so, like where they'll have like huge orchestration happening. So for them, like Kubernetes should be a good option.
Got it. So I think that's all we can take the question today. Thank you so much for being a part of this conference. We also have a lot of other conferences, like AI Agents conference is also there. I think I don't know. I think you were there too. I don't know. I think I did. Did you submit a session? I think so you did.
Only for AI dev, I did submit a session. I might have. I was wherever I see AI, I thought like, okay, let me try it. So I think I have one more session coming up with the build a serverless team.
Oh, build
On
serverless, you know. Oh,
build
they're my very
serverless.
good friends.
So
Are you
yeah.
going for the in-person conference?
No, I mean I was supposed to Seattle, but
Yeah.
I think due to some conflict issues, sorry, the
Hmm.
what is this? I don't say it's a conflict. I got to know very late.
Yeah.
It was happening on Tuesday or Wednesday. I got to know on weekend, so I cannot book tickets and I cannot travel. So I said like, oh, I can't do it. Then I forgot his name. Alan. Alan has reached out to me saying like, hey, we missed you and we love to hear whatever you want to do. So I'm going with Build Serverless. I think it's on
Wow.
19th. 19th, and I'll try to share same AI agent session what we have in a little higher way of how we can use MCPs or how I'm just started building an agent for the demo. So I don't know that will work or not by then. So I'm just starting to build a agent like where it'll automatically read GitHub issues and it can implement the change and it can push it to GitHub.
Yeah, that's good. That's
So
very lovely, you
yeah.
know. And as you've started traveling for these conferences, you know, I would encourage you to submit your sessions for the European conference. You'll find a very stark difference between American conferences and European conferences. European conferences, you know, they're more like a festival. You know, it's like sometimes they
Yeah.
do olfactory, you know, in a milk
100%.
factory or somewhere, old railway
Oh,
stations. I often go
oh.
there,
I
so
don't
I
know. I
just
can travel.
there.
Yeah, I have one session, like one workshop I've agreed to do on this AI.
Mhm.
I forgot where it is. So it's somewhere in Europe, European country. So they have this. I've told you, like I'm writing papers, right? So
Hmm.
one of the conference paper, when I submitted them, they said like, "Oh, we missed the deadline for this, but your topics looks good. Is it okay if you do a workshop on this?" I said like, "Yeah, I
Yeah.
can do that." Maybe I'll need to wake up in middle of night to give them a demo. Maybe.
There's a lot of commitment, you know, there's a lot of commitment when you do this community event. So I won't take much of your time. Thank you so much. Let's stay in touch, right? It is always lovely to host you. Have a lovely
Thank you.
weekend ahead. And yeah, thank you so much once again.
Thank you. Thanks for the opportunity and thanks everyone. Hope I haven't wasted your 20 minutes or 30 minutes of time on
No
Friday.
way. No
Have a nice
way.
weekend.
All right. Yeah. Bye bye. All right, ladies and gentlemen, that was Uday for you wrapping up the software architecture conference. And now it is time, ladies and gentlemen. Can you believe it? We have completed 4 long days. You know, I still remember we rolled out about this conference in about February, right? And we received more than 150 submissions. I'll tell you that more than 150 speakers applied when we picked just about some 35 to 36 speakers and you know some 3-4 speakers that we always have from our community. Just about 40 speakers. We have speakers from TCS, Amazon, IBM, Nvidia, Google, Microsoft, you name it, right? I think we also had some speakers from JP Morgan and everything else. So it has been, I want to give a big shout out to all the speakers. Thank you so much for being a part of this conference. This was the 4th edition of software architecture. It's always, an honor and to host you all. Thank you so much for sharing your knowledge and your pearls of wisdom. I also want to give a shout out to the Sharp Economy for supporting this conference. All the ads and all that you see, that was actually from Sharp Economy. Go ahead and download it. You'll find the link in the YouTube description or Facebook or LinkedIn, wherever you're watching, and you can claim up to 200 tokens as a reward point. I also want to give a shout out to CSharpCorner, right? They are the organizer. So everything that you can think, this tool and website and everything, they have put up. So thanks to CHAPCorner for organizing that. And then I have uh, folks behind the team, right? Rohit is the one who has been doing all this social media. So if you have been tagged but on social media, it is Rohit who is doing it. All the graphics that you see, that's made by Rohit. Then we also have Bharat, all the changes on the website, that's made by Bharat. So if there's any mistake, I won't take the blame, just blame Bharat. And then I see some of the folks in the chats like Hemant and Sophia and all that. Thank you so much for all the help that you all have done. Finally, I want to make an announcement, ladies and gentlemen. I'm going to use this opportunity to announce the Software Architecture 2026. It's going to take place in the second week of August 2026, right? I hope that until then I can get some beard. I'll look maybe more mature. But yes, ladies and gentlemen, I wanted to take this opportunity to announce the the 5th edition of this software architecture conference. It's been a lovely time with you all. Thank you so much. This is your host Stephen Simon, signing out now. Going to see you next year, maybe on the other side. Take good care of yourself, and bye-bye.
What's that about?
Sharp reward. Never heard of it.
Let's look it up. Feels like free reward for walking. So this app tracks steps and gives you rewards?
Yep, every step adds up. And you can even spin a daily wheel.
That's actually fun. See, it tracks steps, shows balance, and has this spin wheel too.
Okay, fine. I'm downloading it. Sharp reward, right?
Told you, it's addictive.
I walk a lot. I deserve free reward.